Okay, so am I audible to you? Just check it out whether you can hear me, you can listen me. And thanks a lot for coming. And let's have a great session today. This, as you know, we are starting a new, type of domain now on YourPedia. We are starting intensive questions, entire subject question related, videos. And I'm very sure this is going to help you. So let me tell you in the beginning itself, for getting maximum benefit for class, what we need to do is we need to sit and ये notes I think सब लोगों के पास ये notes पहुंच गया होगा. We have provided this PDFs to you because when you have to do hundreds of questions, then questions should already be there with you. And your PDF पे till your GATE exam, mentors are going to provide you really good questions. और NPTEL बहुत बड़ा सोर्स है, उसमें बहुत अच्छे अच्छे क्वेश्चंस है. मेरे को लगता है कंसेप्ट हम वहां से अच्छा क्लियर कर सकते हैं. So you people are going to get questions and mentors are going to solve it. So 4-5 hours में पूरा सब्जेक्ट और अच्छे क्वेश्चंस आपको मिल जाएंगे. You have to note those questions carefully. And for just before exam you should do lot many questions. आपका प्रैक्टिस होना चाहिए, काफी अच्छे क्वेश्चंस आपके रिवीजन का उसमें प्रैक्टिस कर लें. एंड वी विल ट्राई अवर लेवल बेस्ट कि आप ज्यादा से ज्यादा हम लोग क्वेश्चन करवा पाए एंड सब्जेक्ट्स का रिवीजन करवा पाए. You need to be patient because it is going to take time. And today I'll be solving these questions, and for some questions Vishal sir will also join me today because it is going to be long class. So he will also be joining me today for handling some of the questions which are really good and they are from his domain. So I think now we started. So I'm very sure you people are ready with your pen and paper, pen and copies. So let's start it. Thanks a lot once again for joining me here. It is quite motivational, it is quite inspirational for me as a teacher when students are sitting there and they are attending the classes. That is the motivation for any teacher like me. So I'm really thankful to you for that, and I assure you this session is going to be worth spending your crucial time just before the GATE exam. So let us start it now. I welcome you to the very good subjects, that is thermodynamics. So जिन स्टूडेंट्स के पास ये नहीं है, शीट नहीं है क्वेश्चंस का, राइटिंग विल टेक लॉट ऑफ टाइम. तो आप पढ़ो बस और आप डाउनलोड कर लो वेबसाइट से. अपना ये जो पीडीएफ है इसका डाउनलोड कर लो. लिखने पे टाइम वेस्ट नहीं करेंगे. जिनके पास ऑलरेडी है वो उस क्वेश्चंस को देखते जाएं और हम सॉल्व करते जाएं. सो लेट मी रीड दिस फर्स्ट क्वेश्चन. आई स्टार्ट विद द फर्स्ट क्वेश्चन. Pressure cooker has the lid screwed on tight. A small opening jiska area is given 6 millimeter square is covered with petcock, that is some kind of fixer that can be lifted to let steam escape. How much mass should the petcock have to allow boiling at 130 degrees centigrade with an outside atmosphere at 100 kilopascal? Now you see, what you have to do is for every question you have to think how you will solve this. You have to think for a while how you will solve it. क्वेश्चन को एक दो बार पढ़ना है, सोचना है, फिर मैं उसका सॉल्यूशन दूंगा. एंड सेकंड थिंग इज एनपीटेल की असाइनमेंट में उन्होंने डाटा नहीं दिया है. प्रिज्यूमिंग के डाटा तुम खुद उठाओगे, जैसे स्टीम टेबल डाटा दे हैव नॉट प्रोवाइडेड, बट इन द एग्जाम ही विल प्रोवाइड यू दैट डाटा. So we need to simulate. I will provide you that data. So steam table informations were not provided on NPTEL, so they are not reflected in the questions. But I will give you those data. But questions are good, concept is good. So now in this question, if you see what he has given you, he has given you 100 kilopascal is basically the atmospheric pressure. That is what we know. And 130 degree centigrade उसने temperature दे रखा है. So let me give you some kind of diagram which you can make in your copy. Let me give you a small diagram here. Let us say this is the kind of mechanism which we have. Pressure cooker, and let us say this is the area, small a, and let's say capital A, that is 6 millimeter square is the area जो हमारे पास दे रखा है for this pressure cooker small opening. And this is a saturated pressure, that is what we know here. And this is a pressure cooker, and बाहर this is the lid, और बाहर जो है वो atmospheric pressure है हमारे पास. This is the atmospheric pressure which is outside. Now at T 130 degrees centigrade, T is equal to 130 degrees centigrade. what is saturated pressure. He has said that you are to basically at 130 degrees centigrade, this saturated pressure is 2.7028 bar. That is a saturated pressure corresponding to 130 डिग्री सेंटीग्रेड. तो जैसे मैंने आपको बताया वो डाटा आपको गेट एग्जाम में देगा, यहां पे डाटा नहीं दिया था बट वहां पे गेट एग्जाम में आपके पास डाटा रहेगा. एंड अब हमें फोर्स इक्विलिब्रियम देखना है. यहां पे 6 मिलीमीटर स्क्वायर, यहां पे प्रेशर पी सैचुरेटेड, डेल्टा पी कितना लगेगा? डेल्टा पी विल बी पी सैचुरेटेड माइनस पी एटमॉस्फेयर. अभी कितना होता है? एटमॉस्फेरिक प्रेशर इज 1 बार. Atmospheric pressure is 1 bar and saturated pressure corresponding to 130 degree centigrade. We have got that saturated pressure. So अब हमारे पास जो delta P into area is the basically force. Delta P into area is the force and that force is equal to weight of this particular small component which we are given. और वही हमसे पूछा है कि m कितना होगा. वी नीड टू फाइंड आउट व्हाट इज m. तो इसका अपना वेट नीचे की तरफ लगेगा और डेल्टा p इनटू एरिया ऊपर की तरफ फोर्स लगेगा. सो नाउ इफ वी सी वी आर टू फाइंड आउट द मास. सो व्हाट इज डेल्टा p? डेल्टा p इज 2.7028 माइनस 1 बार. बार तुम जानते हो इतने पास्कल के बराबर होता है. दैट इज द प्रेशर डिफरेंस. एरिया मिलीमीटर स्क्वायर में आपके पास दे रखा है. So area is 6 into 10 raised to power minus 6 मीटर स्क्वायर अगर आप उसको कन्वर्ट करना चाहें. और मास हमें फाइंड आउट करना है इन ग्राम. सो अगर तुम कैलकुलेट करोगे देन आई थिंक मास इज कमिंग आउट टू बी 102 ग्राम. दैट इज अ कंसेप्ट. कॉपी पे नोट करते जाओ क्या कंसेप्ट पे हमें क्वेश्चन पूछा गया था. सो दिस इज द कंसेप्ट व्हिच इज गिवन टू अस. अलाउ बॉइलिंग एट 130 डिग्री सेंटीग्रेड. तो मेरे को कैसे पता लगा कि ये सैचुरेटेड प्रेशर होगा? क्योंकि जब आपका बॉइलिंग होगा तो फेज चेंज होता है. बॉइलिंग इज अ फेज चेंज. ऑल ऑफ यू नो देयर इज अ इफ आई ड्रॉ अ डायग्राम दिस यू ऑल ऑफ यू आर अवेयर अबाउट दिस टीएस डायग्राम. तो ये जो आपका यहां से आपका वेट रीजन है, जब बॉइलिंग होता है तो आपका फेज चेंज नहीं होता. आपका बेसिकली जो फेज चेंज हो रहा है, सॉरी, फ्रॉम सैचुरेटेड लिक्विड टू सैचुरेटेड वेपर, वो आपका फेज चेंज रीजन है जिसमें प्रेशर एंड टेम्परेचर आपका कांस्टेंट रहता है. सो एट 130 डिग्री सेंटीग्रेड बॉइलिंग एट 130 डिग्री सेंटीग्रेड मींस आपके पास सैचुरेटेड प्रेशर है वहां पे. दिस इज P and T remain same. You know what is the meaning of saturated temperature? तो saturated temperature corresponding to pressure can be obtained from the steam table. तो 130 डिग्री सेंटीग्रेड पे हमें saturation pressure पता चल जाएगा या प्रेशर के ऊपर हमें सैचुरेटेड टेम्परेचर पता चलता है. दोनों डाटा हम ले सकते हैं. वी कैन टेक बोथ द डाटास. सो वी गॉट दैट इट इज बॉइलिंग. बिकॉज इट इज बॉइलिंग 130 डिग्री सेंटीग्रेड पे सैचुरेटेड प्रेशर वाज P saturated and atmospheric pressure is this. Always calculate delta T, delta P, sorry. So whenever piston cylinder mechanism is given to us, delta P is to be taken. Delta P means you need to take the pressure difference. Atmospheric pressure is 1 bar. Inside pressure he will give you is always a gauge pressure. You understand that? You need absolute pressure. So absolute minus atmospheric is the pressure difference. So always use pressure difference to calculate force on the piston. I hope this first question is clear to you. Let's proceed ahead with now second question. So we go to the second question now. This is the second question. Again, I want you to read it. Saturated water vapor at 200 kilopascal is in a constant pressure piston cylinder assembly. At this state, the piston is 0.1 meter from the cylinder bottom. How much is this distance if the temperature is changed to 200 degree centigrade? Read this question once again. There is a saturated water vapor at 200 kilopascal. Again, now he will provide you some data in this particular case. So there is a saturated water vapor which is in a constant pressure cylinder assembly and piston is at particular distance from cylinder bottom. If the temperature is changed to 200 degree centigrade, where will be the mechanism or this piston? So let me make the diagram. So this piston cylinder mechanism is given to us. Remember one thing, whenever piston cylinder mechanism is given to us, then The expansion process is isobaric, constant pressure heat addition. This is constant pressure heat addition. This is a closed system, control mass system, closed system, and constant pressure heat addition is the thing in this particular case. So what happens is saturated vapor at 200 kilopascal at pressure is equal to 200 kilopascal is basically constant pressure cylinder assembly. So piston is 0.1 meter from the bottom. So this is 0.1 meter initially. Now he's asking you how much will be the expansion if the temperature changes to 200 degrees centigrade. So T initial, T final is 200 degrees centigrade. Can you tell me what will be the T initial? What will be the initial temperature? Saturated water vapor at 200 kilopascal is in constant pressure cylinder assembly. So what will be the initial temperature? Now, what is the T saturated corresponding to 200 kilopascal? That is 120.21 degrees centigrade. So the saturated temperature corresponding to 200 kilopascal, which you will get from the stream table, he will give you in the GATE exam. Just now understand the concept. That is 120.21 degrees centigrade. So that is our initial temperature. So this is our initial temperature, saturated temperature. Because water is saturated. How do I know? Saturated water vapor at 200 kilopascal. So if I am to make the diagram, aisa diagram banega. Again, this is a wet region and this is 200 kilopascal. So what is the T saturated corresponding to 200 kilopascal? That is 200 kilopascal. So we know what is the temperature at 200 kilopascal saturated from the stream table. Now what is volume? Let's say the area of this piston is A. So volume कितना हो जाएगा? Volume is nothing but area into x. Let us say this distance we take is x. The distance we take is x. Now what is the initial volume? Initial volume V1 is A into x1. What is final volume? A into x2. A into x1 and A into x2. So initial volume is basically A into x1 and A into x2. Area remains same. Now because it is a constant pressure heat addition, P1 V1 by T1 is equal to P2 V2 by T2. It is a constant pressure heat addition because he has already mentioned constant pressure, but piston cylinder mechanism is also always a constant pressure. अगर यहाँ पे stopper लगा हो, if there is a stopper, then when the piston is on the stopper, it becomes constant volume heat addition. Remember this, GATE में दोनों ही टाइप के क्वेश्चन आते हैं. Piston cylinder mechanism, if the piston is floating, remember if piston is floating, it is constant pressure. But if piston is not floating, it is sitting on the stopper. If it is sitting on the stopper, it is constant volume heat addition. That you please note in your copy, and both the questions come. Now in this case it is floating piston, right? So pressure is constant. This goes down, area is same. So this is x1 over t1 is equal to x2 by t2. Now the student make a mistake. We have to find out x2, x1 into t2 by t1. Now what mistake student do? They put t1 t2 in degree centigrade. See, whenever t1 or t2 is to be put, it is to be put in Kelvin, unless until it is delta T. If it is delta T, whether you calculate delta T or difference in temperature in degree centigrade or Kelvin does not matter. But when it is to be used T, temperature is to be calculated, you need to basically use that in Kelvin. So let's put the values. X1 we already know 0.1. What is T2? 473.5. So that is 200 degrees centigrade in Kelvin is 473.5 and 393.36. That is T1. So that is saturated. Now you will say, sir, in this assignment saturated is steam information is not given, but in the GATE exam they will provide the information. So what is V2 coming? So x2 we will get as from here 0.12028 meter. Please note 0.12028. So answer will be D, 0.1220. Every question is a good concept. Please note that in your copy. You can directly get that question. Enjoy the concepts of NPTEL. They are really good. You know, as a teacher also we feel concepts are very good. and you should enjoy these concepts. Is this done? So what did we learn in this? We learned that there is something which is called saturation temperature and saturation pressure. Whenever the phase will change, boiling or phase will change, वो आपको एक चीज दे देगा, वो आपको प्रेशर दे देगा और टेम्परेचर पूछेगा, ये टेम्परेचर दे देगा तो आपसे प्रेशर पूछेगा, तो समथिंग ही विल गिव यू, and that information in GATE will be provided, and the moment we get that information, then he will give you, heat addition process or something. So if it is a piston cylinder mechanism, if it is a floating piston, then you are to consider constant pressure process. If it is a stopper, you are to consider constant volume process. Let's go forward now. We go to third question now. You are watching 100 question series. We reach third question, and I want you to basically focus on the question which is given. Read the question carefully. You need not to write the question. Question is already available on the website of YourPedia. Those of you who are not taken, they can take it. So read the question now. A 50 kilogram piston in a cylinder with a diameter of 100 millimeter is loaded with a linear spring and outside atmospheric pressure of 100 kilopascal as shown in the diagram. So see the mechanism here. उसने एक mechanism दे रखा है, यहाँ पे pressure is atmospheric pressure and there is a air. Spring exerts no force on piston when it is at the bottom of cylinder. This is very very important. ये line बहुत important है. When it is at the bottom of cylinder and for the state shown, pressure is 400 kilopascal with volume 0.4 liter. The valve is opened. अब ये valve हमने open कर दिया to let some air get inside it, causing the piston to rise 2 centimeter. Find the new pressure and you have to take G as 10 meter per second square. तो क्या क्वेश्चन दे रखा है? 50 किलोग्राम पिस्टन का अपना मास दे रखा है, तो पिस्टन का भी mg लगेगा. 50 किलोग्राम पिस्टन दे रखा है जिसका डायमीटर भी दे रखा है. So you are given the diameter, so you can calculate the area of the piston also. उसमें एक स्प्रिंग लगा हुआ है. Outside pressure is given as 100 kilopascal. This is 100 kilopascal. Spring exert no force on piston when it is at the bottom of cylinder. That means in the beginning this was the situation. In the beginning this was the situation. You need to understand like this. This was the situation in the beginning. पहले situation ये था. फिर क्या हुआ? ये ऊपर जाना स्टार्ट हुआ. This is the second stage. This is the first stage. First stage में piston is at the bottom, और जब piston bottom पे है, this is the free length of spring. Free length of spring. तो spring को compress नहीं किया था आपने. Spring was not compressed. In this case, the diagram which is given to you, in this case, spring is compressed. This is the diagram in which spring is compressed. And then, so then this is the second case. First case is free and second case is this. अभी हमें देखना है कि how much is the spring rise. How much is the spring rise? So let's take the two cases now. First, let's calculate the area of the piston. Pi d square by 4. D is 100 millimeter. Keep writing. तो स्प्रिंग का जो हमारे पास डायमीटर आ जाएगा, that is sorry एरिया आ जाएगा, that is 7.85 into 10 raised to power minus 3, 7.854 into 10 raised to minus 3 meter square. That is the area of the piston. That is area of the piston. Now in this particular case, now let us say this distance is x. यहां पे it is free expansion. Now ये ऊपर x चला गया. Let's make the force equilibrium in this particular case now. तीसरा केस एक और आएगा. इस केस में force equilibrium क्या होगा? Pressure is 400 kilopascal. He is saying 400 kilopascal. यहां पे बाहर कितना है? 100 kilopascal. तो डेल्टा P कितना आ गया? डेल्टा P is 400 minus 100 kilopascal. ये ऊपर की तरफ लगेगा. What is other force? Let me tell you, this is 300 into area. Pressure force is balanced by mg plus another is K into X1. Equation number 1, very, very important equation. See this carefully. In this particular case, pressure inside is 400 kilopascal. Pressure outside is 100 kilopascal. What is delta P? 300 kilopascal. Pressure force will act on the piston upward direction is equal to weight of the piston. Mass is given plus K into X. How much is X? Bottom से लेके यहां तक जो distance है that is X. K is the spring stiffness. So K into X. तो ये आपका पहला इक्वेशन आएगा, कॉपी पे लिख लो. इससे पहले पिस्टन नीचे था. When the piston was at the bottom, there was no compression in the spring. But when 400 kilopascal comes, there is a compression in the spring, which is X. And now this is the first equation. From where 300 came? 400 minus 100 into area of the piston is equal to weight of the piston plus compressive force of the this particular piston. Okay, now this is number 1. Now everything is known to us. Area we have calculated, M is given to us from here. Everything is known to us, and no, K and X1 is to be obtained. Now let us say another information is also given to us. What is this? This particular now volume is 0.4 liter. This is 0.4 liter. That is the volume given to us. You know what is the volume? Volume is 0.4 liter. Liter is 10 raised to power minus 3 meter cube, which is area into X1. Another very important information from where we can calculate what is X1. So this 0.4 liter is 0.4 into 10 to minus 3 is equal to area into X1. We are given that in this state pressure is 400 kilopascal and volume is 0.4 liter. अभी यहां से area हमें पता है, we have calculated. What is X1 coming? So please write in your copy. X1 is 0.0509 meter. That is the value of X1. So presently X1 is equal to this. So presently this is 0.0509 meter. That is X1, right? Now if we know X1, put the value of X1 here and spring constant will come out to be 36452.96 Newton per meter. So spring constant हमारे पास निकल आएगा इस इक्वेशन से. We got the value of X1, put X1 here, we got the spring constant as 36452.96 Newton per meter. That is the spring stiffness. That is what we have got, spring stiffness. Got it? This is a very, very good question. Really good question of NPTEL, just like the question you get in GATE. So let me revise. पहले क्या था? Spring was in unstretched position. Spring was in its free position, that was at the bottom. फिर वो x मीटर ऊपर चला गया. जब वो x मीटर ऊपर गया, अंदर प्रेशर आ गया 400 किलो पास्कल. यहां से एयर सप्लाई चल रहा है, 400 किलो पास्कल आ गया और x लेंथ ऊपर चला गया. इसका वॉल्यूम है आपका 0.4 लीटर. 0.4 लीटर से हमें x1 पता चल गया, एरिया इज गिवन टू अस. x1 पता चला गया तो हमारे पास यहाँ पे इक्वेशन लिखो, इक्वेशन ऑफ फोर्स इक्विलिब्रियम. सो वेट ऑफ द पिस्टन प्लस kx इज बैलेंस्ड बाय डेल्टा p इनटू योर एरिया. डेल्टा p इज इनसाइड प्रेशर माइनस आउटसाइड प्रेशर. अब क्या होता है? देयर इज अ थर्ड इक्वेशन नाउ. नाउ इट सेज piston goes 2 centimeter even further. Now let me give you third diagram here. अभी क्या हो गया? पिस्टन और ऊपर चला गया. See this carefully. Now piston has gone even further. This is the new situation now. Now what is this? X तो पहले ही था, X plus कुछ और चला गया X1 plus 0.02, 2 centimeter more. It has gone 2 centimeter more. Now we need to find out what is the situation here. This is the new situation now. Now this is the X1 plus 2 centimeter more, and now we want to find out what is the final pressure. Let's say final pressure is now P final. Outside is atmospheric pressure. So P final minus 100 kilopascal into area is equal to mg plus K into X1 plus 0.02. This is the second equation. अभी जहां पे x1 लिखा था वहां पे x1 प्लस 0.2 मीटर और आ जाएगा 0.02 मीटर, बिकॉज अभी स्प्रिंग को तुमने और कंप्रेस कर दिया. यू अंडरस्टैंड? तो स्प्रिंग पहले x1 कंप्रेस था, अभी x1 प्लस 0.02 कंप्रेस हो गया, and we want to find out what is the final pressure. Now all the things are known to us. X1 also we have calculated in the previous case, and K is also known, M is also known, area is also known. What is the pressure coming? That was the question. And answer for that, anybody has calculated answer for that? No, answer is 492.8. 492.8. A is the answer. 492.8 kilopascal. That is the answer for this. Believe me, these are really good questions. These are really good questions of NPTEL. That is what you are to revise at the time of exam now. This is what you have to revise. These are really very good questions of NPTEL. So today you are going for 100 question series of thermodynamics by YourPedia. Me and Vishal sir are going to take the questions. So majority questions I'm going to take, and then Vishal sir is also, yes. So somebody who has solved this question deserve to get really good score in GATE. Believe me that, because अगर आपने क्वेश्चन सॉल्व कर दिया तो आपको अच्छा स्कोर उसमें हिट होगा. You will get good in GATE, right? Okay, so if this is done, let's go for next question. आपको क्वेश्चन कॉपी पे नहीं लिखना है, आपको डाउनलोड करना है. आपको मिल जाएगा. You can download the question from YourPedia website. You can go on YourPedia website and you can download the questions. अभी इसको बस देखो, क्वेश्चन को समझो and try to solve these questions. A rigid tank whose volume is unknown is divided into two parts by a partition. So there is a partition and there is a rigid tank. Whenever he gives you rigid tank, so something should come to your mind that the rigid tank means the volume is not going to change. Volume is going to remain, overall volume is going to remain constant. जैसे मैंने आपको बताया था, floating piston cylinder means pressure is going to remain same. Piston on the stopper means volume is going to be constant. Rigid का भी मतलब होता है volume constant रहेगा. That is the meaning of it. So rigid tank whose volume is unknown, volume हमें पता नहीं है, उसको दो पार्ट में एक पार्टीशन ने डिवाइड किया है. वन साइड इज आइडियल गैस एट 927 डिग्री सेंटीग्रेड, अदर साइड इज इवैक्यूएटेड एंड हैज अ वॉल्यूम ट्वाइस द साइज ऑफ पार्ट विच इज कंटेनिंग द गैस. सो ये जो इवैक्यूएटेड है, दिस इज 2v1, दिस इज v1. अभी पार्टीशन को रिमूव कर दिया, वी रिमूव्ड द पार्टीशन एंड गैस एक्सपेंड्स टू फिल द एंटायर टैंक. अभी गैस एक्सपेंड कर गया पूरे टैंक पे, उसने एक्सपेंड कर दिया. हीट इज नाउ अप्लाइड टू द गैस. अभी देखो हीट हमने गैस को दिया अंटिल द प्रेशर इक्वल्स द इनिशियल प्रेशर. तो प्रेशर जो है वो अब इनिशियल प्रेशर के बराबर हो गया. प्रेशर इक्वल्स द इनिशियल प्रेशर. तो अगर मैं दो स्टेट्स लूं तो इनिशियल प्रेशर इज इक्वल टू फाइनल प्रेशर. अगर मैं दो स्टेट्स कंसीडर करूं तो इनिशियल प्रेशर विल बिकम इक्वल टू फाइनल प्रेशर. यू हैव टू डिटरमिन द फाइनल टेम्परेचर ऑफ द गैस. थिंक इट ऑफ, कैसे करेंगे. क्वेश्चन डिफिकल्ट नहीं है, आंसर चॉइस दे रखा है, एंड सोचो कैसे इस क्वेश्चन को करेंगे. क्वेश्चन इज नॉट डिफिकल्ट, इट इज गुड क्वेश्चन. जस्ट थिंक इट ऑफ हाउ यू विल सॉल्व दिस क्वेश्चन. यू नो समटाइम इट लुक्स लाइक क्वेश्चन बहुत ही टेढ़ा है, क्वेश्चन बहुत ही डिफिकल्ट है. डिफिकल्ट नहीं होता, क्वेश्चन बहुत आसान होता है. अब ध्यान से देखना. लेट्स टेक दिस एज अ मैटर. लेट्स दिस कंसीडर दिस एज अ मैटर. तो इसको इनिशियली क्या था, लेट्स से प्रेशर इज P1, लेट्स से वॉल्यूम इज V1 एंड मास इज M, कैरेक्टरिस्टिक गैस कांस्टेंट इज R एंड टेम्परेचर इज T1. ये मैंने किसका लिया, ये मैंने इस आइडियल गैस का लिया. आइडियल गैस इक्वेशन लगा सकते हैं. वी कैन टेक आइडियल गैस इक्वेशन. वी कैन टेक आइडियल गैस इक्वेशन. यस, आंसर इज करेक्ट. योर आंसर इज करेक्ट. सो आइडियल गैस हम ले सकते हैं. आइडियल गैस इज गिवन. अब सेकेंड स्टेज पे लेट्स से P2 V2 इज MR/T2. दैट इज अ फाइनल स्टेट. किसका, इसी का. अभी एक्सपेंड हो गया. फाइनल स्टेट इज P2 V2 इज इक्वल टू MR/T2. दैट इज अ फाइनल स्टेज. तो उसका फाइनल स्टेज आ गया. अभी क्योंकि मास सेम है, गैस सेम है, तो दीज टू थिंग्स आर सेम. ना तो मैंने मास चेंज किया, ना मैंने गैस चेंज किया, तो मास और R सेम रहेगा. M एंड R इज गोइंग टू बी सेम. सो दैट इज बेसिकली इज गोइंग टू बी सेम. एंड बोलता मैंने हीट सप्लाई किया तो प्रेशर भी सेम है. जितना प्रेशर पहले था, प्रेशर अभी भी उतना ही है इस गैस का. आई एम यूजिंग आइडियल गैस इक्वेशन ऑन दिस गैस, यहां पे तो कुछ है ही नहीं, आई एम यूजिंग आइडियल गैस इक्वेशन ऑन दिस आइडियल गैस which is given to us. So उसका initial pressure is P1, final pressure is also P2 given to us. अब what we want to find out is final temperature. So T2 by T1 is equal to V2 by V1. T2 by T1 is equal to V2 by V1. Now what is V2 by V1? What he has given, initial volume was V1, अभी total volume कितना हो गया, V1 plus 2V1 is 3V1. So the volume has increased to 3 times. So V2 is equal to 3 times V1. ये कैसे पता लगा, V1 and 2V1 if you add total, now this gas is going to get into entire, this particular entire container, so this will have 3 times the volume. So T2 will also be 3 times T1. अब मैंने आपको बताया था कि इसको केल्विन में डालना है. व्हाट इज द टेम्परेचर गिवन, T1 is 927 plus 273, तो कितना हो गया 1200 केल्विन इफ आई एम नॉट रॉन्ग, तो दिस इज 1200 केल्विन. सो 1200 केल्विन मींस T2 कितना हो गया तुम्हारा 3600 केल्विन, लेकिन आंसर डिग्री सेंटीग्रेड में है, तो इट इज 3600 माइनस 273.15, तो 273.15 आप करके, दैट इज हाउ दिस आंसर हैज कम अप. सो यू कैन सॉल्व दिस पर्टिकुलर आंसर, राइट. Okay, is this clear to all of us? That was question number 4. So please pick up the small hint given in the question until pressure becomes equal to initial pressure. तो ऐसा जो hint देगा, you need to pick up those hints and solve the question. Number 2, if it looks like some question is difficult, ऐसा लगे तुम्हें question difficult है, तो don't assume it to be difficult, may be very simple, and vice versa. Sometimes you will find that question looks very simple, it may be difficult question. So that is what you have to use your mind, whether you want to solve that question or not. Let's go for this next question. Do not write any question in your copy. You can download the notes provided by YourPedia Education. You need not to write in your copy. These are the really good questions which mentors have taken from YourPedia. So that is what we are to do it. Yes. So how much heat is supplied? MCP, MCDT. No, because we need to see there that is a constant basically pressure process he is given. From there we can think of if temperature we get initial and final, we can calculate that. Now read this question. Following expression to calculate the work done by simple compressible substance. Consider the following expressions. First is dW is equal to PdV, that is the first thing. Second is dW is equal to F resistance into dx. F resistance is the force resisting the movement of the system boundary, and dx is the differential displacement of the system boundary in the direction of force. पढ़ो उसको ध्यान से. And उसने आंसर चॉइस बना रखा है, which one among the following statements regarding applicability of the above equation is are true. Just go for the answer. बताओ क्या आंसर इसमें हिट करेंगे. What will be the answer for this? So yes, you can take multiple statement MSQ also, multiple statement type also you can take. Multiple statement का concept NPTEL से ही आया है, because professor used to give that kind of assignment, multiple statement assignments, वहीं से ये concept आया है. Okay, so read this question carefully and you will understand that question may be ticklish in GATE. It may not be that simple. Question may be ticklish in the GATE. You may feel it is simple, it may not be simple. So try to answer this question. Consider the following expressions to calculate work done by a simple compressible substance. dW is equal to PdV. dW is equal to PdV. Which among the following statements regarding applicability of the above equation? So PdV is applicable only for system undergoing quasi-equilibrium process. That means reversible process. Let me tell you, this statement number A is not correct. Maximum of you are saying it is correct. It is not correct. Let me tell you, this statement is not correct, and that is the most important part. That is the most important part I want to discuss with you. Now, one answer which you are giving is partially correct. So the answer to this question is D. See this carefully. Answer to this question is D. A is not correct. Why A is not correct? I'm going to explain it, but A is not correct. D is the right answer. Okay, listen now carefully. Okay, so this F into dx can be true for, that's a general formula, general expression for force. If somebody asks you, भाई force कैसे निकालते हैं सर, सॉरी वर्क कैसे निकालते हैं सर, वर्क निकालते हैं force into distance. ये तो mechanics का formula है. This formula is of the mechanics. So this statement W is equal to F into dx is true whether system is going for reversible or irreversible process, equilibrium or non-equilibrium process. That is not a problem. So quasi equilibrium means a reversible process, very slow process where every state is in equilibrium, with the adjacent state. That is the meaning of quasi equilibrium. So quasi equilibrium का मतलब क्या है? Almost reversible state. That is the meaning of it. Many of you are wondering what is the quasi equilibrium. Quasi equilibrium means reversible. तो ये general formula है. Work is equal to force into distance is a general formula. जनरल फॉर्मूला है तो वो यार वो क्वासी इक्विलिब्रियम के लिए भी होगा, नॉन इक्विलिब्रियम के लिए भी होगा. नाउ लिसन केयरफुली. नाउ लिसन दिस केयरफुली. व्हाट इज द मीनिंग ऑफ दिस स्टेटमेंट, व्हाई दिस स्टेटमेंट इज रॉन्ग? लिसन दिस केयरफुली. Many students think that PDV is always a work. Let me tell you, PDV may be a work, it may not be a work. It may be just multiple of one thermodynamic property with the difference of another thermodynamic property. Pressure is a thermodynamic property. dV is the change in volume. It may be P into difference in volume, P into change in volume. It may not be work. I give you example. Suppose you take a nozzle. I give you a nozzle. Tell me one thing. Don't you observe dP here and don't you observe V dot here? I'm just giving you example. अगर तुम नोजल में फ्लूइड फ्लो ले लो तो उसमें प्रेशर ग्रेडियंट आता है, डीपी आता है, उसके अंदर डीपी होता है और उसके अंदर वॉल्यूम फ्लो रेट भी होता है, वी डॉट भी होता है. नाउ माय क्वेश्चन टू यू इज, इफ आई गिव यू दिस नोजल इन विच फ्लूइड इज फ्लोइंग, discharge is V dot, let us say, so V dot dP, will you call it a work or not? Will you call it work? And if you call it work, you will say this is a reversible work, but you also know this is not the device. Nozzle is not the device in which you get work. उसके लिए तुम्हारे पास टर्बाइन होना चाहिए, उसके ब्लेड होने चाहिए, ब्लेड मूव करने चाहिए, तभी तो वर्क मिलता है. So many students think that VDP is a non-flow work, VDP is a flow work, and PDV is a non-flow work, PDV is a displacement work, PDV is a piston cylinder work. Actually, PDV may be work, it may not be work. Now, PDV can become work only if you have device for that. And what is the device? We need, sir, piston cylinder mechanism. We need a piston cylinder mechanism in which piston is moving at very slow pace. It is infinitesimally slowly it is moving. Very slow expansion or compression is taking place. Then only PDV will give you work. So let me tell you one thing here. VDP may be work, it may not be work. If VDP is a work, you need to have a mechanism for that. And the mechanism is piston cylinder mechanism. And that also you need to move it very slowly. Then only it will become what you have written as reversible process. So to get PDV as a reversible work, you need to first have a piston cylinder mechanism, then you need to move it very slowly. Then only PDV will be a closed system, non-flow, displacement, reversible displacement work. So sir, if I am giving you P into dV, it can be there. Yes, it can be there. There can be a pressure and then there can be some kind of volume displacement. So that can be there, because if I give you free expansion, now see this carefully. If I give you a free expansion, there is a pressure और मैंने इसको free expansion कर दिया, मैंने इसको boundary को rupture कर दिया, तो I am getting dV also. I am having P also. पिछला question आपने किया. In the previous question, pressure was constant because I was supplying heat energy from outside. Pressure was constant and there was dV also. There was P, there was a dV. So पिछले question में work था क्या? I asked you that question. In the previous question which we just now did, just see this question. in this question, if I ask you, in this question there is a P1 is equal to P2, so pressure is constant, initial and final. There's a dV also, final volume is 3V, initial volume is V, there's a dV also. So you have P, you have 3V, you have PdV, but do you think that is a work? Actually that is not a work. Why? Because there is no mechanism, through which we can get PdV work. So now let's conclude. Sir, PdV, if it is a work, it is always reversible. It is used for closed system. So number, if PdV is a work, it is for closed system, it is basically reversible work. That is true. Similarly, if minus VdP is a work, it is for flow system, and this is also reversible. But suppose he gives you some term called PdV, it may be work, it may not be work. So that is what you need to understand always. So in this case, he was not telling you that whether it is a work or something, so that term is not given, and hence we cannot be sure whether it is a work or not. So answer to this question is only D. A is not a correct statement here. A is not a correct statement here. Yes. So there was a PdV in the previous question, but that was not a work. Let's go to next question now. Read this question again carefully now. Read this question number 6. You are watching 100 question thermodynamic series, and at the end of the session, you will be knowing many concepts in thermodynamics. I am very sure many concepts are going to come in the actual exam, and the kind of encouraging response which you people have given, I'm sure we are going to conduct many classes. We are going to give you the assignments, questions, and many concepts will be clear. The morale of the mentors of YourPedia will be high, and they will serve you better. That is there. So let's read this question now. Which of the following statement is true? Please answer. Amount of work done during quasi-equilibrium process. Quasi-equilibrium process means what? That simply means आपका reversible process between two given states does not depend on path followed in going from initial state to final state. Amount of work done during quasi-equilibrium process between two given states also depends on path followed in going from initial state to final state. So read these statements and tell me what is your answer. I want you to write your answer here. And remember, this question can be MSQ, multiple statement questions. It can be true. It can be MSQ also. It can be MSQ. So give me your answer. I am waiting for your answer. I am waiting for your answer. Please give your answer to this. Give your answer MSQ. You should not spend more than 1 or 2 minutes for answering these questions. These questions are simple, but at the same time, they can be ticklish. So try to provide the answer for this. Okay, now let me tell you, answer for this is B and C. The correct statement is B and C. Now what is the meaning of it? The amount of work done is a path function. It is a path function. Yeah, it is a process function. And volume is a point function. It is a state property, is a thermodynamic property. Let me give you the diagram of a cycle now. This is the Otto cycle. 1, 2, 3, 4. This is the Otto cycle. PV diagram of Otto cycle. Now I ask you simple question. Now this entire cycle is a reversible cycle. So this is the reversible process. There are 4 reversible processes. 1 to 2 is isentropic compression. 2 to 3 is isochoric heat addition. 3 to 4 is isentropic expansion. Now, if I give you on PV diagram isothermal process, or if I give you on PV diagram isentropic process, so don't you think for these two reversible processes work is calculated differently? So even if the process is reversible, isothermal, isentropic, koi bhi process ho reversible, whenever you want to calculate work done, you need to see what process is that, because work is a path function. But when we come to properties, when we come to properties like volume, pressure, temperature, internal energy, these do not depend upon the path. These only depend upon the initial and final state. Let me ask you a question. What is the internal energy change? What is the internal energy change for isochoric process? Ideal gas. Internal energy change for isochoric process, mcv delta T. Internal energy change for isobaric process, mcp delta T. Internal energy change for isentropic process, mcp dt. mcv dt. So that means whether process is isochoric, or the process is isobaric, or the process is isentropic, or the process is polytropic, the formula of internal energy change is same, mcv delta T. Why? Because internal energy is a thermodynamic property, it is a point function. So जब भी तुम्हारे पास पॉइंट फंक्शन आएगा वो पाथ पे डिपेंड नहीं करता, और जब भी तुम्हारे पास पाथ फंक्शन आएगा वो पाथ पे डिपेंड करता है. सो अब यहां पे आ जाओ वापस. चॉइस बी में बोला था अमाउंट ऑफ वर्क डन ड्यूरिंग रिवर्सिबल प्रोसेस बिटवीन टू स्टेट्स also depends upon path followed in going from initial to final. बिल्कुल सही बात है, because work is path function, and see, volume is a point function, it does not depend upon the path. So I hope it is clear to all of us. Point function, path function. Okay, so that is how it goes. Let's go to next question now. Let's go to this question. इस क्वेश्चन को देखो जरा क्या है. बहुत अच्छा क्वेश्चन ऑफ NPTEL. वेरी गुड क्वेश्चन फ्रॉम द असाइनमेंट ऑफ NPTEL. ट्राई टू सॉल्व इट. और देखो ये क्लास जो तुम्हारी चलेगी अभी, ये क्लासेस तुम्हारी सेल्फ एक्सप्लोरेटरी हैं, मतलब तुम्हें साथ साथ करना है. अपना भी नॉलेज चेक करते जाओ तुम लोगों ने कैसे किया है, हाउ यू पीपल आर प्रिपेयरिंग. एग्जाम इज कमिंग नाउ, वेरी लेस टाइम इज लेफ्ट. सो एट द एंड ऑफ द क्लास 100 क्वेश्चन तुम्हारे पास होने चाहिए, और 100 क्वेश्चन के कंसेप्ट भी तुम्हें समझ आने चाहिए, और तुम्हें साथ साथ प्रैक्टिस भी करनी है. कैलकुलेटर लो, पेन लो और सॉल्व करो, बिकॉज इफ यू सॉल्व अलोंग विद मी वी विल फील मोटिवेटेड. तो सॉल्व करो इनको, किस तरीके से करेंगे. ओके. आइडियल गैस गोज थ्रू एक्सपेंशन प्रोसेस in which the volume doubles. The process will lead to larger work output. An isothermal process or a polytropic process with exponent 1.25. Yes. What is the answer for this? Which process will lead to a larger work output? अभी क्या क्वेश्चन है ये क्या क्वेश्चन है? लेट मी टेल यू द कंसेप्ट बिहाइंड दिस. अभी पीवी डायग्राम तुम लोगों ने किया है, पीवी डायग्राम, स्पेसिफिक वॉल्यूम प्रेशर डायग्राम. देखो सारी प्रोसेसेस को मैं इस तरीके से शो कर सकता हूं. I can show all the processes on PV diagram like this. ये जो आपका फोर्थ क्वाड्रेंट है, this is expansion. Fourth quadrant is expansion. What is the meaning of expansion? Sir, pressure is decreasing, volume is increasing. And second quadrant is compression. Second quadrant is compression. This line is isobaric. This line is isochoric. Now, any process can be represented as reversible process as polytropic process, where small n is the polytropic index. अब अगर मैं n को 0 कर दूं, तो बन जाएगा P is equal to constant, isobaric process. अगर मैं n को 1 कर दूं तो बन जाएगा temperature is equal to constant. n अगर 1 कर दूं तो PV is equal to constant, PV is equal to MRT. तो PV constant means T constant. अगर मैं n को गामा कर दूं तो बन जाएगा आपका आइसेंट्रोपिक प्रोसेस. गामा फॉर एयर इज 1.4. अभी कोई भी और वैल्यू n का लिया जा सकता है. इस केस में उसने आपको n इज गिवन एज PV 1.25 इज इक्वल टू कांस्टेंट. उसने ये प्रोसेस दे दी. अब n की वैल्यू इंक्रीज होती जाती है और आइसोकोरिक प्रोसेस के लिए n का वैल्यू होता है इनफाइनाइट। अभी सर ये इनफाइनाइट कहां से आ गया? इसके लिए आपको चलना पड़ेगा इसकी स्लोप के लिए। व्हेन यू कैलकुलेट द स्लोप ऑफ दिस, log of p प्लस n log of v इज इक्वल टू log of कांस्टेंट। अभी डिफरेंशिएशन लो, dp by p प्लस n dv by v इज इक्वल टू 0। तो dp by dv कितना आ जाता है? माइनस एन पी ओवर वी। अब ये क्या है dp by dv? ये स्लोप है पीवी डायग्राम का। dp by dv is the slope of pv diagram. Now tell me which line has a slope infinite? Which line has infinity slope? Isochoric. So this left hand side is infinite. Neither p is infinite nor v is infinite. So that means n has to be infinity for isochoric process. Now see this carefully. N on the horizontal line is 0, on the vertical line approaches infinity. That means if you want to draw any line on PV diagram, then n increases like this in the expansion quadrant and it increases like this in the compression quadrant. Now if somebody asks us to plot the isothermal process for which n is 1, then isothermal process will be like this and PV raised to power 1.25 line will be like this. Clear? Everybody got it? So this is isothermal process and this is PV raised to power 1.25 is equal to constant. These two processes are like that. Now see the question. He has given you one isothermal process and another he has given you is polytropic process. Now tell me, under which process you get more area? If you plot it on x-axis and calculate PDV work, on which process you get more area? So more area is obtained on isothermal process and hence work done under isothermal process will be more. That is how you can analyze this particular process. So volume doubles. Why sir we are calculating PDV work only? Why not VDP work? भाई VDP पे तो निकाला जा सकता था ना, प्रेशर एक्सिस पे निकाला जा सकता था, बट वॉल्यूम इज चेंजिंग। सो वॉल्यूम जब चेंज होता है तो पीडीवी वर्क निकालते हैं, राइट? सो दैट इज द मीनिंग ऑफ इट। सो वी गेट मोर आइसोथर्मल वर्क। दिस इज हाउ वी नीड टू अंडरस्टैंड द क्वेश्चन। आई एम श्योर दिस क्वेश्चन इज क्लियर टू यू और आपको कुछ कंसेप्ट भी पता चले इसके अंदर। दिस क्वेश्चन वाज रियली गुड क्वेश्चन। अगले दो क्वेश्चन आपकी चेक करने के लिए दे रहा हूं, आपका लेवल कहां है। अगर अगले दो क्वेश्चन तुमने निकाल लिए विद इन 4-5 मिनट्स तो तुम्हारा लेवल बहुत अच्छा है। लिसन टू मी केयरफुली। अगले दो क्वेश्चन गेट के बहुत ही अच्छे क्वेश्चन है एनपीटेल के, और अगर तुमने वो दो क्वेश्चन निकाल लिए अगले दो क्वेश्चन, दैट मींस यू आर गोइंग टू हिट अ रियली गुड स्कोर, राइट? सो लेट मी गिव यू नेक्स्ट टू क्वेश्चंस। आर यू रेडी फॉर नेक्स्ट टू क्वेश्चंस? Here are the two questions and you have to calculate these two questions within 5 minutes. 5 मिनट का तुम्हें टाइम दे रहा हूं ये दो क्वेश्चन निकालने के लिए, 5 minutes. And if you hit these two questions within 5 minutes, your gate level of preparation is good. So try to solve these two questions. These two questions come on your screen. Try to solve this question within next 5 minutes. See what is the answer coming for this. What? So you are given a balloon which is behaving that pressure inside is proportional to diameter square. तो प्रेशर और डायमीटर का रिलेशन उसने आपको दिया है, उसने प्रेशर और डायमीटर का आपको रिलेशन दिया है। प्रेशर इज प्रोपोर्शनल टू डायमीटर स्क्वायर और इट कंटेन्स 2 किलोग्राम ऑफ वाटर एट 150 किलो पास्कल विद 85% क्वालिटी and balloon and water are now heated so that a pressure of 600 kilopascal is reached. See, whatever value they have provided, I have given you. So I think for second question you need some values, but first question you can solve. So anyhow, those of you who have solved the first part, that is really good. Those of you who have provided the first part, that is really good. So let me solve this question for you now. Let me solve this question for you. अब इस क्वेश्चन को देखो जरा क्या है. Pressure is given as proportional to diameter square, that is given to us. इसका मतलब क्या हो जाएगा, P2 by P1 is equal to D2 by D1 whole square. P2 by P1 is equal to D2 by D1 whole square. अब final pressure is also given to us, initial pressure is also given to us. So final is 600, initial is 150, that is D2 by D1 square is equal to this. So that is 4. So D2 is 2 times D1. So everybody gets this, D2 is equal to 2 D1. तो D2 हमारे पास हो गया डबल द डायमीटर. अब मेरे को ये बताओ, बैलून दे रखा है यार तुम्हारे पास. बैलून मींस क्या होता है? बैलून स्फेरिकल बॉडी मानी जा सकती है, और उसका अगर डायमीटर d है, रेडियस अगर r है, तो तुम्हें पता है वॉल्यूम इज 4/3 पाई r क्यूब. एंड if I write it in the form of diameter, then it becomes pi d cube by 6. So the volume is pi d cube by 6. लिखते जाओ, volume is pi d cube by 6. Now volume is proportional to diameter cube. तो यहां पे अगर देखेंगे V2 will be equal to क्यूब अगर कर दें तो 8 times V1. ये भी लिख लो कॉपी में. If diameter is double, तो volume is 8 times क्यूब हो जाएगा. So if volume is basically 8 times of initial volume, now I can manipulate this particular thing, and this gives me diameter is proportional to V raised to power 1/3, because we want to get answer in that form. So D is equal to constant V raised to power 1/3. D is some constant into V raised to power 1/3, right? अब यहां पे आ जाओ, come to this particular part now. P is proportional to diameter square, and diameter square is proportional to constant V raised to power 2/3. कांस्टेंट का स्क्वायर भी कर दोगे तो कांस्टेंट ही रहेगा. सो डायमीटर इज प्रोपोर्शनल टू V raised to power 1/3. सो डायमीटर स्क्वायर इज प्रोपोर्शनल टू V raised to power 2/3. तो यहां पे ले आओ, P इज प्रोपोर्शनल टू वॉल्यूम रेज्ड टू पावर 2/3. तो क्या हो जाएगा, P इज इक्वल टू कांस्टेंट इनटू V raised to power 2/3. तो अगर हम उसको एक तरफ ले आए तो दिस विल बी P इंटू V raised to power -2/3 is equal to constant. तो पहले क्वेश्चन का आंसर है B. फर्स्ट क्वेश्चन आंसर इज B. So the answer to first question is B. P into V raised to power -2/3 is constant. पहला क्वेश्चन निकल गया तुम लोगों का. तो this is a good question for first part. लिख लो इसको कॉपी में. And as I am telling you again and again, you need not to write the question, just write the answers. क्वेश्चन का नंबर लिखो, आंसर लिखो. असाइनमेंट्स तुम्हें मिल जाएगा YourPedia से, that is not a worry. You can download the assignment from the website of YourPedia. 100 question thermodynamics, all NPTEL questions. अब चलते हैं दूसरे क्वेश्चन की तरफ. Now read the second question. Considering the water as control mass, find the amount of work done in this process. अब उसने तुम्हें देखो ये टर्म भी दे रखा है, तो डाटा मैंने तुम्हें पहले ही बता दिया था इन द बिगिनिंग कि डाटा उसने तुम्हें दिया नहीं है इसमें NPTEL असाइनमेंट में, क्योंकि ये असाइनमेंट्स तो करनी होती हैं स्टूडेंट्स ने, उनके पास टीम टेबल होता है, लेकिन गेट में वो तुम्हें डाटा देगा. वो डाटा मैं तुम्हें प्रोवाइड कर रहा हूं. सो लेट्स गो फॉर नाउ सेकंड पार्ट ऑफ दिस क्वेश्चन. सो सेकंड पार्ट ऑफ द क्वेश्चन वाज रिलेटेड टू दिस. अब सेकंड पार्ट में देखो क्या दे रखा है हमारे पास. कंसीडरिंग वाटर एज कंट्रोल मास, फाइंड द अमाउंट ऑफ वर्क डन. अब P1 हमारे पास दे रखा है 150 किलो पास्कल. ड्राइनेस फ्रैक्शन हमारे पास दे रखा है 0.85. दैट इज अ ड्राइनेस फ्रैक्शन गिवन टू अस. नाउ एट दिस पर्टिकुलर प्रेशर, तुम लोगों को ये डायग्राम, टीएस डायग्राम अगर मैं तुम्हें दूं, यू नो द मीनिंग ऑफ दिस. तो ये आपका 150 किलो पास्कल पे मेरे पास ये सैचुरेटेड वेपर एंड सैचुरेटेड लिक्विड स्टेट्स के सारा डाटा मिल जाएगा. I can even get what is T saturated, and this is given to us as dryness fraction also 0.85. Now let me give you some values. Specific volume V in saturated liquid region is 0.00100527. Saturated वेपर में स्पेसिफिक वॉल्यूम इज 1.1593 मीटर क्यूब पर केजी, मीटर क्यूब पर केजी. तो मैंने आपको जी वैल्यू एंड एफ वैल्यू का डाटा दिया फॉर स्पेसिफिक वॉल्यूम. दिस इज व्हाट इज गिवन टू अस. Now dryness fraction is also given to us. So can you identify state 1? So V1 is equal to Vf plus x times Vg minus Vf. You know this formula? You know how to find out particular state? तो हमारे पास स्टेट 1 के ऊपर कितना स्पेसिफिक वॉल्यूम आएगा, we can calculate that. So specific volume at state 1 is equal to this. Now if I want to find out total volume V1, that is equal to mass into specific volume which I have calculated at this state, that is the total volume. Let me give you the value of total volume, that is equal to 1.97112 meter cube. दोबारा देख लो ध्यान से कैसे किया. So we are given 150 kilopascal, mass is given 2 kilogram. Now at 150 kilopascal we can calculate what is the saturated liquid state and saturated vapor state. Specific volume I can calculate, dryness fraction is given, I can calculate state 1, and I can also calculate the volume corresponding to this state 1. हम लोग ये भी निकाल सकते हैं, right? Now we want to find out the work done. We want to find out the work done. What is work? Sir, PdV इंटीग्रेशन 1 to 2. हमें फाइनल प्रेशर 600 kilopascal तक जाना है. Let's see how we go that. Now what is pressure? Sir, pressure is given as C into V raised to power 2 by 3 dV. लिखते जाओ. So pressure is constant into V raised to power 2 by 3. I am sure you people are writing in your copy. हमें निकालना है amount of work done. Work done is equal to PdV. So I take it from initial to final. उसने बोला टेक द वाटर एज अ कंट्रोल मास. पीडीवी कंट्रोल मास के लिए निकालते हैं, कंट्रोल वॉल्यूम के लिए वीडीपी निकालते हैं. सो अगर वो कंट्रोल मास के लिए वर्क निकालने को बोलेगा तो फॉर कंट्रोल मास वर्क इज पीडीवी, कंट्रोल वॉल्यूम वर्क इज वीडीपी. रिमेंबर दैट. दिस इज वेरी वेरी इंपॉर्टेंट फॉर you to calculate. Okay, let's see how do we calculate it. So अब इसको निकालेंगे तो कितना आ जाएगा. कांस्टेंट क्या है? कांस्टेंट की वैल्यू आपने ऑलरेडी निकाला हुआ है. सो कांस्टेंट इज बेसिकली P V raised to power 2 by 3 P V raised to power P is equal to V constant V raised to power 2 by 3. So what is constant? Sir, PV raised to power minus 2 by 3. That is the value of constant. Copy में लिख लो. It can be P1 V1 or it can be P2 V2 raised to power minus 2 by 3. So what is constant? Constant is P into V raised to power minus 2 by 3, whether at state 1 or at state 2. Right? So this is this. So I take now this outside. It becomes C V raised to power 5 by 3 over 5 by 3 1 to 2. Write in your copy. So C into V raised to power 5 by 3 over 5 by 3. So how to integrate it further now? C into V2 raised to power 5 by 3 minus V1 raised to power 5 by 3 divided by 5 by 3. लिखते जाओ. Now I multiply inside. I multiply this inside 3 by 5 C into V2 raised to power 5 by 3 minus C into V1 raised to power 5 by 3. लिखते जाओ. Keep writing. C into V2 raised to power 5 by 3 minus C into V1 raised to power 5 by 3. Now see carefully what is C into V2 raised to power 5 by 3. So I can put this value of C here and I can put this value of C at this point. You know that. Just tell me what is P1 V1 raised to power minus 2 by 3 into V1 raised to power 5 by 3. So the moment I put this value of C here, P2 V2 raised to power minus 2 by 3, V2 raised to power 5 by 3. What is the answer? P2 V2. Just check it out. So that means this entire thing comes out to be 3 by 5 P2 V2 minus P1 V1. That is the work. Agree? Is that clear to all of us now? Okay, so now let's take V1 common here, 3 by 5, P1 V1 I take common, becomes P2, if I take that common, P2 by P1, V2 by V1 minus 1, right? Now P2 P1 is already known to you, so pressure is already given to you. V2 V1 also ratio you know. You said V2 will be 8 times V1 and P2 by P1 is 600 over 150. So V1 also you have calculated. This ratio is known to you. P2 by P1, P2 is this, P1 is this, V2 by V1 is 8, P1 is known to you, V1 you have calculated. Put all the values and answer will come as 5500 kilojoule. 5500 kilojoule, yeah. नहीं देखो, directly you should not put P1 V1 P2 V2 because you never know what you get here. Directly put नहीं करना है, you need to calculate it. Question अच्छा था. This was a really good question, the kind of question you expect in your GATE exam. This was a really good question. This was a good question, the kind of question which you can expect in your GATE exam. Right? Okay, let's go for next question now. Agree ho gaya? Let's go for next question. Read this question carefully now. Again, some data I will give you, but understand the question. Data I will give you, but understand the question, how it is to be done. Piston cylinder assembly contains 1.5 kilogram of water at 200 kilopascal and 150 degrees centigrade. It is now heated by a process in which pressure is linearly related to volume to a state of 600 kilopascal and 350 degrees centigrade. Find the work done by water during this process. Read the question carefully. Read the question which is given to us. Piston cylinder assembly is given to us here, right? So let me give you the two states. From steam table, I need to provide you some data from steam table. Write in your copy. If P1 is 200 kilopascal and temperature is 150 degrees centigrade, so please write H1 is 2769.1 kilojoule per kg. It's a superheated state corresponding to 200 kilopascal. If you calculate the saturated temperature, it is coming less than 150 degrees centigrade. So it is superheated state 200 kilopascal 150 degrees centigrade. तो तुम्हें सुपरहीटेड रीजन में उसने वैल्यू दिया है. सिमिलरली इंटरनल एनर्जी, स्पेसिफिक इंटरनल एनर्जी 2577.1 किलोजूल पर केजी. लिखते जाओ कॉपी में. एंड स्पेसिफिक वॉल्यूम 0.95986 meter cube per kg. So this entire data is corresponding to this value. And if you know mass, you can multiply that with specific volume and you can calculate the volume also corresponding to state 1. Now let me give you now P2. P2 is 600 kilopascal and temperature T2 is 350 degrees centigrade. Again, that is also superheated region. So if you want to know which region it is, superheated or saturated, you need to find out the saturated temperature corresponding to 600 kilopascal. So what is the saturated temperature corresponding to that? It gives you the value of whether it is superheated or not. So temperature, saturated temperature is coming less than that. So what is enthalpy now? H2 is 3166.1 kilojoule per kg. Now specific internal energy is coming to be 2881.5 and specific volume is 0.6995 meter cube per kg. That is a specific volume. Now see, the specific volume is less, that means it is a compression. Now we are given mass also, we can find out the volume also. V2 also can be obtained. So this is the state 1, this is the state 2. We have to find out the work done. And there is another important thing given, linear relation is given. So this is the diagram which you can think of getting. ये diagram तुम्हारे पास बनेगा 1 2 state P and V, state 1 state 2, and you have to find entire area. This area you have to find. So this is the triangle and this is the rectangle. So what is P2? P2 is 600 kilopascal. What is P1? 200 kilopascal. So this is 600, this is 200. What is V2? What is V1? V2 V1 we have calculated. कैसे निकाला V2 V1? M into specific volume. तो हमें इस पॉइंट पे V1 पता लग गया, V2 पता लग गया, we calculated it. अभी टोटल वर्क कितना है? टोटल वर्क इज इक्वल टू नाउ 200 into V2 minus V1 plus half of 600 minus 200 into V2 minus V1. This is the total work which we can calculate. तो आंसर कैलकुलेट करोगे, कंप्रेशन वर्क है, कंप्रेशन है इसलिए नेगेटिव आएगा, -291. फाइंड द वर्क डन by water. Sorry, this is not negative, it is work done by water already is given. So listen this carefully. Answer choice given in the NPTEL is 291, though it is a compression. If in the question he asks you to calculate work done, what will be the work done? तो आप नेगेटिव लगा सकते हैं, वो कंप्रेशन हो जाएगा. बट अगर आएगा वर्क डन बाय द वाटर, जब बाय दे दिया, ऑलरेडी हैज गिवन बाय, तो साइन कन्वेंशन उसने ले लिया, तो यू आर टू टिक 291. दोनों आंसर दे रखे थे, नेगेटिव भी दे रखा है, पॉजिटिव भी दे रखा है. लिसन दिस केयरफुली. व्हाट विल बी द वर्क डन बाय कंप्रेसर? वो नेगेटिव नहीं लगाना, उसमें तुमने मैग्नीट्यूड देना है, नेगेटिव नहीं लगाना. व्हाई? बिकॉज इज ऑलरेडी मेंशन वर्क डन बाय कंप्रेसर. सो वहीं पे तुम्हें नेगेटिव लगाना है जहां पे यू आर नॉट गिवन द सिस्टम. इफ ही हैज गिवन यू द सिस्टम, you are to go for yes. So your answer is correct. B should be the answer for this. That is correct. That is the right answer. Let's go for next question now. We go for question number 11, and again another good question. Read this question carefully now. Another good question. 400 liter tank that is given contains argon gas at 250 kilopascal and 30 degrees centigrade. Cylinder B is having frictionless piston of such mass that pressure of 100 kilopascal will float it, and it is initially empty. The valve is opened and argon flows into B and eventually reaches a uniform state of 100 kilopascal and 30 degrees centigrade. Eventually reaches uniform state of 100 kilopascal and 30 degrees centigrade throughout. What is work done by argon? Assume argon to be ideal gas. सोचो कैसे करेंगे? Just think how you will do this. Just think of how you will do it. You know, there is an argon here. Argon flows into this and lifts the piston. So how shall you calculate it? Just think it of how shall you solve this question. Try to think and then I give you the solution for this. It's a good question of NPTEL. The important thing here is throughout the temperature remains 30 degrees centigrade and 100 kilopascal. Argon flows into B and eventually reaches uniform state of this. The pressure and temperature is this. This P naught 100 kilopascal actually is atmospheric pressure. So it looks like this piston is not having any mass. Abhi ho kya raha hai? The piston will go to this level. Pressure inside and pressure outside is P naught only, right? And temperature is also maintained constant. तो अगर हमें ये डेल्टा V पता चल जाए, if we get to know delta V, we can calculate the work done. वर्क डन होगा कहां? यहां पे वर्क डन होगा, यहां पे वर्क डन होगा. मैंने आपको पहले भी बताया था, फॉर वर्क टू बी डन, फॉर वर्क डन यू नीड अ मैकेनिज्म. You do not have mechanism here. From here you are getting only matter. You are only getting a matter which is actually pushing the piston, and piston cylinder mechanism is doing work. It is expansion work. Now the pressure is constantly remaining P naught. So if I want to calculate expansion work, I need to see P naught into delta V. Delta V, now initial there is no volume. Now suppose I get to know what is the volume change, I will calculate what is the work done. So how to find out what is the volume? How to find out what is the volume change now? How shall we calculate what is the volume change? Now let's see how we calculate what is the volume change. We are given here the gas which is argon gas. Now for the gas which is argon, we need to calculate what will be the volume in this particular case. Just calculate the volume V2, change in volume finally. Give yourself 1 minute if anybody has got it. Okay. Yes, 60 kilojoule and V2 is 1 meter cube. That is correct. Now see, we are given this 400 liter. So 1 liter is 10 raised to power minus 3 meter cube. So 400 into 10 raised to minus 3, 0.4 meter cube. V1 is 0.4 meter cube. So the volume is V1 of the argon liter tank. Argon gas was having this volume initially. This is the volume of argon gas initially. Now temperature is remaining constant. P1 V1 by T1 is equal to P2 V2 by T2. So now we are given that argon gas can be assumed to be ideal gas. So I can use this formula. T1 and T2 are remaining same. Temperature initially and temperature is going to remain same. That means P1 V1 is equal to P2 V2. Now P1 is given to us as 250 kilopascal. P2 is given as 100 kilopascal. V1 is given as 0.4. Can you tell me what will be the V2? See this carefully. Argon gas is ideal gas. P1 V1 by T1 is equal to P2 V2 by T2. Now P1 is 250. V1 is given as 0.4 meter cube. P2 is 100 kilopascal. V2, from here you will calculate V2 as 1 meter cube. V2 is 1 meter cube. We have initial volume of the matter. We have final volume also of the matter. Now what is the delta V? Delta V is 0.6 meter cube. What is P naught? 100 kilopascal. 100 kilopascal. So 0.6 into 100 kilopascal gives you 60 kilojoule as answer. So mark this in your copy. This was also a good question. It should not come 100. टेम्परेचर को कांस्टेंट करो. P1 V1 by T1, P2 V2 by T2. P1 P2 दे रखा है. V2 निकल जाएगा 1 मीटर क्यूब. V1 is 400 लीटर, 0.4 मीटर क्यूब. वहां से आपके पास डेल्टा V 0.6 आ जाएगा. And this delta V change in volume, this change in volume is also change in volume of this particular piston. So from there you can calculate it. Let's go for question number 12 now. This is the question number 12. Read the question carefully. Try to give me the answer. As you are sitting with entire thermodynamics revision with NPTEL questions and you never know directly what question comes. Assignment, please take the assignments of YourPedia, download the assignment and come to the class. And if it all goes okay till exam, till your GATE exam, YourPedia will keep on conducting such classes. So if it goes okay, we will keep on doing that. It can be MSQ. It can be MSQ. Not only one choice. It can be MSQ. Go for MSQ. You know, a gas separated from vacuum by a membrane. There's a gas and then there's a vacuum. Membrane ruptures and fills the entire volume. Free expansion ho gaya. This is the free expansion. Yes. कौन सी ट्रू स्टेटमेंट्स हैं? Which are the true statements? Do you think there is only one true statement? Do you think there is only one true statement? Just see this carefully. Check it out carefully. Do you think there is only one statement? What about this? Don't you think this is also true? Check B and C. Both are contradictory. Either B will be true or C will be true. One is to be true. So why you are not giving C and D? C and D are the answer. See this carefully. B and C are contradictory, opposite. Either of these two is to be true, right? Either B is correct or C is correct. So one has to be the answer. Now C and D are the correct statements. Most of you made this mistake. Most of you did this wrong. You should not make mistakes in such small questions. You should not make mistakes in small questions like this. And that is what it is saying. It is a reversible process. This one is a reversible process. When you get PDV work, it is a reversible work. So you cannot get PDV work through free expansion. That is what it is saying. Right? Okay, those who have not getting NPTEL lectures, please go on the website and download it. That is there. Or talk to the executives. Right? Okay, so answer for this was C and D. Let's go to next question. This is a good question. Read this question carefully. A constant piston cylinder assembly contains 0.8 kilogram of water as a saturated vapor at 400 kilopascal. It is now cooled so that water occupies half of original volume. Find the heat transferred to the water in the process. Find the heat transferred to the water in the process. Read the question carefully. I need to give you some data. So let me give you some data. पहले तो diagram बनाते हैं. Keep writing in your copy. So what kind of diagram we are going to get here? So let's make TS diagram. So 400 kilopascal is given to us. In the beginning, state 1 was 400 kilopascal pe. It is in the state of saturated vapor. This is the saturated vapor. This is the saturated vapor. Now, corresponding to 400 kilopascal, please write in your copy, T saturated is coming out to be 143.608 degrees centigrade. From the steam table, you will get this data. From the steam table, you will get this data. He will provide you this data in the exam. So U1 specific internal energy, which is U gaseous state also 2553.1 kilojoule per kg. I am giving you values at state 1, which is also saturated vapor state. Write the specific volume also at this state as 0.46238 meter cube per kg. That is specific volume there. And what is the volume we are getting? M into V1. Mass is given 0.8 into V1. That is coming out to be 0.3699 meter cube. That is the total volume V1. Now again he has given you one data that final volume is initial volume by 2. So we are given the final volume. You know, we have to calculate the heat transferred. For that we may be requiring this information. Right? So V2 is V1 by 2. That is what we have calculated as 0.18495 meter cube. That is final volume. Now can we find out the specific volume at state 2? Let us say this is a state 2, because it is in the question, it is given that it is now cooled so that water occupies half of its volume. Let us see what is V2. V2 is V2 by mass. So how much is the specific volume coming? 0.23119 meter cube per kg. Right? Specific volume we get like this. You know, we have now specific volumes corresponding to this point and this point both. So what is the specific volume corresponding to this point? Saturated water state, saturated liquid state, that is 0.00108355. And what is gaseous state? That we have already calculated as 0.46238. This value is already known to us. So if I put now V2 is equal to Vf plus X times Vg minus Vf. Suppose we do that. We calculate the value of X as dryness fraction comes as 0.49, 50%. And that is also mentioned in the question approximately. So dryness fraction is also coming 50%. So I was telling you it will be state 2 will be somewhere here. Dryness fraction is coming like this. Why dryness fraction is required? Sir, to calculate U2. UF plus X UG minus UF. So हमारे पास UF and UG का वैल्यू हमारे पास है. We have U value UG Similarly, UF value also can be obtained. Now, what is the value of U2? That is coming out to be 1578.66 kilojoule per kg. So what we did, we calculated X2. From X2 we calculated specific internal energy at state 2, right? So now we have calculated that. Now dq, that is what we want to calculate, is delta U plus dW. How to calculate that now? This is U2 minus U1 plus P into V2 minus V1. So what is dq? dq is U2 minus U1 plus P into V2 minus V1. Or you can calculate directly from enthalpy also. So when you put all the values together, answer will come as minus 855.5 kilojoule. So as I told you, in NPTEL assignment he has not given you the values, but copy के ऊपर लिखते जाओ, because these values will be provided to you in the GATE exam. These values will be provided to you in the GATE exam. Answer will be coming as minus 855.5 kg. And you guys have steam table with you. I request you to start seeing the same steam table, because the moment you start seeing the steam table, 400 kilopascal pe what are the values coming, so you can see those values, you know, saturated liquid state, saturated vapor state, वो चीजें आपको पता लग जाएंगी वहां से. Let's go to the next question now. This is the next question. So read this question again carefully. It is also a good question. An insulated rigid cylinder is divided into two parts of 1 meter square each by an initially locked piston, as shown in the diagram. Side A has air at 200 kilopascal and 300 Kelvin, and B has air at 1 megapascal and 1000 Kelvin. The piston is now unlocked so that it is free to move, and it conducts heat so that air comes to uniform temperature TA is equal to TB. Assume air as an ideal gas with constant specific heat. Determine the final temperature and find the final pressure. Read the question carefully. This one is a good question. It is insulated rigid cylinder, and there are two parts of 1 meter square. He has given you the conditions of A and B. Volume of both is same. Read the question carefully before I solve it. Another good question, and I told you that you are not to write the question. You can download from the website of YourPedia, but I want that you should write it. See, in my opinion, GATE exam will be there because they have declared it, and life cannot stop. If you postpone GATE exam or any exam for that matter, it will be lost to you, because jobs will not come, PSU jobs will not come, your sessions will not start, and everything will stop. Number two, please keep preparing, because if you distract yourself now that exam nahi hoga, chalo aram se karte hain, please do not distract yourself. That is my genuine request to you. Preparation karo puri tarah se, keep yourself safe. We are also teaching, you are also to study. Everybody is to, you know, do their activities. You should not sit at home and ask for, you know, suspension of the exams. ये रोक दो, उसको बंद कर दो, ये कर दो. इससे बहुत लॉस होता है तुम्हें भी, तुम्हारे करियर पे, एंड बाकी लोगों के भी. कीप योरसेल्फ सेफ एंड कीप प्रिपेयरिंग. अच्छे तरीके से तैयारी करो और डिस्ट्रैक्ट मत करो अपने आप को. बहुत से स्टूडेंट्स डिस्ट्रैक्ट कर रहे हैं कि एग्जाम पोस्टपोन हो जाएगा. सो लेट्स reduce the pace of preparation. Please don't do that. Increase the pace of preparation. मान लो 1% चांस, अगर सपोज ये होता है, और तुमने तैयारी अच्छी कर ली तो इट इज गुड फॉर यू। एंड सेकंड सिचुएशन कि आपने अज्यूम कर लिया पोस्टपोन हो जाएगा और तैयारी नहीं किया और एग्जाम हो गया। अंडरस्टैंड व्हाट इज हैपनिंग? सो थिंक दैट वे, अज्यूम करके चलो एग्जाम पक्का होगा 100% और होना ही है वो। गवर्नमेंट हैज डिक्लेयर्ड इट। कोई चीज रुक रहा है क्या? इलेक्शंस रुक रहे हैं क्या? कुछ भी चीज रुक रहा है क्या? तो जब सब लोग काम कर रहे हैं तो वाई एग्जाम्स, वाई स्टडीज, वाई स्कूल्स? एजुकेशन ही क्यों रोकना है तुम्हें? प्लीज prepare well and go with full preparation to the exam. Do not distract yourself at this moment. Let me give you the answer to this question now. पहले तो हम क्या करते हैं? For this, PAVA is equal to MARATA, let us say, and I think both sides it is air, so instead of RA I can write R. Similarly, this is PB VB MB RTB. ये दो इक्वेशन बन गई. Let's call it equation number 1. Let's call it equation number 2. PV is equal to MRT. अभी उसने क्या दे रखा है कि VA is equal to VB is equal to 1 meter cube. So let's divide equation number 2 with 1. PB over PA is equal to MB over MA, TB over TA. लिखते जाओ. Keep writing in your copy. What is PB? What is PA? Now PB is 1000 kilopascal. So this is 1000 kilopascal. This is 100 kilopascal. What is mass of B? What is mass of A? We do not know. Mass of air in B and A we don't know. This is 1000. This is 300. Temperature 1000 Kelvin, 300 Kelvin. So हमारे पास MA will be equal to 2/3 of MB. लिख लो कॉपी में. Mass of A will be 2/3 of mass into B. Right? So mass of A is equal to 2/3 of mass into B. अब अगर मैं इस इक्वेशन को लगाऊं, so PA is 200, VA is 1 is equal to MA, R is 0.287 for air, and TA is 300. I used equation number 1. We got the relation between MA and MB. Use equation number 1. Pressure is given. Now volume is 1 meter cube. Mass is MA. We want to calculate. R is 0.287 and TA is the temperature. So what we calculate, MA is coming out to be 3.48 kg. Mass in container A is coming out to be 3.48 किलोग्राम. यस, मास आ गया हमारे पास, MA आ गया तो MB भी आ जाएगा, राइट? MB can also be calculated. Now when you merge these two, air comes to final equilibrium temperature, let us say T final. You know the formula, M1H1 plus M2H2 is equal to M final H final, right? And if it is ideal gas, you know this formula, M final H final M1 H1 plus M2 H2 specific enthalpy. And if it is air, ideal gas, I can write it as M final temperature final, M1 temperature 1, M2 temperature 2. Now 1 is nothing but A, 2 is nothing but B, and M final is nothing but MA plus MB, right? And T final can be calculated. So T final is coming out to be MATA MBTB over MA plus MB. What is MA? What is MB? We have calculated. What is TA, TB? That also is known to us. So T final can be calculated. It is coming 720 Kelvin. Please note down in your copy, it is 720 Kelvin. 720 Kelvin is the temperature. 720 Kelvin. Kelvin. If it is done, let's go to next part. Find the final pressure. Find the final pressure. अभी फाइनल प्रेशर कैसे निकालेंगे? हाउ शैल वी कैलकुलेट फाइनल प्रेशर नाउ? P final, V final, M final, R T final. Can we use this equation? Because finally also it is air only. तो M final कितना है भाई? M final is MA plus MB. निकाल चुके हैं हम MA और MB बोथ हमने दोनों निकाला है. That is 5.807 kg. That is the final mass. And now what is P final? P final is now M final 5.807, 0.287 for air is R. T final is 720 over V final कितना आ गया था? 2 मीटर क्यूब. So this is 599. Where is this? 600 kilopascal. So 599.97 kilopascal आएगा. Yes, 600 kilopascal. Done? Okay, let's go for next question now. Okay, अभी इस क्वेश्चन को 16 को हम थोड़ी देर में बाद में आते हैं. I think Vishal sir will take this question 16. इसको नोट कर लो. 16th question Vishal sir will take. And let's come to 17 to 19 questions. Read these questions now. Read this question 17 to 19. We are given steam at 4 megapascal and 400 degrees centigrade. It enters the nozzle steadily with velocity this and leaves at this megapascal at temperature 300 degrees centigrade. Inlet area of nozzle is given 50 centimeter square and heat is being lost from nozzle at rate of 75 kilowatt. You have to determine the mass flow rate of steam, exit velocity, exit area. ये क्वेश्चन बहुत बार रिपीट होता है गेट में, and this question is a really good question. Many times it is repeated and the question is good. अगर एयर और हीलियम दिया है तो हमारे पास सारा डाटा नहीं है उसको एनालाइज करने का. फिर देन वी नीड टू टेक RMA, RA वगैरह सेपरेटली लेना पड़ेगा हमें उसको. RA and all these values also we have to take it then. Right? So let's now go for this question. Let me solve all these three questions for you. So I will give you some data for this. Let me provide you data. So at 4 megapascal, please write in your copy, he has given you saturated temperature as 250.35 degrees centigrade. So it is superheated region. So the data which is given to us for the steam, that is superheated region. It is the superheated state. And at that H1 is coming out to be 3214.5 kilojoule per kg. Keep writing. Specific volume is given as 0.07343 meter cube per kg. That also you please write. Now at 4 megapascal, sorry, at 2 megapascal, again the data is given. T saturated for this is also 212.37 degree centigrade. ये भी superheated region में है. So the steam is in the superheated state only at entry as well as exit. Now what is H2? We are given as 3024.2 kilojoule per kg, and specific volume is given as 0.1255 meter cube per kg. So we are given at this data H1 and V1, H2 and V2 हमारे पास वो वैल्यू दे देगा. अभी क्या लगाना है? स्टडी फ्लो एनर्जी इक्वेशन लगाना है. वी हैव टू यूज स्टडी फ्लो एनर्जी इक्वेशन बिकॉज ये आपके पास स्टडी फ्लो का केस है, राइट? फ्लो थ्रू नोजल. लगाते हैं इसको. H1 C1 square by 2 plus GZ1 into mass flow rate plus heat flow rate Q dot is equal to M dot H2 plus C2 square by 2 plus GZ2 plus W. अभी उसने हमारे पास Z1 Z2 नहीं दिया है, W भी नहीं है, W नहीं होता, नोजल के अंदर there is no work done and it is horizontal situation and heat is lost. Heat is lost, it is given to you at a rate of 75 kilowatt. So minus 75, I think this is kilowatt. 75 kilowatt. Remember, once you put the values, m dot h1 का वैल्यू आ जाएगा 3214.5, ये किलो जूल पर केजी में है, इंटू केजी पर सेकंड से मैंने मल्टीप्लाई किया. C1 is given 60. Remember here you have to divide by 2000 because kilojoule में है. This is in kilojoule. So 60 square divided by 2000 is equal to m dot into then 3024.2 plus C2 square by 2000. यहां से हमारे पास C2 निकल के आ जाएगा. And yes, we want to calculate C2 from here, but before that, mass flow rate. Can I calculate mass flow rate? Yes. Mass flow rate is area, velocity into density at state 1. If this three information is there to us, we can calculate it. And also, that is area, velocity and density at exit also. So mass flow rate through nozzle at entry and exit is same. Steady flow hai. So area of the nozzle at entry is given to us. Velocity is given 60 meter per second. And this is 50 centimeter square. Units we have to take carefully. And density is nothing but specific volume. So specific volume is nothing but density, and density is nothing but 1 by specific volume. तो हमारे पास ये भी है, area भी है, velocity भी है. Mass flow rate I am giving you directly now. It is 4.0855 kilogram per second. That is the mass flow rate which is coming. Mass flow rate will be this. So A1 C1 by V1 will give you mass flow rate 4.08. अभी mass flow rate इस equation में रखेंगे, and then we will calculate the value of C2, velocity at the exit. Anybody has got what is velocity at the exit coming? What is the exit velocity coming? Mass flow rate पहला question था, and if you put the values, C2 will come out to be equal to 588.99 meter per second. So mass flow rate is 4.08 and velocity is coming 588.99. That is the velocity at the exit. And third question is asking is about the area. देखो A2 is nothing but A1 C1 by C2 and then it is V2 by V1. Specific volume. तो तुम्हारे पास specific volume भी है, V1 V2 है. C2 C1 now you know, A1 also you know. So area will be 8.7 centimeter square. You have to put calculation. 8.7 centimeter square will be the area. So this was a good question. और nozzle के बहुत से question आते हैं in which he is asking you about nozzle flow. कितना होगा enthalpy, कितना होगा area. Those questions he is asking you. Right? So let's go for next question now. Read this question carefully. This is the question. Please go through this carefully now. Saturated liquid vapor mixture of water called wet steam in a steam line at 1500 kilopascal is throttled to 50 kilopascal and 100 degrees centigrade. What is initial quality in the streamline? That is a question. Read the question carefully and see how it is to be done. Any idea what is throttling process? क्या होता है throttling process? What do you mean by throttling process? थ्रॉटलिंग प्रोसेस में आपका एंथैल्पी रिमेन्स सेम. This is 1, this is 2. Enthalpy remains same in the throttling process. Now saturated liquid vapor mixture of water called wet steam in a streamline at 1500 kilopascal is throttled to this. What is the initial quality in the stream? So all the data he has given you, so we can find out, at what is the value of specific enthalpy. What we understand is at 50 kilopascal and 100 degrees centigrade, we get superheated state. The moment you go to 50 kilopascal and 100 degrees centigrade, it is a superheated steam. What you get is superheated steam. At that superheated steam, H2 is coming out to be 2682.4 kilojoule per kg. यहां पे जो तुम्हारे पास है सुपरहीटेड निकला, steam is superheated, and I can find out what is the specific enthalpy for that, 2682.4 kilojoule per kg. Now if H2 is this, H1 is also equal to this, but H1 is not superheated, it is in the wet region, Fg. You know this. Now because in the throttling enthalpy does not change, as per the data this is superheated, तो मेरे को H2 पता लग गया. H2 is equal to H1, so I know this now. And now at 1500 kilopascal, I know what is HF, that is 844.56. I know HFG 1946. I know H1, which is 2682.4. X can be calculated, and value of X is 0.944. You should understand the method. Data in the GATE exam he will give you. Yes, the data he will give you. As I told you, NPTEL assignment में data नहीं दिया हुआ था, लेकिन वहां पे actual question में he will provide you the data. So then it won't be trouble for you because data will be given to you. Here I am supplying you data. At least we clear the concepts, and when it comes we understand it. So basically हमारे पास जो दे रखा था वो एक state हमारे पास दे रखी थी आपकी wet region में, and then another state 2 was in given to us in superheated. So it is not constant pressure, obviously. It is, I should plot HS diagram, that will be better. So HS diagram में ये हमें state दे रखा था, state 1, state 2. State 2 is in the superheated region and state 1 is in the wet region. So throttling process is a very, very important concept. Throttling process, constant enthalpy process is a very important concept. वहां से क्वेश्चन बनाता है वो. सबसे पहले आपको H2 देता है सुपरहीटेड रीजन में, उससे आप H1 निकालते हो और H1 से फिर आपको वो ड्राइनेस फ्रैक्शन निकालने के लिए बोलता है. एंड इनफैक्ट ये एक एक्सपेरिमेंट होता है टू फाइंड आउट द ड्राइनेस फ्रैक्शन. लेट्स गो टू नेक्स्ट क्वेश्चन नाउ. Read this question again carefully now. A steam turbine receives steam from two boilers, boiler 1, boiler 2. So at 3 megapascal and 700 degrees centigrade, you get at this particular value, this is state 1 and this is state 2. Exit state is also given to us as this. This is the exit state. आपको पावर आउटपुट निकालनी है एडियाबैटिक टर्बाइन की. क्या होगी पावर आउटपुट ऑफ एडियाबैटिक टर्बाइन? ओके, लेट मी गिव यू एट दिस स्टेट वी आर गेटिंग H1 सुपरहीटेड स्टेट है 3912.2 किलोजूल पर केजी. एट दिस वी आर गेटिंग 3481.3 किलोजूल पर केजी. वो डाटा आपको देगा, अभी लिखते जाओ कॉपी पे. कीप राइटिंग इन योर कॉपी. So H1 H2 is provided to you. Let us say mass flow rate is m1 dot, mass flow rate is m2 dot, जो हमें दे रखा है m1 dot m2 dot. So at 3 what we get is m1 dot h1 plus m2 dot h2 is equal to m1 plus m2 dot h3. You know this equation? You already know this equation. So m1 dot is 15 kilogram per second. This is 15. This one is 5. So h3 will come out to be, which is the you know sorry, this is the state which is not 3. This is something which is h in please write it h in. Specific enthalpy we are getting when it will mix it up. Exit state नहीं है, ये आपकी entry state है. So when these two will mix together, we consider the entry stage. So H inlet we are getting is 38.75 kilojoule per kg. M1 dot H1, M2 dot H2 will give me M1 dot plus M2 dot H inside. So H inlet specific enthalpy inlet will be 3804.47. So that is the specific enthalpy of the steam when it enters. Now let's talk about this third state, exit state. So H3 is now HF plus X times HFG. This is the exit state. अभी उसने हमें दे रखा है X dryness fraction is 0.96 and 10 kilopascal पे HF will be known to me. Saturation liquid state HF, from the table I get 191.81 and HFG I get as 2392. So what is H3, which is exit, is 2488.226 किलोजूल पर केजी. तो मेरे को H इनलेट पता चल गया, मेरे को H exit भी पता चल गया. Exit के ऊपर स्पेसिफिक एंथैल्पी कितना है. And now if I use the steady flow energy equation, so what is the turbine work is H inlet H exit into mass flow rate, which is 20 kilogram per second. So from these two I got H inlet, from this state I got H exit and multiplied that with mass flow rate, so I got work of the turbine. Now what is the concept we learned in this? That if we get different streams when they enter in the turbine, then we need to mix these streams and then we need to calculate the specific enthalpy. We need to mix these streams to get the specific enthalpy. So what is the work turbine coming? Answer is 26.3 megawatt. अब इसको निकालेंगे आप खुद. You will solve this and you will get, this is the work which is coming. Let's go for next question now. Question number 22. Please see this question and keep writing in your copy now. See this question also. A steam is compressed by an adiabatic compressor from 0.2 megapascal 150 degree centigrade to 0.8 megapascal 350 degree centigrade. Mass flow rate is also given. तो पावर इनपुट कितना है कंप्रेसर को? वेरी सिंपल क्वेश्चन. ओनली थिंग इज इफ डेटा इज गिवन टू अस वी कैन कैलकुलेट इट. तो इसके ऊपर वैल्यू लिख लो. दिस वैल्यू सुपर हीटेड स्टेट है 2769.1 किलो जूल पर केजी एंड H2 भी लिख लो. H2 is coming out to be 3162.2 kilojoule per kg. And then what is the compressor work is m dot H2 minus H1. ये H1 minus H2 negative आएगा 511.03 kilowatt. Just write the values. Just write the values which is given. It's a very simple question. So So you are attending the 100 question thermodynamics lecture. We will solve 100 questions. You keep writing the important things here. Okay, let's go to next question now. Saturated water vapor at 40 degrees centigrade is to be condensed as it flows through tube at a rate of this. The condensate leaves the tube as saturated liquid at 40 degrees centigrade. Rate of heat transfer from the tube is. बड़ा simple question है. It's very simple question. Rate of heat transfer will be m dot HFG. Saturated water vapor is to be condensed. तो जब latent heat of condensation, this is nothing but latent heat of condensation. अभी देखो saturated vapor enter किया है वो. So if you make the TS diagram, this is the state at which enters. This is HFG. So you know condensation heat is nothing but m dot into this. m dot 0.2 दे रखा है. HFG की वैल्यू वो आपको सप्लाई करेगा गेट में. यहां पे वैल्यू लिखो 481.3 किलोवाट. So this 2406 is the data which he will provide you. He will provide you this data. बस ये देख लेना कि latent heat of vaporization and latent heat of condensation, that is something which actually is to be seen. और जब आपका phase change होता है, this is wet region, phase is changing. So when the phase is changing, you have to consider HFG. Let's go for next question. See this question, and two questions are on the basis of this. Okay, this question is double pipe counterflow heat exchanger. There is a oil which is from 150 to 40 degrees centigrade at 2 kilogram per second, and water is which enters at 22 degrees centigrade. And obviously we have to find out the exit temperature of water and rate of heat transfer कितना रहेगा. That is a question given, and simple question, not ticklish question. Okay, so let me give you the answer. Heat exchanger तो तुमने किया हुआ है, it's not a problem. So heat transfer is nothing but m dot of oil, Cp of oil, delta T of oil, and that is equal to m dot of water, Cp of water, delta T of water. जितनी हीट ऑयल में से निकलेगी सारी हीट वाटर में जाएगी. So let's take the data which is given to us. I think this data is given. Cp, this, right? So I calculated for this. So m dot O is 2 kilogram per second. Cp of oil is also given 2.2, and delta T of this is 150 minus 40. Water ka delta T is not given. So if you put all these values, you get 484 kilowatt. And then from here you calculate delta T W of water, and final temperature at exit of water is coming out to be 99.2. Delta T of water can also be calculated. Entry तुम्हें पता है, exit can be calculated. Done? Is this clear? So keep solving all these questions with a relaxed mind, and we have to complete 100 questions. We are going to learn it thoroughly, and good practice will get at the end of the day. So we will provide you hundreds and thousands of questions. Don't worry about that. We'll solve it. There are three parts of this question. Again, a really good question. The kind of question which you can think of getting in GATE exam. Really good question. I want you to solve this question. Try to see whether you get it. So there are two mass streams as is shown in the diagram, m1 dot, m2 dot, temperature T1, T2, and there's a mixing device. The gas is same ideal gas, and it is mixed in steady flow chamber while receiving energy by heat transfer from surrounding as shown. So there is a energy heat transfer is also there. Mixing process takes place at constant pressure with no work and negligible changes in kinetic and potential energies. Assume the gas has constant specific heat. Now what you have to do is you have to determine the expression for final temperature of the mixture in terms of rate of heat transfer to the mixing chamber and inlet and exit mass flow rates. So what you have to find out is you have to find out the final temperature of the mixture in terms of this m1 dot, m2 dot, t1, t2, q, cp, etc. Think it of how shall you approach it. I told you this is a typical question which you can think of getting in GATE exam. ऐसे ही क्वेश्चन आते हैं बिल्कुल एग्जैक्टली वो आपको कुछ देगा जिसमें आपको मैनिपुलेट करना है चीजों को एंड यू हैव टू सॉल्व इट. Just think how you will solve it. Okay, so let me provide the answer now. एनर्जी बैलेंस करते हैं. राइट इन योर कॉपी एनर्जी बैलेंस. हाउ डू वी गो फॉर एनर्जी बैलेंस? Sir, heat flow inside is m1 dot h1 plus m2 dot h2 plus q dot m3 dot into h3. This is the heat energy balance. This is the heat energy balance. But you know what? H is nothing but Cp into T for gases. For ideal gases, you can think of Hp is equal to Cp into T. So what here we get is, now wherever H1 we are getting, we replace that with temperature. So in your copy, you are to write that. I just wrote like this, but in your copy, you are to write like this. So what do we get? T3. So we get T3, that is what we want to find out, is M1 dot over M3 dot into T1 plus M2 dot over M3 dot into T2 plus Q over M3 dot into Cp, right? Yeah, Cp dt भी था, तो when I put it here, Cp will also be there. So equation will be this. When you replace H, you will replace with Cp into T. So this is the answer, and I think this is D is the answer for first question. First question answer is D. First question is done. So everybody understood this was the energy equilibrium only, nothing else. Second question is ticklish. Try करो solve करने का. ये second question को solve करने का try करो. Try to solve this. Obtain an expression for volume flow rate at the exit of mixing chamber in terms of volume flow rate at the two inlet streams and rate of heat transfer to the mixing chamber. अभी तुम्हें find out करना है V3 dot. So how shall you calculate V3 dot? That is the question. V3 dot कैसे निकालोगे? Solve it. This is a good question, as I told you. How shall you solve V3 dot? निकालो, कैसे निकालोगे? How shall you solve it? V3 dot, क्या आंसर निकलेगा V3 dot? Okay, let me give you now. We already calculated. Let me give you how to calculate it. इसको लिखना कॉपी में ध्यान से. Please write this in your copy carefully now. We have calculated that T3 is equal to M1 dot T1. Please write M2 dot T2 plus Q dot divided by Cp divided by M3 dot. This is T3 we calculated, first part. First part was this. This was first part. Can we write M1 dot as density into specific volume dot into density. And in the ideal gas equation, P is equal to rho RT, right? Mass flow rate is nothing but volume flow rate into density. This is volume flow rate. Now, density is nothing but P over RT. So can I write M1 dot as equal to P over RT1 into volume flow rate. Similarly, M2 as P over RT2. Let's write it V1 dot, not to get confused with specific volume. V1 dot, this is V2 dot, हमें वही निकालना है, and M3 dot as P over RT3 V3 dot. So we want to calculate volume flow rate now. So to calculate volume flow rate, you convert mass flow rate into volume flow rate. Mass flow rate is converted into volume flow rate by multiplying with density, and density is P over RT. Now if you put all the things in this formula, T3 is equal to, let's write it P over RT1 into V1 dot into T1. That is what it is coming. Similarly, P over RT2 V2 dot T2 plus Q dot over Cp divided by P over RT3 over V3 dot. Now T1 get cancelled out, T2 get cancelled out, this T3 also get cancelled out, P over RT3 into 3. Right? We take certain things common, PR, 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 we take common. Only thing is PR term will come here. So T3 will go on the numerator, T3 numerator में चला गया, and we have taken here V1 dot over R plus R भी हमने कॉमन ले लिया, V1 dot plus V2 dot plus R over P Q dot by Cp over V3 dot is equal to T3. Just check it out. मैंने क्या किया, P by R से डिवाइड कर दिया सब तरफ, तो R by P आ गया. I divided throughout with P by R, got cancelled, got cancelled, got cancelled, R by P आ गया, and I just took T3 on the numerator. This gets cancelled out, and the answer we get here is, now we get V3 dot is equal to V1 dot plus V2 dot plus R over P Q dot by Cp. That is the, I think, answer we are getting. Answer choice is A. So the answer we are getting is A. Just manipulation, as I told you, of the question. This was a really good question, and this is how we have to solve it. अब तीसरे क्वेश्चन में दिया है adiabatic mixing. In adiabatic mixing, Q is 0. So if it is adiabatic mixing, answer for us will be V3 dot will be V1 dot plus V2 dot. Adiabatic mixing will be Q dot will be 0 and V3 dot will be equal to V1 dot plus V2 dot. So as I told you, this is very, very good question. This question is really good. First, he asked you to calculate T3 dot, And the answer for that we were getting was, I think, D. Then he asked you to calculate V3 dot, answer is A. And then he asked you, what if adiabatic mixing? So adiabatic mixing answer is C. So this all was good question here. Let's go for question number 29. Read this question carefully. What is answer for that? Question number 29. Okay, so Vishwanath, that I need to check it out, whether that will be M3 dot or it may not be there. We need to put that in formula and check, right? Yes, so questions normally come in GATE exams from these kind of topics. So what is answer? And it can be multiple select questions. Give the answer fast. I'm waiting for your answer. Give the answer fast. What will be the answer to this question? I'm waiting for your question. Okay, which among the following is true about pure substance? Which of the following is true? A pure substance need not to have a single chemical element or compound. That is true. It may not be single chemical compound. No, this is B, C, D. Answer is B, C, D. All the three are correct. Note कर लो, ये इसी का definition है. This is the definition of pure substance, right? He has given you the example also. Like B is giving you air is mixture of several gases. तो उसके अंदर बहुत से chemical element हैं. But oil and water is not homogeneously mixed. Soluble नहीं है, तो वो नहीं हो सकता pure substance, right? Okay, next go for next question now. Answer this question. Do it fast. Do it fast. Which of the following statement is true regarding the number of properties required to fix the state of system? हाँ जी, क्या आंसर आएगा? What will be the answer to this question? What is the answer? I am waiting for your answer, because these questions, 100 question series, you people will get the question in advance. We expect that आप उसको पढ़ के आएंगे, and then you will give your answers also. Okay, so answer for this is D. D is the answer for this question. Let me tell you what is Gibbs phase rule. Degrees of freedom is equal to C minus P plus 2. C is the number of components. D is the F is the degree of freedom, means independent thermodynamic properties which fix the state. So how many independent properties are required to fix a state? That is F, degree of freedom. C is the number of components. P is the number of phases. अभी क्या है? Number of components, if number of component is, let us say we keep it 1. If C is given as 1, so F is 3 minus P. F becomes 3 minus P. Right? Now if we consider the single phase, Fp is equal to 1, F comes out to be 2. Simple compressible pure substance is two independent intensive thermodynamic properties. Actually, this question was not related to CP, etc. It was intensive and extensive. Remember that in Gibbs phase rule, if you want to find out degrees of freedom, that is independent thermodynamic properties, and those properties are not extensive, these are intensive properties. That is the most important thing. So this intensive properties versus extensive property question it was. And remember that Gibbs phase rule mein you talk about intensive properties, not extensive properties. So either intensive extensive, no, एनी नहीं हो सकता, टू होता है, कोई नंबर है उसमें, इंटेंसिव एक्सटेंसिव नो, सो एलिमिनेशन से तुम बोलोगे डी इज द आंसर, इंटेंसिव प्रॉपर्टीज इज द नेम फॉर दैट, राइट? तो नोट कर लेना इंटेंसिव प्रॉपर्टीज. अनदर टू गुड क्वेश्चन, रीड दिस क्वेश्चंस केयरफुली. The two tanks are connected as shown in the diagram. Tank A has 200 kilopascal, specific volume is 0.5, volume is 1 meter cube. Tank B 3.5 kilogram at 0.5 megapascal and 400 degrees centigrade. Now the valve is opened and the two come to uniform state. The question is now 1, 2, 3, 4, these 4 questions. On the basis of this data, let me give you, he will provide you data. Let me provide you some data here. Now at this particular state, it is a superheated state. At 0.5 megapascal, 400 degrees centigrade, superheated state hai. So B is at the superheated state. Specific volume is given as 0.6173 meter cube per kg. That is the value. And mass is 3.5. So volume at B is mass into specific volume. That will be 2.16 meter cube. Right? And VA is 1 meter cube. Specific volume is 0.5 meter cube per kg. Now he is asking you what is the mass of water in tank A. So what is the mass? Density into specific volume. Or you can say that volume over specific volume. Sorry, mass is volume into density. So volume over specific volume. What is volume? 1. What is specific volume? 0.5. So 2 kg. ये तो बहुत ही सिंपल है. You can easily calculate it. 2 kg. Specific volume of tank B before valve is opened. अब ये तुम्हें डायरेक्ट स्टीम टेबल से तुम्हें उठाना था 0.617. You will take it from the steam table directly. And then comes volume of tank B 2.16 meter cube. Final specific volume क्या होगा? What will be the final specific volume? So final specific volume is total volume over total mass. You know what is MA, you know what is MB, you know what is VA, you know what is VB. So that will come out to be VA is 1 meter cube plus 2.16, 2.2 plus 3.5. So final volume is 0.575. This is the answer for this question. This is the answer for this question. Done? So it was a very simple question, not a ticklish one. Let me take you to the next question now. Read this question. ये पहले भी गेट में exactly ऐसा question आ चुका है. So गेट मैकेनिकल में ऐसा question exactly आ चुका है, but it is important question. So read this question carefully and try to solve it. Water has critical specific volume of 0.003155 meter cube per kg. A closed and rigid steel tank of volume 0.025 meter cube contains a mixture of water and steam at 0.1 megapascal. Mass of the mixture is 10 gram. The tank is now slowly heated. लिक्विड लेवल इन द टैंक, क्या होगा लिक्विड लेवल को? आई एम श्योर यू पीपल कैन आंसर इट वेरी क्विकली. This question has been asked in the GATE in the previous years also. I'm sure you people can answer this question. Okay, so let me give you the answer for this. What is critical? Let me draw pressure volume diagram here. P specific volume, this is a critical point. What is the specific volume given corresponding to critical volume? This is 0.003155 meter cube per kg. This is the specific volume at critical point. Now he gives you at some particular pressure 0.1 megapascal, he gives you, let us say, specific volume V1. Let us say ये तुम्हारा स्टेट आया, this is your state 1, this is 0.02, yeah, this is meter cube, but you know we are to divide it with 10 kg also, so specific volume will be 0.025 over 10, 0.0025 meter cube per kg. So specific volume at state 1 is given as 0.0025. This is the diagram you need to understand. Now the tank is heated, the tank is closed and rigid, so the heating is constant specific volume heating. Let us say वो यहां चला गया, स्टेट 2 पे चला गया, स्पेसिफिक वॉल्यूम, बिकॉज टैंक का ना तो मास चेंज हो रहा है ना वॉल्यूम चेंज हो रहा है. सो इफ यू हीट अ टैंक which is rigid tank, neither mass is changing nor volume is changing, so specific volume will also remain constant. So V1 will be equal to V2, right or not? So the concept is, if it is a rigid tank, closed tank, and you heat it, neither mass changes nor volume changes, specific volume remains same. अब उसने आपको इनिशियल स्टेट दे रखा है क्रिटिकल स्टेट से पीछे की तरफ, लेफ्ट साइड. व्हाट इज द लॉजिक ऑफ दैट? नाउ सी दिस स्टेट 2 एंड टेल मी what happens to dryness fraction at state 2. Dryness fraction is more or less, x2 is less than x1. After heating, the dryness fraction decreases. And what is dryness fraction? Dryness fraction is mass of vapor over total mass. तो अगर dryness fraction decrease कर रहा है, if dryness fraction is decreasing on heating, the liquid content is increasing. Liquid content is increasing. Suppose I give you now specific volume this side. Suppose I give you specific volume as 0.004 meter cube this side. Then what will happen after heating? Dryness fraction will increase. Dryness fraction will increase and the liquid level will decrease. So initially this question has come, next time this question can also come. The dryness fraction बढ़ गया तो liquid content कम हो जाएगा. So next time if I give you this as 0.045 meter cube, so dryness fraction is going to increase. So that was the concept from where he asked you this question. Hope you understood this. Right? So let's go for next question now. See this question, try to solve this question now. The question is, two-phase liquid vapor mixture of water initially at pressure 5 bar, dryness fraction 0.5, is heated in a closed rigid tank of volume 0.2 meter cube until only saturated water vapor remains. The approximate mass of water and final pressure will be respectively. So what will be the answer to this question? Again, some information is required, and that is what I'm going to give you. So that is the question which is given to us. So let us say this is 5 bar. I'm just giving you a hypothetical case here. And this is pressure P2, this is pressure P1. This is state 2, this is state 1. Right? Dryness fraction is given as 0.5, let us say. X is 0.5 corresponding to state 1, let us say. Now at 5 bar, the information which we get is, at 5 bar, what is specific volume? 0.001092 meter cube per kg. And what is specific volume in gaseous state? 0.3748 meter cube per kg. So V1, which is also equal to V2. Now this is V1 and this is V2 specific volume. Vf plus X times Vg minus Vf. So if I give you at 5 bar these values, the specific volume comes out to be 0.18795. लिखते जाओ कॉपी में, कीप राइटिंग इन योर कॉपी. Okay. After 10 minutes, we'll take a break of 10 minutes. After 10 minutes we may take. So let me push it forward now. This mass is equal to volume over specific volume. Volume दे रखा है 0.2, specific volume is 0.18795. So what is mass is 1.064 kg. We are given volume. Volume is given, specific volume we have calculated from this data. तो mass आ गया हमारे पास. We have got the mass. That is 1.06. That is a mass. And how to calculate pressure now? Pressure is nothing but this is the saturated pressure corresponding to this Vg. Now this Vg is nothing but, that is the value of V1 or V2, 0.18. So corresponding to 0.18795, the pressure whatever we are getting, that is the saturated pressure corresponding to this, right? And that comes out to be, I think, 10.5 bar. So I think this is the answer for this question, 10.5 bar. But as I told you, this was highly focused on data oriented question. This was totally data oriented question, right? So far in these questions, 16th question is not done so far by me, because that Vishal sir is taking. And this 37th question, this question also Vishal sir will take once my part is over. So he will take this question, 37th question also. So we'll do this question little later. Now let's answer this question. Please read this question carefully now. Read this question carefully. Carnot cycle operates between two temperatures T1 and T2. Carnot cycle operates between two temperatures T1 and T2. T1 is more than T2. If T1 is increases by delta T, keeping T2 constant, T2 decreases by delta T, keeping T1 constant, तो efficiency किस में ज्यादा होगा? It's very standard question, you know. This is very, very standard question. So let me give you the meaning of this. You know, this is the Carnot cycle efficiency. Let's say this is T1, this is T2. Heat engine. Efficiency of Carnot cycle is 1 minus T2 by T1. Now there are two ways to improve the efficiency. One is, either I can increase the temperature, because if you see, From here, efficiency increases if either I decrease T2 or I increase T1. You see the formula? That is a formula of Carnot cycle efficiency. Efficiency of Carnot cycle can increase if either I decrease T2 or I increase T1. So this is how you have to visualize. Efficiency increases like this and COP increases like this. COP of heat pump or refrigerator will increase if difference in temperature decreases. T1 T2 के बीच में गैप अगर कम हो जाए, and efficiency increases अगर इनका गैप बढ़ जाए. So how can you increase the efficiency of Carnot cycle? He will ask you question. Sir, I can increase the efficiency of Carnot cycle in two ways. Number one, I can increase T1 or I can decrease T2. Okay, then do one thing. One by one, first you increase T1 and then you decrease T2. If I increase T1, that efficiency I get is 1. If I decrease T2, I get efficiency as this. Now, which one is better? Do one thing, just calculate efficiency 2 minus efficiency 1. If it is coming positive, that means 2 is better. So when I do that, what I get is this term becomes positive, T2 by T1 plus delta T minus T2 minus delta T over T1. 1 cancel हो जाएगा, negative cancel हो जाएगा. So efficiency 2 minus efficiency 1, ये positive term आ जाएगा, minus ये आ जाएगा. डिनोमिनेटर में T1 इंटू T1 प्लस डेल्टा T आ जाएगा, देन T1 T2 माइनस T1 प्लस डेल्टा T into T2 minus delta T. When you open it, delta T square will get cancelled out because that is very small term. T1 T2 will get cancelled out. So when you open it up, what you are going to get numerator is delta T T1 minus T2 plus delta T square over T1 plus delta T. This is all positive. This term is coming positive. That means this method is better. अब इसको याद कर लेना because exam में this question can be asked in a different ways. I told you there are two ways to increase the efficiency of Carnot. Either you increase the temperature of source or you decrease the temperature of sink. Something like this. Reverse is true for coefficient of performance. Pump and refrigerator, reverse is true. You decrease it, COP increases. Now the question can be, what should we do? You should increase this or decrease this. The better option is this. Decrease the lower one. So the better option is decrease the lower temperature, but that cannot be done because ambient temperature cannot be decreased. It is practically not possible. Practically it is not possible to decrease the temperature of ambience. वो बहुत ही कम हो जाएगा, right? I hope this question is clear. अभी तुम्हें एक और इसके ऊपर मैं होमवर्क देता हूं. COP के बारे में सेम चीज करो. Do same for COP. COP of heat pump or refrigerator can be increased by raising lower temperature or decreasing higher temperature. Which one is better? That you please answer. Which one is better? That you answer for COP now. Okay, next question. Now this question in NPTEL looks like they had given wrong answer, but please read this question. It's a simple question only. You know, claim of inventor, how it is to be done, that kind of question. So this is the heat engine. This temperature is 650 Kelvin. This is 300 Kelvin. Heat engine, right? Temperature WQ1. Read this question. Rejects 50% of heat absorbed. So this Q2 is 0.5 Q1. This is also 0.5 Q1. So efficiency actual is 0.5. And what is Carnot efficiency? 1 minus 300 by 650. How much is that coming? 0.54. Approximately 0.54. It looks like it is a practical engine. What is the trouble? But answer was given something else. So this is a very simple question. I hope this kind of question you are aware. वो आपको actual values दे देगा, वो आपको theoretical values भी दे देगा. Actual and theoretical values को match करके you have to give your answers. Something like that, right? Okay, let's go for next question now. Read this question. Read these questions carefully. Reversible engine operates between temperature T1 and T2, and energy rejected by this engine is received by second reversible engine at temperature T2 and rejected to the reservoir at T3. अभी कुछ इस तरीके का केस दे रखा है हमारे पास, राइट? T1, T2, T3 एफिशिएंसी बराबर है 1 minus T2 by T1. Efficiency is 1 minus T3 by T2, and both the efficiencies are equal. So 1 minus T2 by T1 is equal to 1 minus T3 by T2. That comes T2 is T1 T3 under root. लेकिन यहां से कोई आंसर चॉइस मैच नहीं कर रहा. So none of the answer choices is matching. Yes, option does not match. Anyhow, you write this. This is a typical question. This is how it is framed. It's a simple question, not a difficult. Many times such questions are asked. Right? So both the efficiencies are equal and we have to do it. Let's go for next question now. Try to solve this question fast. Simple question. This is also quite simple question. Carnot heat pump is used to heat a house. Outside temperature is minus 3 degrees centigrade and indoor temperature is 27 degrees centigrade. If the heat loss from house is 40 kilowatt, the power required to operate the heat pump is, that is the question. Let me give you what this question is. Simple question, as I told you. This is 27 degrees centigrade. This is 270 Kelvin minus 3 degrees centigrade. This is 300 Kelvin. And it is used as heat pump. That means this is the conditioned space. This is the conditioned space for us. Now what happens is, whatever Q1 you are giving, that Q1 is rejected also, because then only the constant temperature is maintained. Now pump work, this is a heat pump. So ambient temperature is nothing but this is T0 minus 3 degrees centigrade. How much power is required to operate it? Carnot pump. So how do you calculate COP of heat pump? This is nothing but Q1 by W pump, or it can be written in Carnot terms as T1 over T1 minus T0. Now we want to find out, Q1 is given as 40 kilowatt. This is 40 kilowatt. I do not know this. T1 is 300 Kelvin and difference of these two is 30. Right? So this comes out to be 10. If this is 10, W is going to come as 4 kilowatt. W pump is going to be 4 kilowatt. Right? This is going to be 4 kilowatt. Another simple question. Let's hit next question now. Calculate the internal energy change per unit volume, per unit mole. अब ये बहुत इंपॉर्टेंट क्वेश्चन है, इसमें यूनिट्स वगैरह ध्यान से देखना कैसे होते हैं ये. Calculate internal energy change per unit mole when ideal gas contained in vessel of 0.1 meter cube capacity, initially at 1 bar 298 Kelvin, is heated at constant volume to 400 Kelvin. Right? So there is a constant volume situation given to us, because ideal gas P1 V1 by T1 is equal to P2 V2 by T2, but volume remains constant. Can you tell me what is P2? P2 is P1 T2 by T1. अभी सारी वैल्यूज लगा दो, T1 T2. You understand? P1 is 1 bar, T2 is 400 Kelvin, T1 is 298 Kelvin. So that will give me final pressure. This is 1, 400, this is 298. Pressure आ जाएगा. Now, what is delta U? Change in internal energy is CV delta T. CV into 400 minus 298. That is internal energy change. CV can be calculated. CV is Cp minus R. If you see 30 minus 8.314, 21.686 joule per mole Kelvin. See the units. It is given joule per mole Kelvin. Kilojoule per kg mole nahi, joule per mole Kelvin. So how do we find delta U? 21.686 into this is 102. This will be joule per mole, right? Kelvin आपने multiply कर दिया, joule per mole. But the answer is given in joule per kilojoule per mole. So I need to divide by 1000. So 21.686 into 102 divided by 1000. Answer will be kilojoule per mole. How much is the answer coming? 2.212. That is the answer which is coming. Next question is really good question. Try to see the next question. It is a really very good question. Van der Waals equation. Try to solve this question. This one is a very good question. Tank of 2 meter cube volume is filled with 7 kilogram ammonia at 300 Kelvin. Determine the pressure exerted by ammonia using ideal gas law and using Van der Waals equation. कैसे solve करेंगे इसको? That is what you have to do. So try to see how do you solve it. So very very good question. Van der Waals के ऊपर question. You have to play around with the units which are given to you. Let me give you the answer. अब देखो दो पार्ट में इस क्वेश्चन को हम तोड़ते हैं, एक आइडियल एंड एक रियल. वैन डर वाल आइडियल में क्या है? वी वांट टू फाइंड आउट PV is equal to MRT. So what is P? MRT over V. That is the ideal gas pressure. What is mass given? 7 kilogram. What is R? 8.314 over 17. Because this is characteristic gas constant R. This is universal gas constant. And characteristic gas constant is universal gas constant divided by molecular mass. And what is molecular mass of ammonia? Ammonia के लिए molecular mass is 17. Ammonia is given to us, NH3. So molecular mass is 17. Temperature is 300. And what is volume given as 2 meter cube? Right? So if you put all these values, you will get it in kilopascal, right? So eventually it is coming out to be 513.511 kilopascal. Megapascal, this small m is nothing but this is a capital M, megapascal. So answer is 511. I think what is given is 511 megapascal. So that is closest is this only. Answer तो आपका यहीं से निकल जाएगा, but we want to go for Van der Waals equation. So PV is equal to MRT. पहले तो यहां से आ जाएगा हमारे पास. Now how do we write van der Waals equation? Let me give you van der Waals equation here. I hope you know this equation. But remember that in this van der Waals equation, this V is not volume, this is the molar volume. This is the molar volume, V bar. And this R bar is universal gas constant, 8.314 joule per mole Kelvin. How do you calculate molar volume? You need to calculate number of moles. So 7 kilogram and molecular mass 17, हमें उसको अगर किलो मोल में कन्वर्ट करना है, दिस इज एक्चुअली किलो मोल, अगर हमें मोल में कन्वर्ट करना है तो वी नीड टू मल्टीप्लाई इट विथ 1000. फ्रॉम देयर वी गेट इट इन मोल. So what is molar volume now? V bar is 2 volume over number of moles. Van der Waals equation में this volume is a molar volume. That means volume per unit number of moles. That will come out to be 2 divided by 7000 divided by 17, sorry. That will come out to be 4.85 into 10 raised to minus 3 meter cube per mole. Meter cube per mole. So remember that if you want to calculate this in kilomole, you just divide 7 with 17. But if you want to calculate in mole, you need to multiply this with 1000. Then only you will get moles. Otherwise, you will get it in kilomoles. So what we get here is, now when we solve this question, the pressure value is coming out to be 0.499 because everything else is there. I mean, A is given, B is given, वो सारी value लगा दो, universal gas constant, temperature, then pressure which you are going to get from here, this equation is 0.499 megapascal. ये van der Waals equation के base पे question can be framed, real gas equation, and student make mistake in putting the values of A, B, molar volume, how to calculate molar volume. Those kind of mistakes normally are done. So mark this question also important for van der Waals equation. कि van der Waals equation में से question आएगा, then this is how we have to do it because many questions are being asked. I told you that when you calculate the mole, if you divide kilogram, 7 kilogram with 17, you get kilomole, right? But if you want to calculate mole, अभी क्या आ जाएगा? Kilomole. Why? Because this is kilogram. Now if you want to get mole, you need to multiply with 1000. Why we are getting mole? Because ये सारे के सारा तुम्हें क्या दे रखा है? Mole. Mole. That is the reason आपको इसका यूनिट देखो, B का यूनिट क्या है? What is the unit of B? Meter cube per mole. So V bar should also be meter cube per mole. Right? This is how you have to calculate it. So 7000 divided by 17 is number of moles. Let's go for next question. Simple question. Heat pump has coefficient of performance that is 50% of theoretical maximum, maintains the house at 27 degrees centigrade, which leaks the energy of 0.5 kilowatt per degree temperature difference to the ambient for a maximum of 1.2 kilowatt power input. Maximum outside temperature for which heat pump is a sufficient heat source will be. पढ़ो इस क्वेश्चन को and try to give the answer. Read this question carefully. Read this question carefully and try to give the answer. Now what is given is this. W pump, there is a heat pump, Q1, Q2, T1 27 degrees centigrade, and this is the conditioned space. This one is conditioned space, and I told you जितना Q1 आएगा उतना Q1 बाहर भी जाएगा, and this is T0. Coefficient of performance is actual. Coefficient of performance is nothing but Q1 by W pump. Coefficient of theoretical or Carnot is T1 over T1 minus T0. You know this. And he has given you that Q1 by WP is 0.5 times T1 over T1 minus T0. वो भी दे रखा है. Actual COP is 50% of the theoretical. Theoretical is Carnot. One more information is given. The leakage is nothing but Q1, 0.5 per degree temperature difference to the ambience. So temperature difference to the ambience is T1 minus T0. So Q1 is 0.5 T1 minus T0 kilowatt. That is information is given. 0.5 times T1 minus T0, temperature difference to the ambient. Temperature T1, outside is T0. 0.5 times this is the Q1. Leakage from conditioned space is Q1. So that information is also there with us. We put Q1 value here. Now T1 is given 300 Kelvin. And T0 is to be obtained. And W is 1.2 kilowatt. W pump is given as 1.2 kilowatt. So W pump 1.2 kilowatt, T1 is given, T0 can be calculated. How much is T0 coming? 8 degrees centigrade. Basically 281 Kelvin आएगा solve करके, and then that is 8 degrees centigrade. I told you this is a good question. You could have solved this question. This is a very good question. You be attentive, be active, because we are going to solve 100 questions. They are really good questions. Don't get tired. We'll solve them. But keep writing in your copy, keep making your notes. ये question देखो, read this question. Question number 45. We wish to produce refrigeration at minus 20 degrees centigrade. Reservoir is available at 250 degrees centigrade and ambient temperature is 20 degrees centigrade. Work can be done by a cyclic heat engine which is operating between 250 degrees centigrade and reservoir and ambient. The work which this is doing is used to drive refrigerator, and this is all reversible. So let me make a diagram for you. अभी एक तो उसने इंजन दे रखा है. One he has given you engine, and the work which is produced from engine is going to run the refrigerator. This is heat engine, Q1, Q2, let us say Q3, Q4, this is W. This is 250 degrees centigrade, 20 degrees centigrade. This is 20 degrees centigrade, minus 20 degrees centigrade. And he's asking you what is Q1 by Q3. Ratio of heat transferred from 250 degrees centigrade Q1 to heat transferred from minus 20 Q3. Inki ratio. That is what he's asking. This all is reversible. Can you tell me what is the efficiency? Efficiency is 1 minus T2 by T1. If this is T1, this is T2. That is also W by Q1. Right? What is 1 minus T2 by T1? 1 minus T2, 293 over T1. So 273 plus 250, 523 if I am not wrong, is equal to W by Q1. इक्वेशन नंबर 1, you know what is to be done, W cancel हो जाएगा. What is COP? Refrigerator COP is Q3 over W pump. W pump is nothing but W, but which is also equal to 273 minus 20 over 40. 40 क्या है इन दोनों का डिफरेंस? Equation number 2. Use equation number 2 to calculate Q3 by Q1, Q1 by Q3. That will come 0.48. 0.48. Done. So you know GATE is all about combination of simple questions and moderate degree of difficulty questions and some ticklish question. It's a combination of all these. You should know how to solve all these questions. Okay, Ajit, I think 2 more hours. मैंने आपको बताया था 5 घंटे चलेगा. Next 2 hours में I think we will complete because other next questions are simple. They are not that lengthy questions. मेरे को लगता है 2 more hours. So please attend this entire session. So 5 hours में we will complete. Solve this question. Solve this question. Consider a process with expansion from 0.1 to 0.2 meter cube at constant pressure of 150 kilopascal, followed by an expansion from 0.2 to 0.4 meter cube with linearly rising pressure from 150 kilopascal ending at 300 kilopascal. Find the boundary work. This is the kind of question. ये ऐसा डायग्राम बनेगा. Please make this diagram PV. Corresponding to this, pressure is 300 kilopascal. This is linear. 1, 2, 3. This is 0.1. This one is 0.2. This one is 0.4. This is 150 kilopascal. अभी करना क्या है? Boundary work. यही तो निकालना है हमें. This entire area. So we want to find out this total area. So what is that? 150 into 0.2 minus 0.1 plus half of 300 minus 150 into 0.4 minus 0.2. Right? It should come 60 kilojoule. Come 60 kilojoule. Simple question as I told you. Keep writing in your copy. See, don't miss any question, don't miss any class. YourPedia mein we are going to cover very good questions and you are going to get all the assignments. Questions you will get it before your class. Whenever you come for the 5 hours class, 100 question class, come with your questions. Read them beforehand. Then within 5 hours you will get 100 questions for sure. And with concepts from the teachers, right? Read this question now. Read this question. Now, what is situation given is this. If I draw TS diagram, this is the TS diagram for this case. Saturated liquid water at 200 degrees centigrade. Expanded isothermally in a closed system until its quality is 80%. This is what is given. X is 0.8. This is a state 1. This is state 2. Temperature is a saturated temperature. Saturated liquid water at 200 degrees centigrade. Now, if temperature, saturated temperature is 200 degrees centigrade, as I told you in the beginning of the class, he will give you the values. What is H1 coming? Which is this? Is 852.27 kilojoule per kg. Please write in your copy and you can check it. You can also check it. You can also check it. Yes, we will provide you the assignment 1 day before. That is sure. We will provide you these assignments 1 day before so that you can get it print out, no doubt, and you can read it also. That we promise. U1 is 850.47 kilojoule per kg. Now, that is the initial positions given to us. Now, corresponding to this, I can also calculate what is HFG, right or not? So, what is HFG coming? 1939.7 kilojoule per kg. These all values can be obtained. UFG also you can obtain 1743.73. All these values can be obtained. So can you tell me how much is this enthalpy change? This one. How much will be this enthalpy change? DH will be X into HFG, right or not? H2 minus H1. H2 minus H1. This state minus this state is nothing but X into HFG, right or not? And similarly, du can be X into UFG. So we have got all the values. And X is given 0.8. So dW, dQ is delta U plus dW. Closed system. This is constant pressure also. So this is nothing but DH. This is nothing but DU. And this is DH. DH we have got. DU also we have got. Just multiply 0.8 with this, 0.8 with this. Or dW will be equal to 0.8. 1939.7 minus 1743.7. And you get the value. He has given 1.36. Actually, it is coming out to be 1.56. Just check it out. This is the value which is coming. Five more minutes and then we take a break of 10 minutes. 5 more minutes, I'll solve 2-3 questions. We hit up to 50. We are going 47. 3 more questions. They are simple questions. Let's go for next question. 48. Heat pump operates on Carnot heat pump cycle with COP of 8.7. Keeps the space at 26 degrees centigrade by consuming 4.25 kilowatt of power. Determine the temperature of reservoir from which the heat is absorbed and heating load provided by the heat pump. Just read this question. So what is given? This is W, 26 degrees centigrade, conditioned space. It is a heat pump, Q1, Q2. COP, how do you calculate? Q1 by W, which is given as 8.7. That is also T1 over T1 minus T naught. This is T naught. What is T1? This is 273.15 plus 26. What is W? That is 4.25 kilowatt. Using this, we can find out T naught, 264.76 Kelvin. If you use this, then you can also find Q1 as 8.7 into W. So this T naught was not required. It is coming 36.975. Yeah. So this is coming out to be 36.97 kilowatt. That is Q1. and temperature is, I think, temperature 265 Kelvin and 37. Yes, that is answer. So temperature T naught is 265 Kelvin. Done. Next question. Carnot heat engine receives heat from a reservoir at 900 degrees centigrade at rate of 15 kilowatt, rejects the waste heat to ambient air at 25 degrees centigrade. Entire work output of heat engine is used to derive a refrigerator that removes heat from refrigerated space at 10 degrees centigrade and transforms it to same ambient air at 25 degrees centigrade. Let me give you the diagram. So he has made this kind of arrangement. (1173 Kelvin). This is the heat engine producing work. 298 Kelvin. Please make this diagram. Q3, Q4, 298 Kelvin, 283 Kelvin. And this one is the conditioned space. This is what, and if conditioned space is lower one, this is refrigerator. This one is refrigerator. So this entire thing is given. One more thing is given. This Q1 is given as 15 kilowatt, right? And you have to find out Q3. So what is Q3 that is to be calculated? What is Q3 that is to be obtained? अभी इसकी एफिशिएंसी निकालते हैं. 1 minus 298 by 1173 is equal to W by Q1. अभी सब दे रखा है. Q1 is also given. What is W coming? W will come as 11.189 kilowatt. W निकल गया. अभी COP is nothing but 283 over 298 minus 283. Maximum COP is this, but that is equal to Q3 by W. अब इसका वैल्यू कितना आ रहा है? 18.866. COP can be calculated from temperatures, and W is known to us. So if you solve, Q3 will be 211.09 kilowatt. Though answer is 214 kilowatt. So just check it out whether why this difference is coming. Answer he has given is 214 kilowatt. That is the question, that is the answer he has given. So taking the work from engine and giving to pump or refrigerator, that is a very commonly asked question. Done? Now, last question before we take small break here. 50th question. Read this. A rigid tank contains 5 kilogram of air at atmospheric pressure and 317 degrees centigrade. Air is cooled to surrounding temperature of 17 degrees centigrade. Assume constant specific heat at 300 Kelvin. So this is a question of entropy change of the universe. You know, entropy change of universe, delta S universe is a delta S of system plus delta S of surrounding. You know that? And this is also ds of generation. Entropy generation is also entropy change of universe. Now we are given air delta S of system is nothing but Cv log of T2 by T1 plus R log of V2 by V1. This will be 0 because V1 is equal to V2. For air, this is the formula we are using. For air, we are using this formula of delta S system R log of V2 by V1. This is 0. Now, what is T2? 273 plus 17. And what is T1? 273 plus 317. This is T1. This is T2. And you know it is to be put in Kelvin. CV is 0.718. तो कितना आ गया डेल्टा एस सिस्टम? नेगेटिव में आएगा 2.549 किलो जूल पर केल्विन. किलो जूल पर केजी केल्विन वी कैन टेक. किलो जूल, हाँ हमारे पास मास भी दे रखा है, सॉरी. सो डेल्टा एस सिस्टम अगर मैं मास से भी मल्टीप्लाई कर दूं विच इज 5 kg, मास इज 5 kg, so I am giving you delta system is coming minus 2.5549 kilojoule per Kelvin after multiplying with mass. This is the answer coming for system. How do you calculate delta S of surrounding? It is Q by T naught. This is because heat is going to the surrounding. How do you calculate the Q? MC V into T2 minus T1 over T naught. So because work is not being done, closed system hai, so delta U itself will be Q. 5 into 0.718 into 300. Delta T is 300 over T naught is 290. So what is the value coming? 3.713 kilojoule per kg per Kelvin, sorry. 3.71 kilojoule per Kelvin. So what is asking you is system entropy change and is asking you net entropy change. Net entropy change, you have to add both these two. When you add these two, you get entropy generation also, which is positive. So that means we are getting the answer D. For the process, minus, and for the universe, we get positive. That is how we get it. Right? So I think now, as you were saying, we take a very small brief gap of 10 minutes and we will complete 100 questions. As I told you, you need to sit in live classes. This video may not be available once class is over. You need to sit in live class. And let me tell you, so far we have done now question which is 50 questions are done. So 50 questions over, and we start at after 10 minutes 5:35 p.m. class will resume. So we'll take 10 minutes break, and after 10 minutes 5:35 p.m. we resume the class, and then we start the further questions. Vishal sir will take some questions, and then after that I will also take and complete these 100 questions. So next 50 questions are not, I think this is going to take 2.5 more hours and we complete it. So waiting for you to come back, and then we start it.
Yes, hello guys, welcome on YourPedia platform. So guys, let's start with the question number 37 first. Then we will move to question number 16 also. I think those two questions first we need to cover, and then we will move to another questions. Okay. So guys, as you know, like we are covering all these questions from NPTEL assignment. And yes, there is a very high correlation between previous year gate questions and these NPTEL assignment. Okay. So guys, this is question number 37. Let's first discuss this question. Okay, so yes, so I hope you all have like taken that short break. So now we need to start it again, guys. So please join fast. Yes, Anurag, on website, the file which is available, that is only like file with questions only. For solutions, you need to attend the session. Okay, if you will attend the session, you will find the solution, detailed solution for each and every question. So guys, this is question number 37. There is a piston cylinder device fitted with stops. So this device, which is visible to us, this is a piston cylinder arrangement with stops. As shown in the figure, initially contain 1 kg of water. So this mass of water is 1 kg. This is 1 kg of water at 400 kilopascal, 300 degrees Celsius. 400 kilopascal, 300 degrees Celsius, guys. If you will refer to the steam table, guys, at 400 kilopascal, you will find the saturation temperature in the range of 143.608. So at this range, the T saturation is close to 143.608 degrees Celsius. Easily, if you will refer to the steam table, yes, good evening, everybody. Yes, Abhishek, good evening, all. So at this condition, guys, 400 kilopascal, 300 degrees Celsius, if you refer to the steam table, you will find the saturation temperature. This means that temperature 300 degrees Celsius, which is more than the T saturation temperature, it means we are in the superheated region, means the water which is there inside, it is the superheated water. Superheated water. Actually, it is a superheated steam. Okay, but we are writing it as water only because water, steam, okay, these are actually water, these are actually the phases, liquid, wet region, and you are in the what, vapor region. So those are different phases. So superheated water you are having because the temperature is more than T saturation, and at this temperature we can easily write the enthalpy. यहाँ पे हम enthalpy लिख सकते हैं. So suppose if I will write this condition as 1, this condition, if I will write this as this is 1, okay, this condition is 1. Now what is going to happen, guys? The heat is rejecting from this water, heat rejection is taking place, so heat is losing, this arrangement is losing heat, so the temperature inside is going to decrease. Okay, the pressure is going to decrease, and what will happen? The constant pressure, initially the pressure will be constant. Why? Because if this piston we will assume as a frictionless movement, and the expansion of a piston cylinder arrangement, the compression of a piston cylinder arrangement without friction, we can correlate it very near to a constant pressure process. So initially the process will be a constant pressure process from this to this, up to this. Okay, so this is state 2. This is state 2. From 1 to 2 we will have a constant pressure process. 1 to 2 we will have a constant pressure process, and after 2 to 3, final state will be 3. 2 to 3 will be constant volume. 1 to 2 pressure constant, 2 to 3 volume constant. Okay, now he is asking you, heat rejection from the cylinder continues until the final pressure is 100 kilopascal. Now he is asking you the heat transfer. So let me give you idea, guys, how to solve this problem. इस problem को solve कैसे करना बच्चों? Let me give you some idea. So guys, if you will draw a kind of diagram like here, the TS diagram, suppose this is temperature versus entropy diagram. So this is the initial condition, guys. This is the initial condition. We are somewhere here in the superheated region. We are somewhere here in the superheated region. So initially, what will happen? What will happen? The heat transfer is going to take place at constant pressure. So it will be moved, like suppose this is state 1. So when initially it will be, this is actually a constant pressure line, something like this. This is actually a constant pressure line. So heat rejection will take place and the pressure will remain constant. So this is state 1, this is state 2. And the piston will reach to these stops. Piston कहाँ move कर जाएगा बच्चों? Piston will reach to the stops. So 1 to 2 is a constant pressure process. Okay, and after 2 to 3, because the heat rejection is going to continue, heat rejection रहेगा बच्चों up to what? Up to the final pressure 100 kilopascal. So this pressure line is nothing but this pressure is 400 kilopascal. Okay, and the heat rejection is going to continue up to what? The pressure suppose let me draw it as a PV diagram. मैं थोड़ा सा इसको symmetric बना दिया है, but actually it is not a TS diagram, it is like a PV diagram because I want to draw it as a what constant volume line. तो चलिए मैं यहाँ पे इसको constant volume ले लेता हूँ, something like this. थोड़ा सा मैं इस कर्व को चेंज कर देता हूँ, something like this. So let me take it here pressure, let me take it here volume, and the curve then it will be something like this, something like this. Okay, so this is state 1 superheated. Okay, and then it will be something like this, constant pressure. Okay, then it will be constant volume, something like this. This is constant volume. Okay, so this is state 1, this is state 2, and this is final state 3. This is final state 3, state 1, state 2, state 3. Okay, there is a slight difference because initially we are in the superheated region and finally we are in the wet region. Okay, so now he's asking you the heat transfer in this process, what amount of heat we have transferred. So guys, as we know, at this condition the water is superheated, so I'm going to provide you H1. What is H1? The enthalpy of the superheated vapor, superheated water at 400 kilopascal, 300 degrees Celsius, that is H1, and I'm providing this data. H1 is equal to 3067.1 kilojoule per kg. This is H1, guys. Okay, this is H1, and can I write it here H2? What is H2, guys? H2 is Hg at 400 kilopascal. At 400 kilopascal, Hg equal to H2, because at here the water, until the water exists in the cylinder as saturated vapor. So at stage 2, when the piston is going to rest on the stop, here we will have saturated water vapor. Okay, so that's why I'm writing it here H2 equal to what? H2 equal to Hg. Okay, now from 2 to 3 the process is going to remain constant volume and heat rejection is going to continue up to what? Up to the pressure becomes 100 kilopascal. So this pressure is 100 kilopascal and this pressure is 400 kilopascal. Okay, and this volume both are same. Okay, so can I write it here, guys? V2 is nothing but Vg at 400 kilopascal. Yes or no? What is V2? V2 is Vg at 400 kilopascal. That also you will easily get from the steam table. So let me provide you that data, which is equal to what? यहाँ पे कितना होगा? Vg is equal to let me write it here. So yes, I think this is equal to 0.46, 0.46238. 0.46238 meter cube per kg. Okay, this is specific volume. Yes or no, guys? This is specific volume. Now if you want to find out the heat transfer very easily you can find out. Heat transfer or heat lost, this is nothing but heat transfer equal to Q lost equal to H final, means H3 minus H1. The final enthalpy here, H3 minus initial enthalpy, that is going to give you the total heat transfer. Okay, but this H1 we know from the data which is given to us at 400 kilopascal, 300 degrees Celsius. This is H1. H2, actually there is no such need of H2, but H3, how to calculate that H3, guys? H3 kahan se aayega? H3 is in the wet region, and in wet region you can find out enthalpy as HF plus X HFG. Okay, so these data are required, HF and HFG at what? At 100 kilopascal, because here the pressure is 100 kilopascal. This line is what? This is 100 kilopascal line, guys. This is 100 kilopascal because this is PV diagram. So this horizontal line, this is going to give you a constant pressure 100 kilopascal. So again, if you will refer to the steam table, at 100 kilopascal, this is actually close to what? Atmospheric pressure. So the T saturation will be close to 99 point something, because at 1 atmospheric the boiling point is close to 100 degrees Celsius. So at this HF I'm providing you HF. मैं आपको HF लिख देता हूं. So HF is 417.50 and HFG is 2257.4. Okay, this is HF kilojoule per kg and this is HFG in kilojoule per kg. Okay, but for finding out H3 you require X. Without X you cannot calculate H3. Without X, guys, you can, because if you don't know the dryness fraction here, how you will be able to find out the enthalpy in the wet region, guys? So you need to calculate the X3, and from where you will get X3, guys? X3 kahan se aayega? X3 you will get by comparing V2 equal to V3. Okay, so V2, which is known to us, because V2 equal to Vg at 400 kilopascal. At 400 kilopascal Vg, this also we know from the steam table. And Vg, if you will equate this V2 equal to Vg at 100 kilopascal, which is 0.46238. So this is nothing but Vf plus x Vfg at 100 kilopascal. So at 100 kilopascal, if you know about Vf and if you know about Vfg at 100 kilopascal, easily you will get the x. Okay, ऊपर नहीं दिख रहा है, चलिए मैं थोड़ा सा इसको रिमूव कर देता हूं. तो मैं यहां रिमूव कर देता हूं बच्चों. लेट मी रिमूव इट हेयर. ओके, सो मैं यहां लिख देता हूं. लेट मी राइट इट हेयर गाइस. चलिए, so what I want to say guys, V2 equal to Vg and this is equal to V3 and this is equal to what? 0.46238, because 2 to 3 we are having a constant volume process. Okay, and this V3 0.46238 in the wet region is nothing but Vf plus x Vfg. Okay, x Vfg. So if I will provide you some data guys, अगर मैं आपको कुछ डेटा दे देता हूं at 100 kilopascal, suppose Vf equal to 0.00104,315 meter cube per kg. Similarly, Vg is equal to 1.6939 meter cube per kg. Okay, so I'm providing you some data at 100 kilopascal. This is Vg, this is Vf. Okay, putting all these things guys, you will be able to calculate x. Now can you tell me what value of x you are getting guys? Can you tell me what value of x you are getting? So V3, which is equal to V2, and V2 equal to Vg at 400 kilopascal. So at 400 kilopascal from the steam table, if you refer, you will get this value 0.46238, which is equal to V3, and V3 is in the wet region, which is equal to Vf plus x Vfg, and in the wet region at 100 kilopascal, easily you can find out Vf, which is equal to 0.00104315, and Vg equal to 1.6939 meter cube per kg. Now solving all these things guys, can you tell me what x value you are getting? What is the x value you are getting guys? Please tell me what is the x value you are getting? चलिए, yes, please try to tell me what x value you are getting guys. Let me again put it in front of you. Yes, so what x value you are getting guys? Dryness fraction. Yes, very good. Those are getting x equal to 0.23. You are going to get x equal to 0.2725. Okay, and now if you know this, easily you can define H3. So H3 equal to HF plus x HFG. Okay, x HFG. So H1, already I provided you H1 at this condition. H1 equal to 3067.1 kilojoule per kg. Okay, and H3, if you will solve it from here at 100 kilopascal, this is at 100 kilopascal. Okay, putting all these values here, so this is nothing but 417.50 plus 0.2725 into HFG is equal to, I'm directly writing HFG, which is 2257.4. Okay, solving this, you will get H3 equal to 1032.6145 kilojoule per kg. Okay, further guys, if you want to calculate heat transfer, so Q lost equal to final enthalpy, because this is coming out negative because it is the enthalpy is losing, the final enthalpy is less than the initial enthalpy, so this is equal to change in enthalpy, and this is nothing but H1 minus H2 या H3, इसको मैं लिख देता हूं, this is nothing but H3 minus H1 into mass. And what is the mass guys? Mass is given to you 1 kg only. Okay, mass is 1 kg only. So if you write it here, this term like 1032.6145 minus 3067.1, you will get the answer guys. Okay, please tell me what answer you are getting. What answer you are getting, guys? Now, can you tell me? Yes. So you are going to get answer option C. Very easily, simply you will get the option C as the right answer. So what concept actually we are getting from this question, guys? How to draw actually these process on what PV diagram, how to find out the heat transfer, okay, how to find out the dryness fraction. Lots of question can be framed from this single question only, guys. He can ask you the dryness fraction, like if those property data is given to you, he can ask you the final dryness fraction. Like initially you are having the superheated water vapor inside this, what is the final dryness fraction, okay. And he can ask you something about entropy change also, all those things also. Like if all property table data are given to you, like what is the entropy change again, कैसे निकालोगे, like at this superheated condition what is S1, that is also you can get, like the super from the superheated property table, you know entropy of the water at 400 kilopascal and 300 degrees Celsius. Similarly, entropy in the wet region also you will be able to calculate with the same process, okay. S final means S3 equal to SF plus X SFG, okay. तो वहां से भी अगर आप सिमिलर प्रोसेस कैरी आउट करोगे, you will get the final entropy, okay. And then if you will carry out the exercise, you will get the change in entropy also, because as here you can see the temperature is decreasing, okay, and you know the heat is rejecting, so the entropy of the water is going to decrease, but the entire heat is going out, so the entropy of the surrounding is going to increase. So first, by adding that entropy change of the system means water plus entropy change of the surrounding, you will get the entropy generation. So lots of questions can be framed. So I hope this question is very much clear to you, okay. Let us now move to the 16th question, guys. I think that also initially we have not covered. Question number 16. So let me put it here in front of you. Yes. So this is question number 16. Please refer this diagram, guys, and the concept is more important. Rather than answer, exact answer, the concept is more important. So let me give you some kind of idea how to approach, how to solve this question. So what is saying, guys, there is an insulated piston cylinder arrangement. So this arrangement, which is insulated, okay, ये insulated है, initially contain 8 liter of saturated liquid, okay. Initially it is having 8 liter of saturated liquid, okay. So the entire liquid which is there is saturated liquid. Kitna? 8 liter, okay. And can I say this is 8 kg? Because for water, 1 liter equal to 1 kg, okay. So the initial mass of the water is what? 8 kg, and entire is what? Saturated liquid, okay. And the pressure is what? The pressure is what? Pressure is 175 kilopascal. Pressure is 175 kilopascal. Okay, now this water, the saturated liquid, is stirred with the help of some kind of this arrangement, okay. So you are stirring it with this arrangement, and also you are heating it with some kind of resistive element, okay. So this is some kind of element, through some voltage current you are passing, okay. There is some voltage difference, okay, and some current you are passing. इसमें से आप क्या कर रहे हो? कुछ current pass कर रहे हो, okay. So some electric work you are supplying, so that the energy of this will increase, okay. Now what you are doing? A flow for 45 minutes is allowed in the resistor placed in the water. Assume pressure of the water to be constant during this process, okay. One half of the liquid is evaporated. This point is very, very important, guys. One half of the liquid is evaporated. One half of the liquid is evaporated during this constant pressure process, okay. So when you are heating, like with this resistive element, and you are stirring it with this system, so the pressure is constant. You can assume the pressure constant, which is also mentioned in this diagram also, okay. Now he's saying the paddle wheel work amounts to this. So the paddle wheel work you are giving, so W paddle wheel, okay, W, what you can say, W which you are supplying, paddle wheel, this is nothing but 800 kilojoule, okay. 800 kilojoule. Obviously this will be negative because this is work done on the system, okay. This is work done on the system. Now determine the voltage of the source. He is asking you the voltage of the source. कैसे निकालोगे बच्चों आप? How you will find out the voltage of the source? Now let me give you some kind of important data which is required at this pressure, guys, because pressure is constant. Clearly he has mentioned the pressure is constant, and at this pressure 175 kilopascal, only two data are required. What are those two data, guys? HF and HFG, okay. HF at this pressure 0.175 kilopascal. So at HF is close to this 486.96 kilojoule per kg, and HFG is equal to 2212 something close to this kilojoule per kg. Okay, so at this pressure 175 kilopascal, the HF is this and HFG is this. Okay, now let me give you some kind of idea. मैं आपको एक hint देता हूं because that hint is important, required. What is that hint, guys? The one half of the liquid is evaporating. Initially you are having what, like अगर आप इस process को draw करते हो like on some kind of diagram, like something like this. So this is your initially condition. The entire liquid is in what, saturated liquid condition. So one half is evaporated at constant pressure. The process is constant pressure, and you know during the phase change both pressure temperature remains constant. So it's a kind of phase change process. Okay, so both pressure temperatures are constant. So this is final condition somewhere here. So this is state 1, this is state 2. This is final condition in somewhat wet region. This is initial condition, saturated liquid, final condition in the wet region. And he's saying one half is, like evaporated. So can I say x2 is equal to 0.5? क्या मैं लिख सकता हूं बच्चों? Can I write x2 equal to 0.5? Yes or no? Very, very clearly I can write x2 equal to 0.5. Why? Because the 8 liter saturated liquid which you are having initially, one half of that means 4 liter is converted into vapor. Means now in that piston cylinder arrangement, 4 liter is vapor, 4 liter is liquid. Means the dryness fraction is what? Dryness fraction is 0.5. What is dryness fraction? Mass of the vapor divided by total mass. So means 4 liter, 4 kg divided by 8 kg, you will get it 0.5. So the dryness fraction here is 0.5. Okay, now can you tell me like how much heat you are supplying to this water? How much is the change in enthalpy of the water, guys? How much is the change in enthalpy of the water? Okay, because entire energy which you are giving, like by this paddle wheel arrangement and by this resistive element heating, entire work which you are doing on that water, that is going to increase its energy. Okay, because it is not a constant volume process, so it is going to increase its what's enthalpy. Okay, so the change in enthalpy, if you know for the water, if you know its change in enthalpy, that you can easily equate it with what, guys? That you can equate it with the work which you are doing on the system. Okay, are you getting the idea, guys? Very simple energy balance. So change in enthalpy of the water will be what? Can I write this change in enthalpy? Change in enthalpy of the water equal to the total content. How much is the total content, guys? 8 liter, 8 kg. That is equal to x HFG. Okay, guys, what is this? What is this? This is specific change in enthalpy, delta H. Specific change in enthalpy in the wet region. How we write specific change in enthalpy, guys? I'm not writing like here H1 or H2. I'm not defining H2, guys. Directly, I want to write it here, the change in enthalpy. Okay, the change in enthalpy will be what? H2 minus H1, and that will be what, guys? That will be X times, X means dryness fraction, HFG. Yes or no, guys? So can I write here the H2 minus H1, the specific change in enthalpy, H2 minus H1 equal to X HFG. What is X? That we know. What is HFG? That also we know. 2 kilojoule per kg. Yes or no, guys? So solving this, you will get the change in enthalpy of the water. Yes, please tell me. Now these all things you can equate with what, guys? इसको किससे आप equate कर सकते हो? Okay, so let me write it here. मैं यहाँ पे remove कर देता हूँ. So these all things you can equate it here. The change in enthalpy of the water, this change in, because you need to multiply it with 8. Why? Because these are going to give you in kilojoule per kg. This data is going to give you specific change in enthalpy in kilojoule per kg. But what is the total content, guys? Total content is 8 kg. Okay, so 8 multiplied by X HFG. That's why I'm writing it something like this. So this is change in enthalpy of the water. Change in enthalpy of the water. This is equal to what, guys? This is equal to the paddle wheel work. Okay, plus what? Plus equal to what? This electric work, W electric. Paddle wheel work plus electric work. Yes or no? Paddle wheel work plus electric work. Or like you can ask me, sir, from where you are writing this? Guys, this is a closed system. So you know dQ equal to dE plus dW. Okay, dQ equal to dE plus dW. As clearly he has mentioned, this is actually an insulated arrangement. So this arrangement you can write it as 0 equal to change in enthalpy. Okay, minus electric work minus paddle wheel work. Both works are negative. Both works are negative. Why? Because electric work is also work done on the system and paddle wheel work is also work done on the system. Heat transfer is 0 because the entire arrangement is insulated. So then easily you will get the formula dH change in enthalpy. Like it is better to write it as delta H. Delta H, change in enthalpy of the water. This is equal to W electrical plus W paddle wheel. Okay. Yes or no, guys? Okay. Now let me again write it here. Some answer in front of you. So what is paddle wheel work, guys? Paddle wheel work is 800. It is given to us. Paddle wheel work is 800 kilojoule. And what is electric work, guys? What is electric work? What is electric work? So can I write it here? Electric work, W electrical is equal to VI, voltage into current. Okay, this is VI. This is going to give you answer in watt, but we want it in kilojoule. हमें किसमें चाहिए? Kilojoule में. Okay, why? Because these all things are in kilojoule. This is change in enthalpy in kilojoule. This is paddle wheel work in kilojoule. So we want this also in kilojoule. This is in watt. VI, the product of VI is in watt. Okay, but we want this in kilojoule. So first you need to divide this VI divide by 1000 to convert this kilowatt watt into what? Kilowatt. I am dividing it by 1000. Further, you need to divide it by time, multiply by time. आपको इसके साथ time के साथ क्या करना पड़ेगा? Multiply करना पड़ेगा. As it is given, this resistor is allowed to run for a period of 45 minutes. So you can write it here 45 into 60. Okay, 45 into 60. Okay, now if you will write all these things here, guys, this is delta H. This you will get, already I mentioned from where you are going to get this delta H, and this you can write it is equal to 800 plus the paddle wheel work. Sorry, this is paddle wheel work. Let me write it something like this: paddle wheel plus electric work. So this is paddle wheel work, and the electric work will be V into I. The current is given to us 8 ampere. So V into 8 into 45 into 60, and the all things you need to divide it by 1000. Solving this easily, you will get the voltage. There is only one unknown data, which is voltage, and I hope you all are getting the answer. Voltage. Please check, please calculate your answer and tell me what answer you are getting, guys. Okay, थोड़ा सा exact answer नहीं आएगा, approximate answer you are going to get. Okay, some approximate answer you are going to get. Actually you will get the answer in the range of this close to 370. Okay, तो 370 वोल्ट के आसपास आना चाहिए आपका आंसर. 370 372 वोल्ट, something like that. Okay, 370 370 volt you are going to get, and that is right, I think. Okay, वो बिल्कुल सही है. So I think that will be the right answer. If you are getting answer in the range of, like if I will provide you the range, if you are getting answer in the range of 365 to 380 volt, if you are getting answer in this range, your answer is right, guys. 365 to 380 volt, if in this range you are getting the answer, your answer is right. Okay, because guys, in this question he is going to provide you data at this pressure, initial pressure 175 kilopascal HFG. If he will provide you that data, easily you can calculate. Very good, Mayur, Shashwil, very good, right? Those are getting answer in this range, they are very right. Okay, so guys, from this question, I hope you are getting the idea about the energy balance. Okay, so these two questions we have discussed, question number 16 and 37. Now let us move to some more question, guys. कुछ और question पे move करते हैं. चलिए, so let me put it here. चलिए, because next half an hour we are going to discuss like some more questions which are on the same line, and then Vijayender sir will join, and he will continue. Chaliye, so there is a question, very good question. Let me put it here. Yes. So this is question number 74. I hope this file is with you, like you all are having this PDF file, so you can refer to that from your mobile also. So please try to answer this question. बहुत अच्छा question है बच्चों. Please try to answer this question. So there is a piston cylinder device initially contained 0.5 meter cube of nitrogen gas at 400 kilopascal, 27 degrees Celsius. A electric heater within the device is turned on and is allowed to pass a current of 2 ampere for a time t. Okay, from a 120 volt source, nitrogen expands at constant pressure. So this point is very important. Piston cylinder arrangement, constant pressure, by the resistive heater with a heat loss of this. So heat loss is also given to us 5 kilojoule. Occurs during the process. If the temperature rises 30 degrees Celsius, then determine the time used for heating. Time used for heating. बहुत अच्छा क्वेश्चन है बच्चों. Cp is given to you for the nitrogen 1.039 kilojoule per kg Kelvin. R is also given to you 0.297 kilopascal meter cube per kg Kelvin. Okay. So he is asking you the time for heating. So let me give you some hint, guys. You can also try. So there is a piston cylinder device, something like this. There is a piston cylinder device. Okay. This is a piston cylinder device. Initially contain nitrogen. So this volume V1, suppose this is state 1. I'm writing this as state 1. So V1 equal to 0.5 meter cube and the P1 is 400 kilopascal, which is constant, guys. The pressure is not going to change. When you are supplying heat, because with some kind of resistive heater, because there is some kind of resistive heater is attached, you are supplying some kind of voltage or current. Voltage kitna pass kar rahe ho? Voltage is 120 volt. And suppose current is what? Current is 2 ampere. Okay, voltage, current, both are given. Time is not given. Okay, time is not given. Okay, time is not given to us. He has mentioned here the final temperature is 30 degrees Celsius. The pressure is constant. Okay, pressure is constant. So when it is going to expand, because you are supplying, you are heating it, this gas, by using this kind of resistive element, so the gas you are heating, so it is going to expand. Okay, so he is asking you for what time, how much time you run this system. If the final temperature change, the change in temperature is 30 degrees Celsius. So guys, as you know, this is actually a closed system. Piston cylinder arrangement, it is a closed system. So you can write it as dq equal to du plus dw. Yes or no? Closed system, it's a closed system. Neglecting the kinetic and potential energy changes, we can write first law of thermodynamics for a closed system, dq equal to du plus dw. Yes or no, guys? dq equal to du plus dw. But in this equation, what you need to analyze? First, there is a heat lost. Kitna heat lost hai? 5 kilojoule. So this must be 5 minus 5 kilojoule. Minus 5 kilojoule. This is equal to heat lost by the system. du, what is du, guys? Change in internal energy of a nitrogen. Guys, nitrogen we can treat it as an ideal gas, although it is not mentioned in GATE. He is very crystal clear, very clearly he is going to mention, consider it as an ideal gas. But you know, guys, what, like the thermodynamics we studied at graduate level, we are not going to calculate all those things. Although, like some formula you need to know how we write the change in internal energy for a real gas. You know, in those last chapter, thermodynamic relationship, we derive some kind of expression for the change in internal energy of a real gas. Okay, so safer side, you need to know the formula. But all thermodynamic problems which you are going to get, in those we generally consider gas as a ideal gas. So nitrogen is there, and nitrogen we can consider it as an ideal gas. And for ideal gas, the change in internal energy is equal to mcv dt. This is mcv dt. This is mcv dt. Yes or no? This is heat loss, this is change in internal energy, plus work transfer. There are two works, guys. One is the electric work which you are doing on the system. So this will be minus electric work. So W electric plus, इसको मैं लिख देता हूं electric, EL. Okay, so this is electric, and there will be plus what? Boundary work, you can say. This is boundary work, okay, or expansion work. So there are two works. One is the work done on the system, and another is the expansion work which you are going to get, because when you are heating this gas, the gas is going to expand at constant pressure, and you are going to get some positive work. Yes or no? So there are two work involved. दो work involved है इसमें. So now he has given you, like this data he has given you. आपसे देखो यहाँ पे उसने क्या दिया है, like you know pressure is constant. Pressure क्या है बच्चों? Constant है. And if pressure is constant for an ideal gas, can I write it as V by T equal to constant? Yes or no? And can I write it as V1 by T1 equal to V2 by T2? Yes or no? V1 by T1 equal to V2 by T2? Yes or no? If pressure is constant for an ideal gas, V by T equal to what? Constant. So V1 by T1 equal to V2 by T2. What is V1, guys? V1 is 0.5 meter cube. So 0.5 meter cube divided by V2 equal to T1 by T2. What is T1, guys? T1 is this 27 degrees Celsius. So T1 is 300 kilopascal. Okay. T1 is 300 degrees Celsius. Okay. Temperature rises by 30 degrees Celsius. So T2 is 330. T2 कितना हो जाएगा बच्चों? 330. Yes or no? The temperature rises by 30 degrees Celsius, means the initial temperature is 27 degrees Celsius, means 300 Kelvin. So the final temperature is 330 Kelvin. So this is initial temperature T1, and this is final temperature T2. This is initial volume. From this, easily you will get V2. Final volume you will get. Yes or no, guys? Easily you will get the final volume. Okay. So mass we know. Mass easily. Mass आपके पास आ जाएगा. देखो अभी आप कहोगे सर मास कहां से आएगा, देखो मास m, mass of a ideal gas, mass equal to PV by RT. Yes or no? From ideal gas equation, mass of nitrogen equal to PV by RT. So what is P? Pressure is 400 kilopascal. So 400 kilopascal. Volume is 0.5. Initially, the volume is 0.5 meter cube. R is what, guys? R is given to us. Don't take R 0.287. R is 0.287 for what? For gas, for air. For air, R is 0.287, but for nitrogen, it is what? Universal gas constant divided by the molecular weight of nitrogen. Okay, so which is also directly given to us 1.039. So you need to take this value only into temperature, which is 300 Kelvin. तो इसको सोल्व करोगे बच्चों, you will get the mass of nitrogen. You will get mass of nitrogen. Yes or no, guys? Solving this, you will get a mass of nitrogen. So this mass you need to put it here. उस mass को आपको यहाँ पे put करना पड़ेगा. CV is what, guys? CV is nothing but R minus CP is equal to CV. Why? नहीं, ऐसे लिख देते हैं. CP minus CV equal to R. Yes or no? CP minus CV equal to R. Okay. So if you want to calculate CV अगर आपको निकालना है, so CV equal to CP minus R. Yes or no? CV equal to CP minus R. So CP is given to us. CP is given to us. This. Okay. This is not R, guys. This is CP. मैं यहां लिख देता हूं. This is CP. So R is this. R is this 0.297. 0.297. Sorry for this. Okay. This is CP. This is CP. Specific heat at constant pressure. This is R. Okay. So we need to write it here R. So I corrected already. So this is pressure 400 kilopascal. Volume is 0.5. R is 0.297. And the temperature is 300 Kelvin. Solving this, you will get the mass of the nitrogen, and specific heat at constant volume you will get by subtracting R from CP. CP is given to us, R is given to us. The difference you will get CV. Okay, very good, very good. Love Prakash, आपका आंसर बिल्कुल सही है, बिल्कुल सही. Okay, so you will get CV also. The change in temperature is already given to us 30 degrees Celsius. The change in temperature is already given to us 30 degrees Celsius. Yes or no, guys? Okay. So this we know, and this entire term we know, and this is going to come out positive. ये positive आएगा. Okay. Now, what is expansion work, guys? What is expansion work? The process is constant pressure. So can I write this as PdV, P into V2 minus V1? Yes or no? Can I write this as expansion work as P into final volume minus initial volume? Yes or no? Yes. And what is final volume, guys? This final volume we know from this is पूरे simplification say you will get the final volume, and initial volume is already given to us 0.5 meter cube. Okay, so pressure is known to us. The pressure is 400 kilopascal, which is constant. So 400 multiply by V2 minus V1, you will get the expansion work, and this also will come out positive. This is positive, this is also positive. Okay, this is negative. इस पूरे को solve करोगे, you will get electric work. Okay, you will get electric work, guys. Yes or no, guys? How many of you are getting the electric work? Please tell me. How many of you are getting the electric work, guys? And that electric work easily, if you will equate, उस electric work को आपको क्या करना पड़ेगा बच्चों? You need to equate W electric with equal to voltage into current into time. So voltage is given to us 120, current is given to us 2 ampere. The time we want to calculate, easily you will get the time. But answer आपका second में आएगा. आंसर किसमें आएगा आपका सेकंड में, बट ही वांट्स आंसर इन मिनट. सो यू नीड टू डिवाइड दैट बाय व्हाट 60. यू विल गेट द आंसर इन मिनट, and you will get answer close to 5 minutes. So I hope you all are getting answer close to 5 minutes. Yes, please tell me how many of you are getting answer close to 5 minutes. रोशन बिल्कुल सही है आपका आंसर. चलिए, वेरी गुड. चलिए, so let us now move to next question, guys. I hope this question is very much clear. Yes, 5 point something आएगा, बिल्कुल बिल्कुल सही. 5 point something आएगा, तो you can answer this question because these options are very, like, there is a huge difference. 5, 15, 25, 30. Okay, this is a kind of objective question. So if you're getting answer close to 5, means your answer is right. Okay, चलिए, बिल्कुल सही. Let us now move to next question, guys. Next question पे move करते हैं. थोड़ा से कुछ similar type of question थे. So let me put it here. Those questions. मैं इस पे भी आऊंगा. I will come back to this question also. But first let us solve these questions. Okay, चलिए. तो पहले इस क्वेश्चन को मूव करते हैं. So this is question, guys. This is another question we are going to solve. Another question, guys, we are going to solve. Acha question, and this is slightly different question. So what is saying? There is a cylinder fitted with a piston as shown in figure. So this is cylinder fitted with some kind of piston as shown in the figure. Initially contained 0.2 meter cube of fluid. Okay, so this is containing fluid which is having volume 0.2 meter cube. Okay, at pressure, this is volume, this is pressure, 200 kilopascal. Okay, 200 kilopascal. Heat is transferred to the fluid. You are transferring heat. आप heat transfer कर रहे हो बच्चों. As a result, the fluid is expanded in a constant pressure quasi-static manner. The pressure, it is going to expand at constant pressure. Okay, it is going to expand at constant pressure. Okay, till the volume becomes what? Thrice, means the final volume V2 equal to 3 times of V1. The V2 equal to 3 times of V1. This is also given to us. The piston is then locked. Piston को आपने क्या कर दिया? Lock कर दिया. So this is state 1 and this is state 2, something like this. आपने piston क्या कर दिया? Lock कर दिया. This is state 2. Okay, this is state 2 and heat transfer continues. Heat transfer अभी भी हो रहा है. It is not like that कि at this process heat transfer stops. It is not like that. Heat transfer is continuous up to what? Up to the final pressure 100 kilopascal. Okay, up to the final pressure 100 kilopascal. The internal energy of the fluid is given by this relationship. The internal energy of the fluid is given by this relationship. Okay, now he's asking you if U is in kilojoule in this relationship. If U is in kilojoule, P is the pressure in kilopascal, V is the volume in meter cube. Can you find out the total heat transfer in this case? Can you find out the total heat transfer in this case, guys? So let me again tell you what is the question, guys. There is a piston cylinder arrangement. This piston is freely able to expand. There is no friction. You are supplying some heat to the fluid which is initially having volume 0.2 meter cube, pressure 200 kilopascal. So it will expand, it will move to some position where it will be locked by some kind of pin. Okay, after reaching to that point also, the heat transfer is going to continue. Okay, up to what? Up to the final pressure 100 kilopascal. Okay, up to final pressure 100 kilopascal. Chaliye. So the internal energy of the fluid is given by this relationship. The final volume is equal to 3 times of the initial volume. He's asking you the total heat transfer. Total heat transfer. Can you answer this question, guys? Can you answer this question? So guys, in this question, first thing, we want to calculate the heat transfer. Okay, so let me write it here. Again, it's a closed system. Yes or no? Closed system. So can I write first law of thermodynamics as dq equal to du plus dw? Yes or no? dq equal to du plus dw. This heat transfer we want to calculate. This is heat transfer we want to calculate. Okay, this we want to calculate. What is du? This is change in internal energy. So this is state 2. I don't know, like this is the final state, but I'm writing final state as 3. मैं 3 को लिख रहा हूँ final state. 3 is the final state. Okay, 3 क्या है मेरी final state? Because 2 I mentioned as a state when the piston reached to the pin. Piston कहाँ पहुंच गया? Pin पे पहुंच गया. But he mentioned कि you are continuing the heat transfer up to final pressure 100 kilopascal. So I'm writing the final state with 3. Okay. So what is change in internal energy, guys? The change in internal energy is U3 minus U1. Yes or no? U3 minus U1 is a change in internal energy. Yes or no? Yes. What is work, guys? Is there any work supplied to this system? No. There is no work supplied. There is no pedal wheel arrangement. There is no such kind of electric element added. So there is no such work input. But we are getting the expansion work because boundaries of a closed system are expanding, and when boundaries of a closed system are expanding, we are going to get the positive work. So this work will be positive, and at constant pressure we can write that work as P dV. P V3 minus V2, and you know V3 is equal to V2 only. This is equal to V3 because after reaching to this position, the piston will be locked by some pin. So V3 is going to equal to what? V3. V2, V3 both are same. So this is final state. I'm writing this as a final state. Okay, this is final state. Okay, and this volume, this is both are same. Yes or no, guys? So can I write this as 2? This इसको मैं क्या लिख सकता हूँ? This is U3 minus U1 plus pressure. What is pressure, guys? Pressure is constant, 200 kilopascal. 200 kilopascal. And can I write this as 2V1? Yes or no? Because V3 equal to 3 times V1. V3 equal to 3 times V1. So 3V1 minus V1, you will get 2V1, and V1 is this. Okay. So V1 is also given to us 0.2 meter cube. Okay, 0.2 meter cube. So these all things we know, the expansion work we know, and this change in internal energy you will get from this relationship, guys. This relationship say easily you will be able to calculate the change in internal energy, because U1 is equal to 3.4 P1 V1 plus AT. So this is the relationship which is given to us for the internal energy. U1 equal to 3.4 P1 V1 plus AT. U2 equal to 3.4 P2 V2. Let me write it as U3. मैं इसको U3 लिख देता हूं. So this is U3 equal to 3.4 P3 V3 plus AT. Okay. P3 V3 plus AT. So you need to remember one thing, guys. What is P3? P3 you need to take 100 kilopascal. P3 equal to 100 kilopascal. The final state is what? Where the fluid is reaching a pressure 100 kilopascal, and the final volume, this is final pressure, and the final volume is V3. Yes or no, guys? Is that clear? The final volume is V3, the final pressure is 100 kilopascal. All these data we know, so easily you will get a U1 also, you will get a U2 also in kilojoule. आपके पास ये आंसर किसमें आएगा? You will get this in kilojoule. Okay, so this is in kilojoule already. This also you are going to get in kilojoule, because we are taking the volume, not specific volume. Okay, we are taking the volume only. So the pressure in kilopascal into change in volume, you will get all these things in kilojoule. Okay, तो आपके पास क्या आ जाएगा? Heat transfer. So guys, if you are getting the answer in this range, अगर आपका आंसर 130 150 के बीच में आ रहा है, your answer is right. Please tell me how many of you are getting answer in this range. Okay, 216 is not right. You are making some kind of mistake, Vishwanath. Okay, I hope this is not the right answer for this question. You need to again check your answer. Okay, आपको अपना आंसर बिल्कुल चेक करना पड़ेगा दोबारा. Yes, please check your answer. I'm not asking you about change in internal energy. मैं आपसे चेंज इन इंटरनल एनर्जी नहीं पूछ रहा हूं आपसे. हाँ, अगर ये भी आ रहा है, बिल्कुल मैं इसको थोड़ा सा ब्रॉड कर देता हूं, बिकॉज फॉर दिस बिकॉज दिस इज गिवन टू अस इन दिस रेंज, ऑप्शन ए इज गिवन टू अस, बट मैं थोड़ा सा इस रेंज को बढ़ाना चाह रहा हूं. सो आई एम गिविंग यू अ रेंज, आई एम गिविंग अ रेंज 120. मैं इस रेंज को थोड़ा बढ़ा के दे रहा हूं, सो दैट इफ एनीबॉडी इज लाइक नॉट अप्रोक्सीमेटिंग ऑल दोस थिंग्स, देन आल्सो यू विल गेट द आंसर. 148 तो बहुत ज्यादा हो जाएगा जगदीश, 148 तो नहीं आना चाहिए. इन दिस रेंज, आई थिंक इन दिस रेंज यू नीड टू गेट द आंसर. मैंने थोड़ा सा बढ़ा दिया है. सो ऑप्शन ए, दे मेंशन्ड ऑप्शन ए एज द राइट आंसर. Option A as the right answer, but if you're getting answer in this range 120 140, your answer is very right. Okay, so please check and please confirm how many of you are getting the answer for this question, guys. Please confirm, is this right? How many of you got the answer for this question? बहुत अच्छा question है, different question है थोड़ा सा. He asked you about the heat transfer, so first you need to apply the first law of thermodynamics, but you need to consider here, in the earlier case there were like electric work also and the boundary work also, but in this case we are having only the expansion work, PdV, at constant pressure without any friction. The expansion work we can write it as PdV. Okay, integration PdV is your reversible work. विश्वनाथ चेक करो बच्चों, 148 तो नहीं आना चाहिए, इतना ज्यादा वेरिएशन नहीं आएगा. Okay, so you are giving 148 answer for the earlier question or this question, I don't know. चलिए, so in this range मैंने थोड़ा सा इसको बढ़ा दिया था, because then you will get the answer. चलिए, so I hope this is very much clear to you. Let us now move to next question, guys. Next question पे move करते हैं. So this is again the similar type of question, you know guys, earlier also we solved. अच्छा नहीं, अभी इसको हमने नहीं solve किया है. So this actually we have not solved, but there is slightly different question, different data. So this is question number 85. There is a piston cylinder device fitted with stops. अभी ये piston cylinder arrangement है, this is fitted with stops, initially contain 1 kg of water at this condition. अच्छा, similar kind of question है, data is also very much similar, but like you know, in initial question like he mentioned about the heat transfer. Okay, exact answer he asked you, and in this question he is asking you the range. आपसे क्या पूछ रहा है? Range पूछ रहा है बच्चों. So I think this question is very much similar to question number 16, I think. Let me check. 16 37. Let me check the question. Yes, this question is very much similar to question number 37. Please refer to question number 37, guys. अभी हमने उसको solve किया था. Question number 37. Okay, so you know guys, in NPTEL assignment also, like different professor sometime, like suppose they launched some course like in year 2018. So they provided some kind of assignment, and suppose again in year 2020 they are launching that module. So sometime with very little changes they introduce similar type of question. So because this question also we added in the assignment, but this question is very much similar to the 16th question which we have solved. So if you refer to the data, all things are same. So this is condition, the superheated water vapor. Okay, this is going to be stopped by these arrangement. Okay, he is asking the heat transfer, and you know guys, when we solved this question 37, we calculated the heat transfer, heat lost equal to minus 202033 kilojoule. You know guys, this also we calculated. अभी हमने थोड़ी देर पहले इसको सोल्व किया था, yes or no? अभी थोड़ी देर पहले इसको हमने सोल्व किया था, and similarly in this question you will solve, you will get the answer in this range 200 2000 to 2100. Okay, so very similar question. So I'm not solving it again because this question is very much similar. Yes, Love Prakash Gupta, very much similar question. There is only different in different options have option that professor has changed. Okay, but entire question is more or less is same. So there is no need to again solve this. So let us move to the next question guys. Next question पे move करते हैं. Now this question is different guys. ये question थोड़ा अलग है अभी. Why it is different? Because in this case he has given you the case where you are supplying the heat. Okay, in this case you are supplying the heat, and this question is very much important also because like earlier question number 16, question number 37 and this 84, if you're not solved, so then you can apply your mind here on this question and you need to try. Let me give you the hint guys. So there is a piston cylinder device containing 4 kg of saturated liquid. So initially you are having saturated liquid. Initially you are having saturated liquid. कितना kg है बच्चों? M equal to 4 kg. Okay, saturated liquid mass equal to 4 kg. Saturated liquid vapor mixture of water. अच्छा, अपने को नहीं पता 4 kg of saturated liquid water vapor mixture बोल रहा है. Okay, so I'm not writing it as saturated liquid. So this is actually mixture. Okay, this is actually mixture. So we don't know what this is a saturated liquid or like it is a mixture. So this region is in the wet region. So initial state of the water is in the wet region, because he is not saying this is saturated liquid or saturated vapor. He is saying it is a mixture of saturated liquid and vapor. So this water condition is in the wet region. At pressure, what? The pressure 150 kilopascal. Okay, 3 kg of the water is in the vapor phase and rest is in the liquid phase. Very important data guys, he is providing you. बहुत important data अपने को दे रहा है. 3 kg of the water is in vapor. So how much is the mass of vapor? Mass of vapor is 3 kg. How much is the mass of liquid? Mass of liquid is 1 kg. So what is the dryness fraction? Sir, dryness fraction is mass of vapor divided by total mass. So this is 3 divided by 4. So this is 3 by 4 is the what? This is 0.75. X equal to what? 0.75. Okay, because the initial point is in the wet region, and in that wet region he is providing you the what? Dryness fraction. So this water is in the wet region, and at this condition the dryness fraction is 0.75. This data he has provided you. Okay, 3 kg water vapor and 1 kg is in liquid phase, so the dryness fraction is 0.75, and the piston is resting on the stop. So this is state 1 guys. Piston is resting on the stop. Now you are supplying the heat. आप heat supply कर रहे हो to the water, as a result of which the pressure of the water increases. When the pressure inside reaches 400 kilopascal, so initially guys from state 1 to 2, state 1 to 2, the process is what? Process कैसा होगा? Volume constant. Constant volume heat addition. Process 1 to 2 will be constant volume heat addition. Why? Because you are supplying heat, the pressure is increasing, but the piston is not moving. Why? Because minimum pressure of 400 kilopascal is required. Okay, where the piston starts moving. 400 kilopascal tak piston is not going to move, so the process is going to remain constant volume process. So 1 to 2 is constant volume. At 2, at pressure, because at this point the pressure reaches to 400 kilopascal. Okay, 400 kilopascal. Then the piston starts moving. Piston क्या करेगा बच्चों? Move करना शुरू करेगा, and the final volume, like I am writing this final state as 3. Final state को मैं क्या लिख रहा हूँ? 3, and that process we can write it as what? Constant pressure. Okay, so 1 to 2 is constant volume. 2 to 3 is constant pressure. How you can say? Because 1 to 2, when you are supplying the heat, the piston is not moving, means the entire mass is enclosed in a kind of fixed region. So the process is constant volume. Now again you are supplying the heat, the piston is going to move, so the process will become constant pressure. And the final volume guys, देखो यहाँ पे V1 is what? V1 is what? V1 is he has given you some data. No, he has not provided you, but we can easily get this. ये अपने पास आ सकता है. This V1 easily we can calculate. From where, guys? This we can calculate from specific volume into mass. So mass we know 4 kg. If you able to calculate V1, you will get the volume V1. आपके पास V1 आ जाएगा. But from where you will get V1, guys? From where you are going to get the V1? V1 equal to Vf plus X Vfg. Okay. At this pressure, 150 kilopascal. So because the initial pressure is 150 kilopascal, so at 150 kilopascal, if I will provide you some data related to Vf and Vg, then easily you will be calculate the specific volume of the water initially. Yes or no, guys? So let me provide you the data so that you will be able to calculate V1, and then V1 equal to V2, and then what is V3, guys? V3 is the 10% more than the V2. Okay, that will be 1.1 into V2. Okay guys, so let me provide you that data. मैं वो data आपको provide कर देता हूँ. So X already we calculated. I hope this is not required to you. तो मैं यहाँ data लिख देता हूँ so that you will be able to calculate. So let me write it here. So at this 150 kilopascal, guys, 150 kilopascal पे, let me write it here, temperature 150 kilopascal, sorry, pressure 150 kilopascal. So at pressure 150 kilopascal, Vf equal to 0.00105,273. This is Vf, and Vg equal to 1.1593. Okay. So at pressure 150 kilopascal, I am providing you Vf in meter cube per kg. Similarly, specific volume of the saturated vapor in meter cube per kg. Okay, so this process is something like this, guys. अगर मैं इस process को show करूं ना बच्चों, so this process is something like this. ये process कुछ ऐसे है, देखो. This process will be something like this. Suppose if I will draw this process on pressure versus volume diagram, PV diagram, so this curve will be something like this. कुछ ऐसे curve होगा. So initially the point is in what? The point is in the wet region, where the dryness fraction is what? इस पॉइंट पे ड्राइनेस फ्रैक्शन कितना है बच्चों? ड्राइनेस फ्रैक्शन इक्वल टू 0.75. ओके, सो इनिशियली यू आर एट दिस पॉइंट, आप इस पॉइंट पे, दिस इज स्टेट 1, this is state 1. Now you are heating, you are supplying heat, so that you are heating it at constant volume. So this 1 to 2 is the heating process at constant volume. 1 to 2 is the heating process at constant volume. Okay, so this is your pressure, this is your constant pressure line, this is your constant pressure line, which is 150 kilopascal. Okay, you are heating it so that it will finally reach to a pressure of 400 kilopascal. So this is your final pressure. Okay, so this final pressure is what? This is 400 kilopascal. Okay, this is 400 kilopascal. So 1 to 2 is constant volume heating process. Okay, now from 2 to 3 it will be constant pressure. So the point 3 will be somewhere here, because यहाँ से अगर आप constant pressure heating करोगे, so you will be somewhere here. So the process is something like this: 1 to 2 constant volume, 2 to 3 superheating. Are you getting the idea? And he is asking you the heat transfer. आपसे क्या पूछ रहा है? Okay, he is asking the final temperature. आपसे क्या पूछ रहा है? Final temperature. So he is asking you this T3. What is T3 final temperature? What is T3 final temperature? Yes or no, guys? So how many of you are able to calculate V1? V1 कितनों का आ गया बच्चों? V1 from this specific volume V1 you will be able to calculate, because dryness fraction is 0.75. If you will put it here, VFG is VG minus VF. Okay, put all these things, if you will put, you will get V1. V1 आपके पास आ जाएगा. And then if you will multiply V1 with mass is 4 kg, you will get V1. Okay, and V1 is equal to what? V1 is equal to V2. V1 किसके इक्वल है बच्चों? V1 equal to V2. Yes or no, guys? V1 equal to V2. Yes. Yes, guys. V1 equal to V2. V1 those are saying V1 is coming out, yes, V1 आपका आएगा V1 equal to V2 which is equal to 0.8697, ये आ जाएगा आपका, this will come out 0.8697, okay, this will come out 0.8697, but you need to multiply this with what, इसको मल्टीप्लाई कर देता हूं 0.8697 with 4, so this will come out 3.4788 meter cube, 3.478 meter cube. Yes, yes, very good Chakrabarti, Saikat Chakrabarti. Chaliye. And what is V2 guys? V2 equal to V1, but what is V3 guys? Can I write this V3, मैं यहां लिख देता हूं, can I write V3 equal to 1.1 V2 and V2 equal to V1? Yes or no guys? क्या मैं V3 को इसके इक्वल लिख सकता हूं? Yes or no? Yes, can I write V3 equal to 1.1 V2? Yes, I can write, because the final volume is 10% more than the initial volume. So up to 1 to 2 constant volume process, 2 to 3 constant pressure, so the final volume is 10% increases, 10% more than the initial volume, means V3 equal to 1.1 of the V2. ओके, तो V2 we know, यहां से अपने पास V2 है, इसको अगर मैं 1.1 से मल्टीप्लाई कर दूंगा, you will get the V2 V3, तो इसको मैं 1.1 से मल्टीप्लाई कर देता हूं, so this will come out 3.8266 in meter cube. Okay, this is in meter cube. Okay, but what we want guys, at this condition, because we want this point is in the superheated region, ये अपने को पता है कि this point is in the superheated region, yes or no? This point is in the superheated region, this we know. Okay, so at this point, if I want to write V3, so V3 is nothing but 3.8266 divided by mass, and what is mass guys? Mass is 4 kg. तो इसको मैं 4 से डिवाइड कर देता हूं, so that we will get V3, the specific volume in the superheated region, the specific volume in the superheated region. Okay, so dividing by this, you will get 0.95665. Okay, 0.95666. Okay, so now we are having two datas guys, दो datas हैं, and then with these two datas, if you refer to your steam table, easily you will get the answer. क्या डेटा है अपने पास? एक तो फाइनल स्पेसिफिक वॉल्यूम इन द सुपरहीटेड रीजन एट ए प्रेशर 400 kilopascal. So at 400 kilopascal, if you will refer to your steam table, you will find the saturation temperature close to 111.37 degrees Celsius. Okay, close to that. At this pressure, 349 degrees Celsius. Okay, if you will refer to your steam table, at this pressure, the saturation temperature is this idea you are going to get. Okay, second idea, at this pressure with a specific volume 0.95665, you are going to get a temperature. Okay, you are going to get a temperature which is what, which is, let me tell you, let me write it here. For the superheated steam table, I'm going to show you also, so that you will get the more clarity, more idea. So at a superheated pressure 0.4, so guys, this is the data. I hope this superheated steam table is visible. So at pressure 0.4 megapascal with the specific volume 0.93, close to that guys, you can refer. With specific volume 0.93, close to that, if you refer, the temperature is what guys? The temperature is this. Okay, because we are getting the specific volume in the range of this 95. Okay, so you are going to get the final temperature in the range of 540 to 560. 540 to 560. So then we can say our final temperature is in between 540 560, means the answer is option B. Okay, option B क्या हो जाएगा बच्चों? This is the right answer. So the final temperature means T3, T final is in the range of 540 to 560 degrees Celsius. Okay, but how we are getting guys? Because two datas are required. With only single data like pressure 400 kilopascal, you will not be able to calculate. No, Vishwanath, on saturated vapor line you are going to get T saturation. Okay, on saturated liquid line, like suppose at pressure 400 kilopascal, you will get T saturation. Okay, you will get T saturation which is equal to 111.349 degrees Celsius. But at this pressure, like let me, if I will tell you the specific volume, at this pressure, the specific volume, okay, at this pressure, the specific volume of the gas Vg equal to this 0.462. Okay, Vg is 0.462, and you can check it here, guys, very clearly. You can check the V3 here is 0.95665, and here Vg is 0.462. It means we are in the superheated region. Are you getting the idea, guys? Because the specific volume is more than the here Vg, because this is Vg and the volume is more than that, means we are moving in the superheated region. And as we are moving in the superheated region, so you need to refer to the superheated steam table. And in superheated steam table, at pressure 400 kilopascal, specific volume close to 0.95, you will be able to get the final temperature in the range of 540 560 degrees Celsius. Okay, so that's why I'm going with this option B as the right answer. Okay, please tell me, is this clear, guys? Please confirm. How we can say 2 is on the saturated liquid line? चलिए, अभी एक बच्चा बोल रहा है सर, how we can say कि 2 is on the saturated liquid line? देखो देखो, initially we are moving like this is our initial point. Okay, this is our final point. Okay, so heat is now transferred. आपका heat transfer कर रहा है, and the final pressure is what? The final pressure is 400 kilopascal. Final pressure क्या आपका? 400 kilopascal. At 400 kilopascal, the piston is going to move. Piston आपका क्या करेगा? Move करेगा. So let me check. Heat is now transferred to the water, as a result of which the water pressure increases. When the pressure inside 400 kilopascal, piston starts moving in quasi-equilibrium manner. This is manner, and the heat transfer continues till the process. Guys, even if you will show this point somewhere here, अगर आप इसको ऐसे भी show करोगे, something like this. Okay, something like this, then also the answer is going to come out same. Why? Because this is, suppose this is initial point, suppose here the dryness fraction is 0.75, you are raising the temperature, you are heating it at constant volume, so the process will be something like this. Okay, the volume is constant, finally reaching to a 400 kilopascal, the process will become constant pressure. So this is the final point. Okay, this is the final point. So at final point we want T saturation. So here at this pressure the T saturation is this, and at here 400 kilopascal, specific volume this, the final temperature is this. Okay, so then also there will be no deviation in the final volume, final temperature. So I hope you got the answer, you got the point. So guys, there is no such deviation. You cannot say yes, from this data it is not clearly mentioned that this point is in the super saturated vapor or not. So that is not going to affect the answer, guys. So even if you will take this, if you will just shift this line somewhere here, then also you will get the right answer. You got the point? So we are interested in the end points. This is the end point, and this is the initial point in the wet region where the dryness fraction is 0.75. Okay, चलिए, let us now move to next question, guys. Next question पे move करते हैं. So this we have solved. Okay, चलिए, ये तो हमने already we have discussed. ये हमने already discuss कर लिया है. This also we have discussed. चलिए. Now this is the similar question, guys, but there is slight difference, like the 9th question. Okay, 9th question की तरह ही similar data है, but there is slight difference. So there is a spherical balloon of diameter 0.5 meter. So there is a balloon with the diameter d1 equal to 0.5 meter. There is a gas at 1 bar 300 Kelvin. So the P1 is 1 bar, okay, and the T1 is 300 Kelvin. The gas is heated inside the balloon. You are heating the gas inside the balloon, and the balloon is allowed to expand. The final pressure is going to changes linearly with the diameter. So pressure is directly proportional to temperature. He is saying the pressure is linearly varying with the diameter, means pressure is directly proportional to the diameter. Yes, V2 equal to Vg. Vishwanath, very good. Final V2, like V2 is the like volume, Vg is equal to Vg, but what I mentioned, guys, V3 is the final state. Okay, because you are continuing the heating. Okay, आपने heating को continue किया था उसके बाद भी. So the final volume is in the superheated region, which is V3. So 3 states I mentioned. 1 to 2 constant volume, 2 to 3 is constant pressure. So 1 to 2 V2 equal to V1 and V1 equal to what? Vg. Okay, but वो Vg को कब बोलेंगे हम? Vg तब बोल सकते हैं if we know like that point lies in what? That point V2 point lies in the saturated vapor line, but that we don't know. That's why I calculated V1 को मैंने calculate किया. I have not compared V1 equal to what? I have not compared V1 equal to Vg at 400 kilopascal. Why? Because we are not sure कि V2 equal to Vg or not. You got the point? But V1 is equal to what, guys? V1 equal to Vf plus x VFG. VF at what, guys? Lower pressure. Okay, and VFG at also at that lower pressure, and x we know that is given to us 0.75. Using that data we calculated V1, and V1 equal to VG. That you can check, you can match what value of V1 you are getting. Okay, V1 का क्या वैल्यू आपको आ रहा है, that you can check. मैं भी आपको बता देता हूं V1 हमारा कितना आया था. So V1 we got close to 0.8697. Okay, जो कि VG से ज्यादा है. V1 is more than VG. That's why now we can surely say कि that point will surely lie somewhere here. वो point कुछ ऐसा lie करेगा. That will be somewhere here. How we can say, guys? Because this is P versus V line, something like this. So this is 0.1, and this V1 we calculated. V1 we calculated 0.8697. Okay, this is 0.8697. This we calculated. Okay. और यहां पे जो हमारा Vg है, इस पॉइंट पे जो Vg है, दिस इज Vg. ओके, दिस Vg is equal to 0.46238. okay, Vg is less than this. Okay, and this is 0.2, guys. This is 0.2. okay, this is 0.2 somewhere here, something like this. This is constant pressure line. This is 0.2. So as you can say, as you can check, V2 is more than Vg. That's why I'm shifting this line in what? Some part in the wet region, and the end point is in the superheated region at constant volume. You got the point, guys? Why actually I shifted this line? Because after observing that ki V1 equal to V2, and V2 as it is more than Vg, because at 400 kilopascal, if you check Vg, which is equal to 0.46238. okay, so V2 is more than Vg. That's why this point will be somewhere here, and the 0.3 will be somewhere here. But definitely 1 to 2 will be heat addition at constant volume, and 2 to 3 will be heat addition at constant pressure. The answer is going to remain same. You got the point? Chaliye. Okay, so now he is asking you the work in this case. इसमें थोड़ा सा करेक्ट कर लेना. दिस इज 10 की पावर 5. इन ऑल द केसेस दिस इज समथिंग लाइक दिस. 10 की पावर 5, 10 की पावर 5, 10 की पावर 5, 10 की पावर 5. So pressure is directly proportional to diameter, and P1 is given to us. Pressure is changing linearly, and the final pressure P2 equal to 4 bar. Okay, so the initial pressure P1 by P2 equal to D1 by D2. Okay, yes or no? So P1 is what? P1 is 1 bar, P2 is 4 bar. Okay, D1 is given to us, spherical balloon of diameter 0.5. So this is 0.5, this is D2. So D2 कितना हो जाएगा आपका? D2 will be this 1 by 4 into this 0.5. Okay, तो इसको देखना कितना बनेगा ये. Okay, so final pressure P1 by P2 equal to D1 by D2. So P1 initial pressure is 1 bar, the final pressure is 4 bar. Okay, so D2 equal to 4 into 0.5, so it is equal to 2 meter. So the initial diameter is 0.5, the final diameter is 2 meter. Okay, now he is asking you what is the work done in this case. What is the work done by the gas? Okay, so guys, in this case generally we need to assume one assumption, like there is no such work like which is required in stretching the balloon. Okay, so if you neglect that, there is no such work required in stretching the balloon. So the entire work which you are giving, that is what? That is expansion work. Okay, so that work, and reversibly if you will assume, so that work will be integration PdV. Okay, so as like we know there is some relationship between pressure and diameter, so easily you can replace diameter with volume, because volume for a balloon is nothing but pi by 6 d cube. Okay, so diameter d equal to 6 by pi v entire power 1 by 3. Okay, so diameter you can replace with this. Diameter equal to 6 by pi v whole power 1 by 3. Okay, so now if you write it here, the pressure which is equal to 6 by pi volume whole power 1 by 3 into dv. Okay, into dv. Yes or no, guys? Okay, so pressure we are replacing. Okay, diameter we are replacing, but before that we need to write the relationship between pressure and diameter also. So pressure equal to C by D, so you can write it here, P equal to CD. Okay, so P equal to what? P को मैं लिख सकता हूँ CD, so C into D, and then diameter we can replace with this. So I'm replacing the diameter with this 6 by pi into volume whole power 1 by 3 into dV. Okay, so this we want to solve, guys. If you want to find out the work in this case, you need to solve this entire thing. Okay, अब इसमें देखो कहां पे कंफ्यूजन आएगा. फर्स्ट थिंग इज like how to calculate change in volume. V2, V1 we know, V1 easily you will get because initial diameter we know, okay, and remaining things are constant. Very easily by calculating you will get V1. But how to get V2 guys? V2 guys kaise aayega? You know the diameter is changing by what? Diameter is changing by 4 times. Diameter kitna ho raha aapka? 0.5. From 0.5 it becoming 2 meter. Okay, so diameter is increasing by 4 times. So can I write here the V2 is equal to 64 times of V1? How I can write? Because here we know volume is directly proportional to diameter cube. Volume is directly proportional to diameter cube, and as we know the diameter is increasing by 4 times, so the volume will increase by 64 times. Volume कितना हो जाएगा आपका? 64 times. Okay, so if you will put all these things guys here, अगर आप ये सारा कुछ सोल्व करोगे then easily you will get this work. एक और चीज मैं लिख देता हूं, how to get this constant C. ये C कैसे आएगा बच्चों? How to get this C constant? So C equal to P1 by D1, you need to use the SI unit. The pressure is 1 bar, so 1 into 10 to the power 5 divided by diameter is 0.5. Okay, so the constant C equal to 2 into 10 to the power 5. Okay, this is constant guys. Pressure is directly proportional to diameter, so that constant C equal to P1 by D1 or P2 by D2. Okay, we know the P1 which is equal to 1 bar, so 1 into 10 to the power 5. D1 is 0.5. Solving this you will get C. So C we know. Integrating this you will get some kind of formula. मैं यहां लिख देता हूं, चलिए. So C, you can write C constant outside into 6 by pi whole power 1 by 3. This is also constant. Integration V ki power 1 by 3. So if you will integrate, you will get V ki power 1 by 3 plus 1. Okay, so 1 by 3 plus 1, it will be what? It will be 4 by 3. So it will be V power 4 by 3 divided by 4 by 3. Okay, limit 1 to 2. Okay, limit 1 to 2. Yes or no guys? This is the work you are going to get. This we know, C we know, this is also a constant. Volume also you will easily get by putting the limits V2 minus V1. Okay, something like this. Chaliye, so C into 6 by pi whole power 1 by 3. If you will put the upper limit first, so it will be V2 power 4 by 3 minus V1 power 4 by 3. Okay, this 4 by 3 you can write it here, and then it will be 3 by 4. Okay, so this 4 by 3 I'm taking it outside, so it will become 3 by 4, something like this. Okay, and as you know V2 equal to 64 times V1. Okay, V2 equal to 64 times V1, so then you can easily replace this data here. आप उसको easily replace कर सकते हो. Okay, so that also easily you will be able to replace. Volume work equal to क्या था हमारा? Integration PdV. Okay, तो यहां से एक चीज ध्यान रखना बस, V की power 4 by 3 means V2 की power 4 by 3 minus V1 की power 4 by 3. This you can write it as what? 63 V1 की power 4 by 3. Why? Because V2 equal to 64 V1. Final volume is 64 times of the V1. So that's why V2 की power 4 by 3 minus V1 की power 4 by 3. This term will become 63 V1 की power 4 by 3. Okay. So and all those things, remaining things, if you will put, you will get the work, guys. Work आपके पास आ जाएगा. Now can you tell me what answer you are getting? Because V1 we know, and remaining all things are constant. C is what? C is equal to 2 into 10 to the power 5. C we know, remaining all things are constant. Volume also we know. So please tell me what answer you are getting. Yes, very good guys. Those are getting A. Your answer is very right. बिल्कुल सही. जिनका आंसर ऑप्शन A आ रहा है बच्चों, very good. Others also please check. You need to check your answer. Why you are not getting option A? Option A is the right answer for this question. बिल्कुल सही. चलिए, तो मेरे ख्याल से एक और क्वेश्चन रह गया. लेट मी डिस्कस दैट ऑल्सो. देन रिमेनिंग क्वेश्चन विजेंद्र सर इज गोइंग टू डिस्कस विद यू. चलिए, लेट मी डिस्कस दैट क्वेश्चन ऑल्सो गाइस. And we are having that question. Let me put it here in front of you. Yes, so this is the question. So let me read it for you guys. So there is a cylinder having piston restrained by a linear spring. So this is actually a kind of linear spring which is having stiffness kilonewton per meter. So this spring stiffness is 15 kilonewton per meter. Okay, the load required for producing unit deflection in a spring that is known as what? Spring stiffness. Okay, 15 kilonewton per meter. There is a mass of 0.5 kg saturated water vapor. So saturated vapor water means here the water vapor which you are having, it is in the saturated vapor condition. किस condition में है? Saturated vapor condition at a temperature 120 degree Celsius. Okay, at a temperature 120 degree Celsius. Condition क्या है? Saturated vapor. You are having saturated vapor. Okay, guys, again if you refer to your steam table, you will find the data at 120 degree Celsius. At 120 degree Celsius, the saturation pressure is 198.67 kilopascal. P saturation is 198.67 kilopascal. Okay, this is saturation pressure at this temperature. Okay, at this temperature 120 degree Celsius, this is saturation pressure. Now heat is transferred to the water, causing the piston to rise. You are supplying the heat to this water, which is causing the piston to rise. The cross-sectional area is what? The cross-sectional area is 0.05 meter square. The pressure is linearly going to vary with volume. Pressure क्या करेगा बच्चों? Pressure is linearly going to vary with volume. Here, the pressure is also increasing, the volume is also increases. Why? Because you are supplying heat, but this expansion is restricted by this, spring. So the pressure is also going to increase. So pressure, volume, they are linearly increasing. Okay, until a final pressure of 500 kilopascal. So the final pressure is 500 kilopascal. 500 kilopascal. Now he is asking the heat transfer. Can you solve this question, guys? क्या आप इसको solve कर सकते हो? Okay, let me give you the hint, guys, how to solve this problem first. चलिए देखो, as there is no such mass of the piston given, mass of the piston अपने को कुछ दिया नहीं है यहाँ पे, but you can consider that. Okay, atmospheric pressure भी कुछ नहीं दिया, but atmospheric pressure भी होगा close to 100 kilopascal. This will also be there. Okay, this will also be there, 100 kilopascal atmospheric pressure. Okay, so as this is not given, so we can neglect. We can consider this arrangement as massless. The piston, we are considering it as massless. Okay, but suppose if some kind of mass of the piston is also given, then you need to consider that also. Okay, so in equilibrium condition, in equilibrium at state 1, the internal force equal to external force. Yes or no? What is internal force? That is the internal pressure into the area, it equal to the external force. What is external force? It is atmospheric pressure into the piston area plus mass of the piston into G, MP, mass of the piston into G, plus what? The spring force, K into X. The spring force, K into X. Okay, the spring force, K into X. So as we know, guys, the initial pressure is what, guys? The initial pressure is 100 kilopascal. It is given. The initial pressure is this 198.67. This is the pressure inside, because you are having saturated vapor. Inside this, you are having saturated vapor, and at that saturated vapor condition, 120 degrees Celsius, the saturation pressure is 198.67 kilopascal. Okay, so now, like, what data which is not given in this question, the piston, when this is at this particular state, what is the spring force? The spring is at rest, or there is some kind of spring force. Agar spring force hoga, then this will also be there, X will also be there, and this term we can neglect. इस term को हम क्या कर सकते हैं? Neglect कर सकते हैं. Okay, इसको हम क्या कर सकते हैं? Neglect कर सकते हैं. So this is equation number 1. This is P1. P1 is what? P1 is this 198.67 kilopascal. What is the area? Area is your piston area, which is this 0.05 meter square. P atmospheric is 100 kilopascal, and again area is piston area. K is the spring stiffness, 15 kilonewton per meter. X is the initial deflection of the spring. Okay, this is equation number 1. Finally, like final state, at final state, again the system is in equilibrium, so you can write it as, again, this relationship F internal equal to F external. So you can write it as P2 means the final pressure into the piston area, P2 into A, which is equal to, again, P atmospheric into A plus K into, मैं यहाँ पे X लिख देता हूँ, X1, and then I can write it here X2 minus X1. Yes or no? X2 minus X1. Okay, X2 minus X1. So from here, guys, you will be able to calculate initial deflection of the spring if you are neglecting this mass of the piston, because he has not given you any data related to mass of the piston. So we can neglect the mass of the piston. So you will be easily able to calculate the initial deflection of the spring using this equation. Area is given to us. Final pressure is what? The final pressure is 500 kilopascal. Okay, the final pressure is 500 kilopascal. Okay, this also we know. And using this final pressure, P atmospheric, stiffness is going to remain constant. You will be easily able to calculate this x2 minus x1 means final deflection. X1 is the initial deflection that you will get from this equation number 1, and from equation number 2 you will get x2. From x2 minus x1, what is you are going to get? You are going to get the displacement of the this piston. How much is the piston displaced? Piston आपका कितना displace किया? You got the point, guys? With what distance your piston is displaced. Now, if you are able to calculate that displacement of the piston using that, yes, that also you can refer. Vishwanath, that approach is also fine. There is no such difficulty in that. Why? Because he has not mentioned anything about that. Vishwanath, he has not mentioned anything about the spring is restrained or not. He has not mentioned anything about the mass of the piston. So that also you can apply. Considering this as 0, isko आप initially 0 मान लो, then you can calculate mass of the piston here, and that mass of the piston you can put in this equation. That approach is also fine. उससे भी आपका आंसर close आ जाएगा. Because no such data is given here. देखो, you can again read a cylinder having piston restrained by linear spring. This saturated vapor shown in figure, heat transfer causing the piston rise. The piston cross section area is this linear spring. So he has not mentioned ki here there is some spring force is acting or not. What is the mass of the piston? So that approach is also fine. Okay, Vishwanath. So considering this 0 initially, spring force 0, you can calculate mass of the piston. Then here you need to write kx only, the displacement of the spring, and mass of the piston you need to consider. You will get the displacement of the spring. Okay, तो वैसे भी आप कर सकते हो. There is no such problem with that. Okay, guys. So now he is asking you the heat transfer in this case. आपसे क्या पूछ रहा है? He is asking you the heat transfer in this case. Okay. So at this condition, guys, at this condition, 198.67 kilopascal, the saturated volume, because you are having saturated vapor. So Vg also you can get from the steam table, which is given to us. Vg equal to 0.89121 meter cube per kg. Okay. So this is Vg. At this temperature, 120 degrees Celsius, at saturation pressure 198.67 kilopascal, Vg is this. Okay. Mass is also given. Mass अपने को पता है 0.5 kg. Mass is 0.5 kg. So easily you will be able to calculate volume, initial volume V1. Initial volume you will be easily able to calculate. ठीक है. तो अगर आप मान के चलते हो कि when the piston is at the bottom, then the spring force will be 0, then you will get x1 from here, and x1 if you will multiply by this piston area, you will get the initial volume. Okay, otherwise directly initial volume you are going to get from this Vg, because here this is the initial state V1, and this Vg you are having, this you will multiply by the mass, you will get the initial volume V1. Okay, so you can check your answer, like, because from here if you will consider the spring force is there, so spring force will be 0 at the bottom, then you can neglect the mass of the piston, you can calculate x1 and then multiply that x1 with what? The area of the piston, you can calculate V1. Then you can match if V1 is coming out same or not. If it is not coming out, means this x1 is 0 somewhere here, the spring force is not there. Okay, so something like that you need to follow, that approach you need to follow, because he has not mentioned all those things here. But here this time I'm not considering initially the mass of the piston, so I'm neglecting the mass of the piston, but spring force I'm considering initially. So x1 also, solving this you will get V1. Okay, so specific volume Vg, because you are having the saturated liquid, saturated vapor. For saturated vapor Vg we know from the steam table, that you will multiply by 0.5, you will get the V1. Okay, V1 ko change in volume also you will get from where, guys? Because x2 minus x1 is going to give you the change in the length, change in displacement of the piston. X2 minus x1 is the displacement of the piston, and that displacement if you multiply by what? That displacement if you multiply by the piston area, you will get the change in volume of the piston, or that change in volume is required if you want to calculate the heat transfer, guys. Because heat transfer using first law of thermodynamics, dq equal to du plus dw. Okay, dq equal to du plus dw. ठीक है बच्चों? तो यहां से आपको इसको सोल्व करने के लिए यू नीड टू सोल्व दिस आल्सो फर्स्ट. पहले आपको इसको सोल्व करना पड़ेगा. And if you calculate volume final, change in volume, let me write it here. The change in volume which you are going to get, change in volume is equal to 0.066 meter cube. You can also check your answer, guys. What is the change in volume you are getting? Okay, so change in volume will come out 0.6066 meter cube. Okay, and the displacement which I got, that is coming out 1.33 meter. X equal to 1.33 meter. What is X, guys? This is actually X2 minus X1. X2 minus X1, which is equal to X, is equal to 1.33 meter. So solving these two equations, guys, you can check the change in volume and the displacement of the spring. Okay, and then using all those things, guys, you will easily get the heat transfer using this equation, dq equal to du plus dw. Now can you tell me in what range you are getting the answer, guys? किस रेंज में आपके पास आंसर आ रहा है? Okay, because he has given you some ranges. उसने आपको कुछ ranges दिया and he is asking you the answer in those ranges. 464 is not right. 464 is not right. If you're getting the answer in this range 570 to 60 600, then this is right. Option B, they mentioned option B as the right answer, guys. Option B को उन्होंने right answer mention किया है. Okay, so guys, I provided you the hint how to find out the displacement. How then after that displacement, the change in volume, you will be easily able to calculate the work. Okay, internal energy changes because at this condition you are having the saturated liquid condition. यहाँ पे आपके पास क्या है? Saturated vapor condition है. So at this condition, you can easily write U1, Ug. Okay, so Ug equal to U1. Okay, from steam table again, if you will write it here, Ug equal to U1 because initially you are having the saturated vapor. Okay, Ug equal to U1. Let me provide that data also to you, and then you can again check and you can tell me what idea you are getting, what answer you are getting. So at the pressure, this initial pressure, let me write it here, 120. Yes, so at 120 degrees Celsius, the Ug is equal to 2528.8 kilojoule per kg. Okay, this is Ug. Okay, so please try this problem. Chaliye, so guys, most of the problem, like initially Vijayender sir discussed, and again he is joining, and entire all 100 problems we are going to discuss. If you are facing problem in any question, then again you can shoot your query. So we will try to discuss that problem also. So please, sir, you can come and we are going to complete those 100 questions. So please answer this question also. Chaliye. So thank you very much, guys. Again, we will meet and we will solve some more questions. Thank you.
Okay, so looks like quite a long session for all of you, very long session, but I believe this is going to work because when we sit comfortably and we start solving questions, then I think it may make sense. So it's almost 5 hours, and I think in next 1 hour, 1.5 hour maximum, I'll be completing all the questions. So our 100 questions will be done. So let me first thank you for being there and watching all the questions. So I think I left this question at 50. So we did questions up to 50, and after that Vishal sir took and some questions and then started solving for you. Now let me go back and I start with I suppose this question 51. I don't think this was done. So I start with this question number 51. Read this question again. This is another good question given to us. Let me read this question for you. So there is insulated piston cylinder device which contains 5 liter of saturated liquid water at constant pressure of 150 kilopascal. Electric resistance heater inside the cylinder is now turned on and 2200 kilojoule of energy is transferred to the steam. And we have to find out the entropy change and water of the water during the process. So let me give you the diagram, what probable diagram can be there. So there is a piston cylinder mechanism, and it is having some kind of heating arrangement also. Something like this is given, and there is a 5 liter of saturated liquid water. Saturated liquid water. So if I draw the TS diagram here for you, This is the kind of diagram we are going to get, and we are at state 1. This is the state 1 and 150 kilopascal, and I'm sure you people are also making notes along with me. So this is the piston cylinder mechanism, 5 liter, and 2200 kilojoule of energy is transferred to the steam. Now we are to find out how much is the entropy change. So we know this state also corresponding to this, and we are at some state 2. We need to find out what is that state. So let us see how we get it. And 2200 kilojoule of energy is supplied by this particular heating element. Now what we know is, like this enthalpy H1, enthalpy which is also saturated liquid state, that is 467.13 kilojoule per kg. So that he will supply you. So that is the state 1. And now because we know this 2200 kilojoule is m into H2 minus H1. Let us say this is the final state. So the enthalpy of the steam has gone from 1 to 2. So this entire heat which is supplied to you, this has taken the state, whatever energy you supplied, 2200 kilojoule. I cannot say this is the this is not heat energy, this is work, actually electric work. So this electric work has increased the enthalpy, so H1 to H2. Now how much is this enthalpy? Let's calculate it. That is 5 kg now. So if I put all the values, I get H2 as equal to 907.13 kilojoule per kg. So I got the final specific enthalpy, that is 907.13. But we also know one thing, that H2 is equal to H1 plus X into Hg minus H1. What is Hg? That also I can calculate from the table, corresponding to 150 kilopascal, and that is equal to 58 kilojoule per kg. So if I put all the values, H1 is known to me, Hg is known to me, H2 is known to me. So X is going to come, X value will be equal to 0.1976. So dryness fraction is this much. Why do I want to know dryness fraction? I want to know dryness fraction because I want to find out entropy at point 2, which is nothing but this is the entropy. So S1 I know, Sg I know, and I want to calculate S2. X is also known to me. So what is that entropy coming? This is coming 2.578 kilojoule per kg Kelvin. That is the entropy, and he is asking you to calculate total entropy change in kilojoule per Kelvin. So S2 minus S1 is m into, now this is S2 2.578 minus S1. So S1 was corresponding to this point. So S1 I can calculate from the steam table as 1.433, 1.4337, and that value is coming out to be 5.72 kilojoule per Kelvin. So 5.72 kilojoule per Kelvin. That was the question. So it was a good question again. So this is okay. So let me tell you now what this question was. And this question is typically like GATE exam जैसा आपको आ सकता है, जैसा expect हम कर सकते हैं question, exactly it is like that. So what we were given was, there is a device which is containing 5 liter of saturated liquid water. When it is saying saturated liquid water, that means state 1 is given to us. अब उसने 2200 kilojoule of electric work supply किया, which increased the enthalpy to state 2. So if I know what is state 2, I can calculate what is the dryness fraction at 2. If I know dryness fraction at 2, I can calculate entropy also at 2, and he has asked you to calculate the entropy change from 1 to 2. Very pretty simple question. So I'm sure you have written it in your copy. Right? No, how to get mass is already given. Water ka 5 liter. Are you people aware that 5 liter mass is 5 kg mass also? For water, 5 liter is 5 kg also. So remember this always. 5 liter is 5 kg also. Right, Kona, have you understood this? Okay, so let's go to next question now. It's a simple question now. As I told you, now maximum time consuming questions are gone. Now very less time will be taken for these questions. Read this question now. In a refrigerator, heat is transferred from lower temperature medium refrigerated space to high temperature one, that is kitchen air. Which of the following options is correct? So he is giving you this. He is giving you this refrigerator. He is saying that in the refrigerator you are supplying something like this. Heat is transferred from lower temperature medium T2 to T1, Q2, Q1, and then W. This is typical refrigerator, right? And this is the refrigerated space. This is the conditioned space. Conditioned space. He's asking you which of the following option is correct. So what do you think is the answer? So what is the answer for this? Yeah, so in these questions data was not given because these are NPTEL assignments, as you understand. So we are providing you data along with question. Keep noting that, and in the GATE exam he will provide you data. So at least we know the concept. Answer lagao jaldi se. Tell me what is the answer for this. Fast. Tell me first. Okay, how do you think this is perpetual motion machine of second type? How do you know this is perpetual motion machine of second type? Perpetual motion machine of second type is this. Q1 into W. This is PMM2. Perpetual motion machine of second type violates the Kelvin-Planck law. So this is not perpetual motion machine. If I remove W, then this will violate the Clausius statement. If I remove W, then Clausius statement is violated. Perpetual motion machine of second type violate the Kelvin-Planck statement. You know that. Kelvin-Planck says that you need to have minimum 2 reservoirs. So there should be reservoir. You need to have minimum 2 reservoirs. That is what Kelvin-Planck statement is. So this does not violate that. Answer for this question is none of these. It does not violate anything. So likho copy ke andar, none of these. Answer to this question is none of these. So every question, as I told you, has a meaning, has a concept in this. Yes, and that brings us to this particular concept also. Let's go for next question now. Read this question now. Read this question carefully and try to answer this. Somebody claims, okay, you say work is not mentioned. In a refrigerator, heat is transferred from low temperature medium to a higher temperature one. Which of the, so he's not saying, he's saying refrigerator. Refrigerator mein to work hota hi hai. So there is a, if it is a refrigerator, understood, there is a work inside it. So you need not to say that he is mentioning you about that. Work is the part of refrigerator, right? So okay, somebody claims to have developed a new reversible heat engine that operates between temperature limits same as Carnot cycle. Which of the following is correct? Just guess what answer is this. Yeah, so it is a Carnot theorem. This is the Carnot theorem. There is something which is called Carnot theorem. So if I give you two heat engines working between same temperature limits, so device 2 is Carnot cycle, device 1 is reversible. This is reversible, this is Carnot, right? And they are working between same temperature limits. So if there are n number of heat engines working between same temperature limits and are reversible, every engine is going to have same efficiency. Listen this carefully. Because what is Carnot efficiency? It is 1 minus T2 by T1. And what is the efficiency of this? 1 minus T2 by T1, because it is also reversible. So even if there are n engines, then the efficiency of all the engines is going to be same. That is the Carnot theorem. Carnot theorem says that if there are reversible engines working between two temperature limits, their efficiency will be equal. That is the Carnot theorem. So answer for this is C. So you have hit the right answer. Answer for this is C. Next question. Read this question now carefully. A food department is uh, kept at minus 12 degrees centigrade by a refrigerator in an environment at 30 degrees centigrade. So actually there is a keeping some particular space at minus 12 degrees centigrade and ambient temperature is 30 degrees centigrade. The total heat gain to the department is 3300 kilojoule per hour and rejection in the condenser is this. Determine the power input to the compressor and COP of the refrigerator. So you people have already solved many questions of this type now. So what is the question given to us now? आपने बहुत से questions किए. You need to know what kind of data he will provide you. So this is a refrigerator and he says that there's a temperature which is minus 12 degrees centigrade, 30 degree centigrade, and this is the conditioned space. This one is conditioned space which I want to maintain, but because outside temperature is 30 degrees centigrade, heat flows here and at the same time I reject that heat to the ambience. So Q2 is the heat I am rejecting to the ambience. Now what is the refrigeration effect? Refrigeration effect, which is nothing but Q2, is equal to 3300, heat rejection is 3300 divided by 3600, that comes out to be 0.9166 kilojoule per second. Heat rejection in condenser, that is Q1, is 4800 over 3600 kilowatt, that is 1.33 kilowatt. So we have understood what is refrigeration effect, and now we have got this also. We want to find out W, work. So work is nothing but Q1 minus Q2, and what is COP? COP is Q2 by W. So we can calculate this, and COP is coming out to be 2.199. 199 is COP, and the work is, if you calculate, it is coming out to be 0.4167 kilowatt. So answer for this is B. Again, another good question and a simple question it was. It was a pretty simple question. If we invest 6-7 hours and if we are in position to revise a particular subject thoroughly with questions, good questions rather, then it makes some sense to attend those questions. I go to next question now, 55 question. Let's go to this question now, question number 55. Household refrigerator has power input of 500 watt and COP of 2.5 and is to cool 5 large watermelon 10 kg each to 10 degrees centigrade. If the watermelons are initially at 25 degrees centigrade, determine how long will it take for refrigerator to cool those watermelons. The watermelons can be treated as water whose specific heat is also given. Very simple question. It is a very simple question. Again, if I give you some kind of diagram here, it is a case of refrigeration effect. So this is the conditioned space. Let us say I have kept some watermelon here. Q2 is refrigeration effect. This is the refrigerator. This is the heat rejector, and this is the refrigeration work which I need to do. Let's say T1, let's say T2. Typically, a household refrigerator, power input is 500 watt. So that is the 500 watt. COP is given as 2.5. So 2.5, and you know what is COP? It is nothing but Q2 by W. So if COP is given to us, so refrigeration effect, which is Q2, that can be obtained as 2.5 into 500, that is coming out to be 1250 watt. So how much is the refrigeration effect? 500 watt is the work done, 2.5 is COP, so we get 1250 watt as refrigeration effect. How much is the heat extracted now? The heat which is extracted from the watermelon is, there are 5 watermelon of 10 kg each, Cp into delta T. So there are 5 watermelon of 10 kg each. So 50 kg into Cp into delta T. Right, so delta T is 25. Initially they were 25 degrees centigrade, now they are 10 degrees centigrade. So this is a 10 and this is 4.2. That is the heat extracted. How much is the heat extracted? This is 3150 kilojoule. This is the heat which is to be extracted from the watermelon. So 3150 kilojoule heat is to be extracted from watermelon. Right, and what is given to us is refrigeration effect is this much watt. You know, watt is joule per second, so kilojoule ko I need to change joule or something like that I am to do. So 3150 is equal to, this is 1.25 kilowatt into T. So how much is the T coming in second? So you will get T is coming out to be 2520 second, or that is going to come as 42 minutes. So in the second it is 2520 second, and then in the minutes it is coming to be 42 minutes. So I told you now not many questions are left. So we will complete 100 questions. So already 5 hours, but I think 6.5 hours may we will be completing sufficiently all 100 questions. You have 100 questions tonight, just revise them. They are the NPTEL assignments and really important questions for exam. And if you don't get anything, you can discuss with your mentors also. Which of the following property is not an intensive property? Everybody can answer this. You know, गेट क्वेश्चन में, गेट एग्जाम में सिंपल क्वेश्चन भी आते हैं, मॉडरेट डिग्री ऑफ डिफिकल्टी के क्वेश्चन भी आते हैं, and difficult questions also come. So which property is not intensive? Independent of mass. So momentum is mass into velocity. It is extensive property. It is extensive property. Velocity is intensive property. Velocity is intensive property. Kinetic energy is extensive property because it has mass into this. So velocity is intensive property, momentum is extensive property, kinetic energy is again extensive property. Kinetic energy is extensive property. So these are the things you need to understand. Energy is extensive property. Okay, let's go for this question now. Again, simple question. Everybody can answer this. Very simple question. Which of the following best describes the control mass, control volume, isolated system? Answer for that is what? What is the answer for this question? Yes. Piston is nothing but control mass. Turbine is control volume, control mass. You calculate PdV work for this. Control volume, you calculate minus VdP work for this. And isolated system. You should know that control mass is also called systems approach. This is also called systems approach. This is called systems approach. You know, YourPedia is taking a lot of classes on NPTEL, and in NPTEL there are approximately 2,000 to 3,000 really good questions. from where exam may GATE questions, in the GATE exam questions are asked. You need to revise that, so prepare it well. Next is, go for this question and tell me, point function and path function. Which combination tells you point function and path function? Yes, tick it up. Point function is pressure, path function is heat. So answer for this is B, pressure, heat. कॉपी के ऊपर टिक करते जाओ. So this is the point function and heat is path function. Barometer. Do you know what is barometer? Barometer is used to measure the atmospheric pressure. Of a mountain hiker reads 800 millibar. This is not megabar. Small m means milli bar at beginning of hiking trip and this at the end of hiking trip. Let's say this is the hiking. You are going at the top. So this guy is standing here and then this guy goes here. Here he finds 800 into 10 to the minus 3 bar. And then, you know, this is 640 into 10 to the minus 3 bar. This is what he founds. This is question you have to ask. This is what you have to calculate. Average air density. So he says average air density remains same. Say air की density remains same, though air density changes. तो कैसे निकालेंगे? Delta P is equal to rho into G into H. I think that is the formula. H जो आपने क्लाइम किया, तो 800 minus 640 into 10 to the minus 3 is what is the air density? 1.2 into 9.81 into H. Solve करो, आ जाएगा H. I think 135 answer is A, 1359 meter. There is a question. Yes, so that is the answer. So Mayur has hit the right answer. Done? Okay, go for this question. Mountaineer now could manage to climb at height of 4000 meter above sea level of Everest mountain. Determine the pressure felt by him at this height assuming same average air density. अभी कैसे निकालेंगे इसको? How shall you calculate it? What is the pressure? Again use the same formula. वही तो है formula. अभी वो यहां खड़ा हो गया 4000 मीटर with comparison to what? Let us say sea level. Let us say this is the sea level. Understand? Sea level. And pressure at sea level is 1 bar atmospheric pressure. P2 I want to calculate and this H is given. So P1 minus P2 is equal to rho GH. So you know what is given is now this is we are given now pressure. We have to find out the pressure at this P2 we have to find, and rho is to be taken as now same average air density, that is in the previous question I think that is what he is mentioning, 9.81 into 4000. Same means what? Previous question 1.2. I think this was linked question or something, so you were to use this. So what is P2 coming? P2 is coming 0.529. So B is the answer for this. 0.529 bar. No, not 0.47. Are you getting 0.47? Is it 0.47? Just check it out whether you are getting 0.47. Is it coming 0.47 or 0.52? Just check it out, each one of you. This one is 1 bar. So how much is this coming? Let's say 12. This is even if I assume it to be 10, this is coming out to be 4.8, that is 0.48 bar, and this is 1 bar minus P2. So P2 will come out to 0.52. I think this is correct. So you are calculating this one. This one is not the answer. He's not asked you this and you have made the mistake. Yes. Now you have made the mistake. You people have calculated this one. And in the question, he's asking you the pressure. He's asking you to calculate the pressure. Determine the pressure felt by him, felt by this fellow, not a decrease in the pressure. He asked you to calculate the pressure. Yes. That is what he asked you to calculate. What is the question? Next question. Which of the following property is the manifestation of internal kinetic energy? What do you think is the answer for this? Manifestation of internal kinetic energy is the temperature, is the basically temperature. Heat is not related to internal, kinetic energy of the molecules. That is related to difference of temperature. So always remember one thing, that pressure is related to intermolecular collision. Intermolecular collision, that is related to pressure. Temperature, this is related to internal energy. Temperature is related to internal energy, kinetic energy, or root mean square velocity. So the molecules which have energy, that is related to temperature. If you talk about heat, this is related to difference of temperature, heat flow, difference of temperature. So it should be very clear what you are talking about. Pressure, you are talking about intermolecular collision. Temperature, you are talking about internal energy, kinetic energy, root mean square velocity. Heat flow, you are talking about the difference in temperature, which will lead to that heat flow. That is how you understand it. Right? So answer for this is temperature. Try to answer this question now. Which of the following type of work is not a non-mechanical form of work? Is not a non-mechanical form of work. Which one of the following is, which of these is not a non-mechanical form of work? Okay, so answer is not a non-mechanical form of work means which of the following is a mechanical work. So question is, which of the following is a mechanical work? Which of the following is mechanical work? Shaft work. Shaft work is nothing but 2 pi nt by 60. That is a shaft power. This is how you calculate the shaft power. So it's a mechanical power. It's a mechanical work actually. This shaft work is a mechanical work. Right? So let's go for next question. And I want you to solve this next question. Another good question of NPTEL assignments. Solve this question. Consider fan located in a square duct 2 meter by 2 meter. Fan motor consumes 400 watt of electric power. Determine the minimum air velocity near fan. Consider the air density to be 1.2 kilogram per meter cube. So now tell how shall you calculate this? Okay, I want you to solve this question. Again, this is a typical gate type question. ऐसा गेट में टिपिकल गेट टाइप क्वेश्चन है ये. इसी टाइप के क्वेश्चन आते हैं गेट के अंदर. दिस इज टिपिकल क्वेश्चन विच यू कैन कम अक्रॉस गेट एग्जाम. बताओ क्या आएगा इसका आंसर? व्हाट डू यू थिंक इज द आंसर फॉर दिस? टेल व्हाट इज द आंसर फॉर दिस क्वेश्चन. Okay, yes. So motor power which is given is equal to kinetic energy of this increase in kinetic energy of air. Increase in kinetic energy. So you need to basically equate the dimensions. So 400 watt of electric power. So that 400 watt of electric power, that is basically going to increase the फैन में होता क्या है, इन द फैन what is happening is air is flowing through fan. Now fan is giving you some power, as I told you 2 pi nt by 60 or something. Now air को kinetic energy जो मिलता है, that is from this power. So air starts moving because of this power. So this is equal to half of mv square. But can you tell me what is the unit of half of mv square? Maybe kilojoule or let us say joule. But here it is watt. So watt and joule में मेरे को कैसे relation बनाना है? I am to put mass flow rate. So I am to here use mass flow rate. So increase in kinetic energy of air per unit time, increase in kinetic energy of air per unit time per second is equal to motor power 400 watt. But what is mass flow rate? Density into discharge. What is discharge? Area of duct into velocity. So this 400 is coming out to be half of density into area into velocity cube. Are we given density? Yes, 1.2 is given. Are given area? Yes, 2 into 2. So area is 4 meter square. Density is 1.2 kilogram per meter cube. And then we have to find out velocity. So velocity will come out to be 5 meter per second. So velocity will be 5 meter per second. So I'm sure you people are clear about this now, how this is to be done. Next question. A chef is cooking mutton in a pan that is uncovered, B covered with light lid, C covered with heavy lid. किस केस में कुकिंग टाइम मिनिमम होगा? In which case cooking time will be minimum? Yes, what is your answer to this question? In which case you are going to get minimum cooking time? In which case you are going to get minimum time? Okay, let me tell you now. Heat addition, what we understand is covered with C में minimum cooking time लगेगा, and I tell you the reason for that. If I give you TS diagram and if I give you two processes, constant volume heat addition, constant pressure heat addition, constant volume heat addition, constant pressure heat addition. So in the constant volume heat addition, this is constant volume heat addition and this is constant pressure heat addition. Pressure cooker or open container is a constant pressure heat addition. So if you see carefully, then in the constant pressure heat addition, the rise in temperature is less for same heat which you supply. So what is this giving you? This is basically the heat addition process which you can talk about. So constant pressure volume process always give you higher temperature. That is the meaning of it. So this particular process, constant pressure process, gives you more temperature, and that is the reason you can save the time of cooking. Right? You can also otherwise think dq is equal to mcv delta t is equal to mcp delta t. Any idea which one is more? Cp is more than cv. So you understand now, for the same delta t, less heat is to be supplied. For the same delta t, for the same rise in temperature, because cv is less, dq supplied is less. Or I can say this way, that if I want to, because cooking is related to rise in temperature, if this is mutton cooking, it is related to temperature. That is the reason we cook it in the pressure cooker, because boiling temperature increase. So with minimum supply of heat, if I get more temperature, and that way cooking will be faster, because if you supply now same heat, if I supply same heat here and here, in which case do you think temperature will be more? If I supply same heat, because cv is less, delta t will be more. If temperature is more, cooking will be fast. That is how you have to understand this. Next question. This everybody knows. So this is nothing but dryness fraction or quality is mass of vapor over total mass. Is mass of vapor over total mass. So that is the quality of the stream, mass of vapor over total mass. That is the answer. So everybody has put this as answer. Now there will be so many classes of 100 question. We are seeing the response, and the response looks like good on YourPedia. You see, this was the first class, let me tell you. And we as mentors, we tried it. We tried that we will give a good question to students. पहले ही भेज देंगे और वो देख के आएंगे. They will see the questions, they will revise the questions, and they will attend the class. So our this class has gone really good. I'm really thankful to all of you, and we are happy with the class. And now we will pull more such classes. So schedule आपको सारा मिला है. All the mentors are motivated now, and if you attend the classes, if you get benefited, obviously then only you will attend it. And if you find this method good, then we will go for some more classes. I told you last time also that if you find something good happening, you should appreciate that. And if you appreciate that, then the people will do that further. So if some teacher is coming, he's preparing these notes for you, sending you these notes with the hope that you will come for the classes, and if it is beneficial to you, then you follow it, right? And the mentors will come, and there is no dearth. There can be other subjects also. Teachers are ready to do that, but they want to get response. Only thing what demoralizes them is, like, we are teaching and 5-6 students are sitting, so it looks like wastage of their time, right? So if that 100 students are sitting and attending and all these things, the way we experience today, then it is going to work. So we are going to start it. Let's go for this question now. Vishwanath, SOM and FM we have already completed. हाँ, तो निटी बॉम्बे का फॉर्म्स निकल गया है. Forms for NITIE Bombay are out, and I think 17-18 is the last date, Feb 18th Feb or something. I will make a dedicated video because NITIE YourPedia के बहुत से बच्चा जाता है. पिछली बार भी I think 50 students from NITIE joined, 50 students of YourPedia joined NITIE last time also. तो वो सारा information I'll share with you, and tomorrow some videos of previous students are also being shared with you. So just go for this question. This is a equation. So if I talk about ideal gas equation, PV is equal to, let us say, RT. This is PV is equal to let's say nRT, or I'll say PV is equal to RT, or if I say this is P molar volume is equal to RT. P is ideal gas equation, R bar is universal gas constant, V bar is molar volume. Now ideal gas may we avoid something, and we need to make a correction to write real gas equation. In ideal gas, we assume that the space occupied by individual molecule is very less, and the space available to the molecule is the entire space of the container. Now this V is the space available to in the container. It's a volume of the container, let us say. Now we need to make a correction, some correction here for volume of molecule. Volume of molecule, that means एक्चुअल में तो क्या है, सारा स्पेस खाली थोड़े है. एक्चुअल में तो the particular molecule, whenever particular molecule wants to move around, entire space is not available for that molecule, but entire volume minus the volume of occupied by molecules is only available. So we need to subtract the volume of molecule. But in ideal gas, what do we assume? We assume that the molecule do not have volume. The size of molecule is very small. If we do not make that assumption, then size of the molecule is also to be used. I mean, the volume of the molecules is also to be calculated. So this is the correction for volume of molecules, and this one is the correction for pressure. Actually, we assume that molecules are not colliding. Molecules are far away. They are not colliding with one another. But in real life, in the real gas, molecules are colliding. If they are colliding, pressure is going to be increased. So ideal gas में and real gas में pressure increases. Ideal gas में and real gas में volume available decreases. So this one is the correction related to basically volume occupied by. So what is the B he is asking you? This. So which of the following statement, the constant B is related to volume which is occupied by gas molecules? That is what you need to see. So any real gas becomes ideal under what conditions? Very high temperature, very low pressure, and very low density. Very low density. At that, any gas becomes ideal gas. Any gas starts behaving as ideal gas. Done. Next question is this. Water in a 5 centimeter deep pan is observed to boil at 98 degrees centigrade. At what temperature will the water in 40 centimeter deep pan boil? Assume both pans are full of water and take density of water to be 1000. Now, what is the concept behind this question? 5 centimeter deep pan and 40 centimeter deep pan. What is the concept here? Now at 98 degrees centigrade, T is equal to 98 degrees centigrade, and now we are given here as P saturated for this temperature is 94.695 kilopascal. Now this is what is the which is data we have got. Now 5 centimeter ke upar we need to get a particular temperature here. We get some more data. Again, I'll come that this is data oriented question. We get P saturated as 84.6 kilopascal, and at temperature of 100 degrees centigrade he will provide you this data in the exam, 101.42 kilopascal. So in the exam he will provide you this corresponding to these temperatures, the saturation pressure. So these are the saturation pressure, boiling pressure corresponding to these temperatures. And from there, if these two data is provided to you, through extrapolation you get this data also. He will provide you 95 pe and 100 degree centigrade pe. What is the saturated pressure? Using this data, you will calculate 98 degree centigrade pe what is the pressure. This is the saturated pressure corresponding to this. Right? Now, this is basically boils at 98 degrees centigrade. So that means water in 5 centimeter deep pan is boiling at 98 degrees centigrade. Means what is the pressure at 5 centimeter now? P at 5 centimeter is this one, 94.695 kilopascal. That is what we are getting now. So understand what is giving. He's giving you the water is boiling at 98 degrees centigrade. So what is the pressure corresponding to that? He will give you these two data, and from there you will calculate at 98 what will be the saturation pressure. So that is at 5 centimeter deep. Now 40 centimeter deep is 5 centimeter deep plus rho g into 35, rho g into h. H is 35 centimeter more. So when you go down 35 centimeter, pressure increases. So what is the pressure now? Let's calculate it. 94.695 plus rho is 1000, 9.81, 0.35 मीटर ओवर 1000 करेंगे तो हमारे पास प्रेशर आ जाएगा 98.13 किलो पास्कल. Hydrostatic law. If I know pressure at 5 centimeter depth, I also know pressure at 40 centimeter depth. Why? Because I am to go 35 centimeter down. So if I add hydrostatic law pressure due to hydrostatic pressure rho g into 35 centimeter, but that is actually 0.35 meter, right? Rho g h, and this is in now kilopascal. So divide by 1000, you get kilopascal. Now what is the saturation temperature corresponding to this? And now T saturated at P40 will be equal to 99.61 degrees centigrade. Now you will say, sir, from where we will get this data? As I told you, this is the concept I'm giving you from NPTEL. When I'm to make this question for GATE, then what I'm going to give you? I'm going to give you a small table. In that table, I'm going to give you this value. I'm going to give you this value. I'm going to give you this value also in a table. You need to find something in the table. लाइक 95 100 के ऊपर आपको मिल गया, तो इसमें से इसके कॉरस्पॉन्डिंगली टेम्परेचर कितना होगा, दैट इज 98 डिग्री सेंटीग्रेड, अंडरस्टैंड, और 98 डिग्री सेंटीग्रेड के कॉरस्पॉन्डिंगली कितना होगा, दैट आई कैन फाइंड आउट दिस. नाउ कॉरस्पॉन्डिंग टू दिस प्रेशर, what will be temperature, that I am to extrapolate the table. So table extrapolation is a very important part of your exam. He will give you a table, you need to extrapolate from that particular table. So answer for this question was 99 degree centigrade. एक्स्ट्रापोलेशन कैसे करें? अरे एक्स्ट्रापोलेशन करना तो बहुत आसान है, क्या ट्रबल है? सपोज मैं तुम्हें टेबल दे देता हूं, सपोज आई गिव यू दिस टेबल, I told you that 95 डिग्री सेंटीग्रेड पे प्रेशर इज दिस, 100 डिग्री सेंटीग्रेड पे प्रेशर इज दिस. What is pressure at 98? Can't you find? So pressure at 98 is equal to pressure at 95 plus pressure at 100 minus pressure at 95 divided by 100 minus 95, difference of this, into 100 minus 98. 98 निकालना था हमें, तो this is 100 minus 98. See now how it is to be done. Pressure at 98 is pressure at 95 plus something, and that something is 3 units. So if in the 5 units pressure rises by this, in 3 units what will be rise in the pressure? So I have gone from 5 to 98 minus 95. So if 95 to 100, 5 unit mein this is the pressure rise, 3 units mein this is the pressure rise, these are 5 units, this is 3 units, this is the pressure rise in 3 units, in 3 units this is the pressure rise plus 95. ऐसे निकलता है. एक्स्ट्रापोलेशन सीख लो, दिस इज वेरी सिंपल, राइट? सो दिस इज हाउ एक्स्ट्रापोलेशन इज डन. बट आई टोल्ड यू लाइक एक्स्ट्रापोलेशन इज अ गुड कंसेप्ट, वहां से एग्जाम में क्वेश्चन आता है. लेट्स गो फॉर नेक्स्ट गुड क्वेश्चन इज दिस. A rigid container of 1348 meter cube volume. This is what? This is given as 1348 meter cube volume. This is 1348 meter cube is filled by some refrigerant of mass 10 kg and initial temperature minus 40 degree centigrade, and the container is then heated until pressure becomes 200 kilopascal. You have to find the final temperature and initial pressure. फाइनल टेम्परेचर एंड इनिशियल प्रेशर. थिंक ऑफ कैसे करेंगे इस क्वेश्चन को, जरा सोचो इस क्वेश्चन को. हाउ शैल यू डू दिस? दिस इज ऑल्सो अ गुड क्वेश्चन. किस तरीके से करेंगे? रिजिड कंटेनर मींस क्या है? कांस्टेंट वॉल्यूम हीटिंग, कांस्टेंट वॉल्यूम हीटिंग हो रहा है. रिजिड कंटेनर मींस कांस्टेंट वॉल्यूम हीटिंग इज गोइंग ऑन. हीटिंग जो हो रहा है कांस्टेंट वॉल्यूम हो रहा है. अब लेट अस कैलकुलेट व्हाट इज V1 is equal to V2 is 1348 मीटर क्यूब. 1 पॉइंट नॉट, ये तो बहुत ज्यादा हो जाएगा. 1.348 मीटर क्यूब. यस, दैट इज द वॉल्यूम. एंड व्हाट इज द स्पेसिफिक वॉल्यूम? स्पेसिफिक वॉल्यूम इज V by mass. तो मास इज 10 किलोग्राम, तो दिस मच मीटर क्यूब पर केजी, this much meter cube per kg is the specific volume. Now if you get the data, तो आपके पास ये एक saturation ग्राफ में आएगा. So you will find that corresponding to minus 40 degree centigrade. Initially it was at minus 40 degree centigrade. तो आपके पास saturated pressure is 57.25 kilopascal. So corresponding to minus 40 degree centigrade, this is the value which is coming, and then it is heated to 200 kilopascal. This is heated to 200 kilopascal. So saturated pressure corresponding to minus 40 was this, and then it is heated to 200 kilopascal. You have to find out the initial pressure. So initial pressure P1 is saturated pressure at what temperature? Minus 40 degree centigrade. Right? So what is that coming? 51.25 kilopascal. And now P2 is this. P2 is given as 200 kilopascal and V2 is given as 0.1348 meter cube. So corresponding to this is 1, this is 2. Corresponding to this, temperature comes out to be T2 comes out to be 66.3 degree centigrade. Again आपके पास इसके लिए information was required, but let me tell you, आप इसको कॉपी पे लिख लो. जब वो आपको information देगा, आपको data देगा, तो you can calculate this question on the basis of this. You can solve this question on the basis of the data or table which he will give you, but at least we should do the questions which are related to this. So constant volume heating, rigid container. Heating in the rigid container is constant temperature heating process. Next question, please read. Again, a rigid tank with volume 1.8 meter cube contains 15 kilogram of saturated liquid vapor mixture of water at 90 degrees centigrade. Now the water is slowly heated. Water is slowly heated now. Determine the temperature at which liquid in tank is completely vaporized. Determine the temperature at which liquid in the tank is completely vaporized. Read this question carefully. What is this? This is a rigid tank. अब देखो, अगर मैं TS diagram बनाऊं, if I make TS diagram, then it is again the case of your, let's say this is P1, this is P2. Volume is given V1 as 1.8 meter cube. Mass is given 15 kg. So specific volume can be 1.8 by 15. That comes out to be 0.12 meter cube per kg. And because it is the rigid tank, specific volume is going to remain same. Saturated liquid vapor mixture 90 degrees centigrade. So now water is slowly heated and you have to find out the temperature at which the liquid in the tank is completely vaporized. So now this particular is the final state. That means this was V1, this was V2, this is the state 2. You have to find out the T saturated corresponding to V2, which is on the saturated vapor line. Right? So corresponding to T saturated corresponding to now V2, which is 0.12, comes out to be equal to 202.9 degrees centigrade. So this is the answer for this. So try to understand from where this he will frame the questions. See, now only half an hour lecture is left. Don't worry, we have done majority of questions. मेरे को लगता है half an hour से भी कम बचेगा. So just attend it and complete it. So no further break. Yes, good evening Apan Raj. Welcome on platform of YourPedia. So Apan has also joined now. Good. So let's go for next question. Okay, answer this question. Answer this question. First law of thermodynamics is applied to a system which obeys dq is 0, dw is 0. Correct option which characterizes this system. Choose karo A, B, C, D. What is the answer? Let's make it more interesting. Tell me what is the answer for this. Tell me what will be the answer for this. Okay, now let's go for first law. dq is equal to delta E plus dw. If dq is 0, that means it is insulated or isolated. dw is 0, delta E is also 0. That means E1 is equal to E2 constant. So that means E is constant and the system is isolated. Answer should be D. D should be the answer. Rahul, we are providing both the things. We are providing workbook also. We are providing the PDFs also. If you only want to take questions, you can take that also. And if you want to take like workbook where you want to write, some space and then you're writing something like that. Some of the students wants to take printout and write there only. In my opinion, we will provide you workbook one day before. You go through that. Next day teacher comes and he solves it. You sit there. You have gone through the questions, and by the end of the lecture, 5, 6, 7 hours, 100 questions you completed. That is how we should best go for it, right? So we will provide you both questions also and workbook also. This is very simple question. So as you know, Cp minus Cv is equal to R. Answer choice is B. Answer choice is B. It can be characteristic gas constant also. It can be universal gas constant also, depending upon what is Cp. Now H is equal to U plus Pv. You know that dH is equal to du plus Pdv plus Vdp. You know that also, right? You know this particular thing also. And also we can write it as du plus Pd into Pv. But Pv can be written as RT. So we can also write dH is equal to du plus R dt. Right? We can write that also. dH is Cp dt. This is Cv dt plus this is R dt. So Cp is equal to Cv plus R. Now many students keep on getting confused. Sir, this R is characteristic gas constant or universal gas constant? That is what students keep on getting confused. Now you need to see what is the unit of CpCv. Now if this unit R is universal gas constant, value of universal gas constant is 8.314, this joule per mole Kelvin, let us say. Then this Cp and Cv are also joule per mole Kelvin. They are also in the same unit. So if this is universal gas constant R, then they are also having unit of joule per mole Kelvin. Otherwise, Cp, Cv are kilojoule per kg Kelvin, right? So this is what you need to be very, very careful. What value is given? Characteristic gas constant or universal gas constant? It can be anything, right? Okay, let's go for next question. This is the next question. A rigid container equipped with stirring device contains a rigid container equipped with stirring device contains 0.5 kg of motor oil. Determine the rate of internal energy increase per unit mass when heat is transferred to oil at rate of 1.5 watt and 2 watt of power is applied to the stirring device, right? Okay, don't worry, you will get all the questions. These are the 100 questions, good question thermodynamics. We'll have many classes, don't worry. You'll get all the entropy questions and everything. We have done a couple of questions of entropy, by the way. Okay, now how to solve this question now? How to solve this question? Now this is dq is equal to delta u plus dw, right? So dq is given as 1.5. Heat is supplied to the oil, 1.5 watt, and 2 watt of work is applied to the stirring. Work is done on the system. So minus 2 watt. So delta U is 3.5 watt. Very simple question. But you know, question is not in watt, it is kilowatt per kg. And what is the mass given? Mass is 0.5 kg. So what will be rate of internal energy increase per unit mass? So delta U by M, how much is that? 3.5 over 0.5, 7 watt per kg. 7 watt per kg. Right? 7 watt per kg. So this is kilowatt. I don't know from where kilowatt came. It has to be watt only. So that was the question number 72. We are left with very less questions now. Right? Let's go for next question, 73. Question number 73. An insulated rigid tank initially contains 2 kg of helium at 40 degrees centigrade and 350 kilopascal. Paddle wheel with power rating of 15 watt is operated within tank for 30 minutes. Determine the final temperature of the helium gas. So how shall you calculate this question now? Again, dq is 0 because insulated rigid tank. Now that means dq is equal to delta u plus dw. If this is 0, that simply means delta u is equal to minus dw. Now paddle wheel with a power rating is 15 watt is operating for 30 minutes. So how much is dw now? dw is coming out to be, now power rating is 15 watt and for 30 minutes it is operating. So this much joule of work, 15 watt into 30 minutes into 60, that is the power. So how much is coming? 27,000 joule, and it is negative. Work is done on the system. Negative becomes positive. This 27 joule, this is negative. If this is negative, on the other side it will become positive. Delta U will increase. What is delta U? Delta U is mCV delta T, which is 27,000. Right? CV is given. M is 2 kg. And if you divide by 10,000, so delta T is 27,000. Mass is 2 kg, 3.11 into 1000 to get the, this is basically CV is in kilojoule. So I need to take that in joule. Delta T is coming out to be 4.338. 4.338, and hence I want to find out T2. T1 was 40. So T2 is 44 degrees centigrade. So I think is the same answer twice given. 44 degrees centigrade. That was 73 question. Yes. Perfect. Now we hit the next question. Another good question. We are getting really good questions today here. So this question is, a piston cylinder device which initially contains 0.5 meter cube of nitrogen gas at 400 kilopascal, 27 degrees centigrade. Electric heater within the device is turned on and is allowed to pass a current of 2 ampere for time t from 120 volt source. Nitrogen expands at constant pressure by resistance heater, and heat loss of 5 kg occurs during the process. right? So this is all is given to us. Let me make the diagram and let me give you this diagram here. So this is a kind of situation given to us. There is a heater and there's a heat loss also, and there's a work, electric work also. Initially V1 is given as 0.5 meter cube and P1 is given as 400 kilopascal. T1 is given as 300 Kelvin. T2 is given as 27 plus 30. So this is 57 degrees centigrade. It was 27 and there is a rise in 30 degrees centigrade. So that comes out to 57 degrees centigrade, which is 330 Kelvin. Final temperature is also given. And there's a heat loss of 5000 joule. That is what is given to us. So you have to find out what is the time required for heating. You have to find out what is the time required for heating. Tell me what is the time required for heating. Right? So let's calculate it. Electric work, how much is electric work? This is V into I into T. V is how much? 120. I is 2 into, let's say, time is T. So dq is equal to delta U plus dW. So dq is minus 5000. Delta U is mCV delta T plus this is coming out to minus 240 into T. Negative because it is being done on the system. We need to take CV. So internal energy. So CV is Cp minus R. You can calculate that value also, CV. And how do we calculate mass? So mass can be obtained as PV over RT. P is given, V is given, T1 is given, R is also given to us. So mass can also be obtained, which is coming out to be 2.45 kg. That is a mass, 2.45 kg mass, heat minus 5000, mCV delta T is given as 30 degrees centigrade. CV can be obtained from here, T can be calculated. T can be calculated. Solve it this question for you. So please solve this question and see what is the answer coming. Yes, so many questions are already done by Vishal sir. And I think this question was also done. Yeah, 5 minutes. Okay, done. So I think answer is 5 minutes for this. This question was already done. Question number 75. Has Vishal sir done this also? Okay, okay. Let me see what he has done. Let me tell you, the answer for this question is A and B. Write this question. I'll explain little later, but you write this answer. Answer for this question is temperature specific volume, pressure specific volume. Answer is A and B. Answer is A and B. For this question, please write in your copy. That is the answer. Question number 76. Write the question number 76 now. A temperature of water is increased from minus 12 degrees centigrade to 105 degrees centigrade, keeping the pressure constant at this. So he's talking about the sublimation and any idea about the this phase diagram for water? So in the phase diagram of water, this is the sublimation. This is the sublimation curve. This is the vaporization curve. This is the fusion curve. This one is the critical point. This one is the triple point. You know, this is the PT diagram for water. Phase diagram for the water. Phase diagram for the water, you have triple point, you have critical point. This side, you know, solid. This side, you know, vapor or gaseous state. And this side is liquid state. So fusion is solid to liquid, vaporization is liquid to vapor, sublimation is solid to directly vapor or gaseous state. Now I want to give you some data. Triple point pressure at triple point is equal to 0.611 kilopascal. Pressure at triple point is this. अभी ये कितना प्रेशर दे रखा है हमें? Pressure given is 0.3 kilopascal. So P is less than P of triple point. इसका मतलब हमारे पास जो प्रेशर है वो यहां पे कहीं दे रखा है, राइट? This is given pressure. And we go from many very less degree centigrade to 105. Low temperature to high temperature we go. तो पहला इंफॉर्मेशन, प्रेशर इज लेस देन ट्रिपल पॉइंट प्रेशर. ऐसे क्वेश्चन इसी तरीके से तुम्हें गेस करने पड़ते हैं. सो प्रेशर इज गिवन लेस देन ट्रिपल पॉइंट, यहीं पे प्रेशर लिमिट है, और टेम्परेचर वेरीज फ्रॉम वेरी लो टू वेरी हाई. सो इट इज डायरेक्टली basically sublime directly from solid to vapor phase. Answer is A. Goes from solid state to vapor state. It's a good question. Note it down. This is a good question, and this was also mentioned at couple of points in the NPTEL assignments. Is this clear? So phase diagram of the water you will do. There are 3 lines. 2 important points are there: triple point and critical point. You should know what is triple point, what is critical point. That you should be aware. And then what is the critical triple point temperature? What is the triple point specific volume? What is the triple point temperature? What is critical point temperature and pressure? That also you should know. Next question is also related to this. Solve करो इसको. अब इसको solve करो. Let's see whether you do it. Solve this question. This is also a related question. I'm very sure now you will solve this question. अगर पिछला question तुम्हें समझ आ गया तो you can solve this question also. Okay, now again PT diagram I am giving you. I am sharing with you again the same phase diagram. अभी हमारे पास जो दे रखा है pressure, that is 200 kilopascal. Any idea what is that? This is critical point is 221 bar. 221 bar. 1 bar is 100 kilopascal, right? So now state 1 is given like this. This is the triple point. We go from very less temperature to very high temperature. Which one among statement is correct? So ice melt into liquid and remain liquid till the temperature reaches 105 degrees centigrade. So why it is liquid only? Any idea? Water boils at 100 degrees centigrade at 1 bar pressure, 1 atmospheric pressure, right? At 1 bar pressure or 100 kilopascal, at 100 kilopascal, this is the boiling temperature. Now the pressure given is 2 bar. This is 2 bar pressure, 2 atmospheric pressure. So at 2 bar, temperature boiling will be more than 100 degrees centigrade. That means हम vaporize तो नहीं हुए, boiling तो नहीं हुआ. This is not a boiling. Understand this carefully. I have not gone to this stage. See the understand the concept. At 1 bar pressure, 100 kilopascal, temperature water boils at 100 degrees centigrade. Now the pressure given is 200 kilopascal, 2 bar. It will not boil at 105 degrees centigrade. It will remain in liquid state. So this is the solid and this is liquid. So this actually ice will melt into liquid and remain as liquid. It will not get into vapor state. So answer is B. So this is B only. ये दोनों ही बहुत अच्छे क्वेश्चन थे. पिछला क्वेश्चन एंड दिस क्वेश्चन आर रियली गुड. कंसेप्ट यूज करो ट्रिपल पॉइंट का और क्रिटिकल पॉइंट का, एंड ये थोड़ा सा लॉजिक. एट व्हाट टेम्परेचर वाटर बॉयल्स एंड नॉट. Question number now 78. You can answer this question. Multiple statement question. Tell me what are the answers. 78 number, what is the answer? Answer for this is, this becomes the behavior of real gas. The ideal gas becomes real gas. Real gas becomes ideal. What are the conditions? Ideal gas relation closely approximates the behavior of real gases. Okay, now so real gas becomes ideal at pressure very low, temperature very high, density very low, because P is equal to rho RT. You know, P over RT. If P is very low, T is very high, density is very low. Low density means the molecules will not interact. There will be huge space available. For the same mass, you'll get a lot of volume. So huge space is available. Intermolecular interaction is not there. So low pressure and high temperature and low density. That is answer. Low pressure, high temperature and low density also. That is also the part of this. So mark it because this is important, right? Determine the phase of water for each of the following states. Now, this is a purely data question, but I am giving you, you will check it on your own. The answer for this is C. C को mark करो और आपने इसको steam table पे check करना है. You will check this on the steam table. You are going to check this in the steam table. You are going to check this on the steam table. I think next question number 80, 81, 82, 83 are covered by Vishal sir for you. These questions have already been done by Vishal sir for you. And I take you to directly now question number 87. All other questions have been done by Vishal sir during the gap which we took. He has solved this question for you. Let's answer 87 question fast. The degree of completion of chemical reaction is given by second law of thermodynamics. Second law only tells you about, possibility of the reactions. Second law of thermodynamics tells you about the possibilities or direction of flow of some particular reaction. So this is the second law which tells you about the possibility of reaction, and it is a directional law or qualitative law. Feasibility or possibility is told by second law of thermodynamics. Done. Next question 88. So the answer for this is A. Mark this. Gibbs-Helmholtz equation. I just want to Gibbs-Helmholtz equation. This is also the way it is written. कॉपी पे लिख लो G over temperature, H function over temperature plus curly G over curly T. Now if I partially differentiate, you know, G over T at particular pressure, this comes out to be minus G over T square plus 1 by T curly G over curly T constant pressure, right? And if you put these values here now, if you compare these two values from these two, from this equation, you will get this as answer, because curly G over T by curly T at constant pressure will be equal to minus H over T square. Just note down these three things, three lines. Right? So this is how it is to be done. Helmholtz function. Okay, so let me cover these questions and I'll discuss at the end कौन सा question बच गया. We'll see that later on. Has this been done by Vishal sir or not, this question? So I'll come to this question little later. First let's go to question number 90. एक बार कर लेते हैं सारा, फिर then I'll analyze how many questions are left and all. Entropy of the system. Read this question and tell me what is the answer for this. Read this question carefully. Second law equation is, equation of second law says entropy change is dq by t plus ds generation. These two are path function. Remember, this entropy change is a point function, but entropy generation is a path function. Remember that always. Now, in a closed system undergoing irreversible process, ds generation is always positive. Entropy of the system, if it is irreversible, this is positive. Now dq by t can be positive, it can be negative, it can be equal to 0. Hence ds also can be positive, can be negative, can be equal to 0. So if ds generation is positive and this one is negative, it may be possible that ds can be negative, because if heat rejection is more, then ds will be negative. वो आपको किसको बोल रहा है? सिस्टम को बोल रहा है, isolated system नहीं बोल रहा है, because if it is isolated system, then dq is 0. If dq is 0, then ds is always positive. So he is not talking about isolated system, he is talking about any system. Answer for this is D. Mark कर लो, D is the answer for this. D is the answer for this. Second law of thermodynamics is very important, and this ds generation is also called the entropy generated, that is entropy change of universe. Entropy change of universe, ds generation is also called that. During isothermal compression process, entropy of a fixed mass of ideal gas. During an isothermal compression process, entropy of a fixed mass of ideal gas. Isothermal compression process, बताओ क्या आंसर आएगा? Isothermal compression कैसे प्लॉट करेंगे? PV डायग्राम पे हाउ शैल वी प्लॉट isothermal compression. And how shall we do it on TS diagram? Isothermal compression. Make sure you understood it. This is PV and TS diagram, isothermal compression process. You know how isothermal process compression is plotted on PV diagram. तो क्या आ जाएगा, dq is equal to delta u plus dw. अब आइसोथर्मल है तो ये तो जीरो आ जाएगा, राइट? ये जीरो आ जाएगा. यहां पे कंप्रेशन है तो ये नेगेटिव है. अगर ये नेगेटिव है तो dq भी नेगेटिव हो जाएगा, dq भी नेगेटिव हो जाएगा. एंड dq अगर नेगेटिव है, dq होता क्या है, dq इज इक्वल टू tds, तो ds भी नेगेटिव हो जाएगा. यू अंडरस्टूड लॉजिक? फर्स्ट लॉ, कंप्रेशन है तो dw इज नेगेटिव, आइसोथर्मल है डेल्टा u इज जीरो, this is zero, this is negative, this is negative. If this is negative, TDS is also negative. T cannot be negative, that is absolute temperature. So DS is negative. DS negative means entropy will decrease. That is the meaning of it. Entropy क्या हो जाएगा, decrease हो जाएगा. Done? Okay, let's go for question next. Van der Waals constant for three gases is given as this. पहले तो तुम्हें बता दें वैन डर वाल होता क्या है. P प्लस A बाई वी स्क्वायर इंटू V माइनस B इज इक्वल टू RT. इसमें नॉर्मली R जो होता है ये यूनिवर्सल गैस कांस्टेंट है. दिस इज यूनिवर्सल गैस कांस्टेंट एंड दिस इज मोलर वॉल्यूम, वॉल्यूम पर यूनिट मोल. दिस इज कॉल्ड molar volume. Normally A and B are constants. अब एक चीज याद रखना, at critical temperature, at critical point, you know what is critical point? At critical point T critical is 8A over 27 RB. R here is universal, this characteristic gas constant. V critical is 3B, right? And that simply means T critical is proportional to A over B and V critical is proportional to B. This information was required to solve this question. So critical point के ऊपर critical temperature is 8A over 27 RB, right? Now let's calculate for each gas A, B and C what is A over B, because T critical is proportional to A over B. किसके लिए B सबसे ज्यादा है? B is maximum for this, तो C gas has maximum volume. Highest molar volume जो है that is for C, highest molar volume is for C. VC is highest for C. So highest is VC. Now VC maximum for gas C. A और B निकालेंगे तो A के लिए आएगा 148.148. This is 400. This is 187.5. मैक्सिमम B के लिए आ गया. So TC is maximum for B. TC is maximum for B. तो टेम्परेचर मैक्सिमम किसके लिए है? B के लिए. वॉल्यूम मैक्सिमम किसके लिए? C के लिए. मोस्ट आइडियल बिहेवियर कौन करेगा? गैस विद मिनिमम वैल्यू ऑफ A. Gas with minimum value of A will be behaving as ideal. So A is going to behave as ideal gas. A सबसे कम होना चाहिए. So this is how you have to answer this question. So if van der Waals gas constants are given to us, A, B are given to us, critical temperature and critical volume corresponding to critical point should be known to us. Highest Tc, largest molecular volume, these terms should be known. Next question is also related to this. Critical compression factor, compressibility factor at critical point. ये आपने किया भी होगा. That is nothing but PV over RT. Right? So what is P critical? A over 27 B square. What is V critical? 3 times B. What is T critical? 8A over 27 RB. When you put all these values into this, you get ZC as 3 by 8. If you put all these values, this is what you get. So note kar lo isko. It's a compressibility factor of van der Waals gas at critical point. So compressibility factor is defined as PV over RT. Yeah, 3 by 8 is the answer. That is correct. So you know the meaning of this. That part is correct. Okay, let's go for next question now. Question number 94. Could 25 gram of argon gas in a vessel of volume 1.5 meter cube exert pressure of 2 bar at 30 degrees centigrade if it behaved as perfect gas? If not, what pressure would it be? पहले तो इसको आइडियल गैस की तरह से लेते हैं. परफेक्ट गैस मींस आइडियल गैस. सो आइडियल गैस की तरह से एनालिसिस करते हैं. आइडियल गैस P is equal to PV is equal to nRT. N is the number of mole, R bar is universal gas constant. तो number of moles कितना है? Argon gas का molecular mass is 40 if I'm not wrong. So this mass is given as 25 gram over 40, 8.314. Temperature is 303, 30 degrees centigrade. And volume is given as 1.5, right? That is what is the P value we are getting. Now we want to get it as in terms of kilopascal से तो आ ही रहा था. ये आंसर आएगा kilopascal में and 100 से डिवाइड करेंगे तो मेरे पास आ जाएगा ये बार में. 10.5 bar is the answer for this. If you solve it, you get 10.5 bar. आइडियल गैस में नंबर ऑफ मोल्स हमने निकाल लिया एंड यूनिवर्सल गैस कांस्टेंट इज 8.314 किलोजूल पर किलोग्राम मोल केल्विन. सो दिस इज हाउ वी कैलकुलेटेड इट. राइट नाउ फॉर कैलकुलेटिंग इट van der Waals gas, we need to have data. We need to have value of A, value of B for this gas. तो ये लिख लो, you can solve it, but in the GATE exam he will give you this data. He gives you A as 1.337, B as 3.2 into 10 to the minus 2, and he will give you units also. So P plus A over V square, V minus B is equal to RT. That is how we calculate it. And this V bar is molar volume. This V over number of moles. Number of moles हमने कितना निकाला था? 25 by 40. That comes out to be 0.625. So this V bar is nothing but 1.5 over 0.625. वो हमें यहां पे रखना है. And then we have to calculate the pressure. So remember that in van der Waals gas equation, this V bar is a molar volume. Volume per unit number of moles. A and B he will give you in the exam, in the question itself. He will provide you that in the question. Ideal gas and van der Waals, these things are important. So answer for this is B. You can calculate, you will find it almost same, 10.4. 10.4 के आसपास आएगा, exactly same नहीं आएगा, 10.4 आएगा. It is very close call. See, let me ask you, it cannot be same. अगर तुम इंटेलिजेंट गैस लगाते, let me ask you a question. आइडियल गैस एंड रियल गैस में प्रेशर ज्यादा किस में होना चाहिए? Understand? So this A factor actually tends to decrease the pressure here. So real gas में ये आपका कम हो जाएगा, आइडियल गैस में ज्यादा होता है. इट कैन नॉट बी आइडियल गैस में कम और रियल गैस में ज्यादा, इट कैन नॉट बी देयर. सो वहां से भी तुम इसको गैस लगा सकते थे. यू कुड हैव मेड अ प्रॉपर गैस इन दैट. A sample of hydrogen gas was found in rigid container. ये एक पार्ट इसमें ऐड करना है. In the rigid container. Rigid container में दे रखा है. This is given in rigid container. Pressure of 125 kilopascal when temperature was 23 degrees centigrade. What can its pressure be expected when temperature is 11 degree centigrade, 11 degree centigrade? How to do it? P1 125 kilopascal, T1 23 degree centigrade or 296 Kelvin. P2 we want to find out, T2 is 11 degree centigrade, 289 Kelvin. Now V1 is equal to V2. Why? Because it is rigid container. So आपको कुछ नहीं करना है. P1 over T1 is equal to P2 by T2. So P2 you can calculate, that comes out to be 120 kilopascal. Next question. Which law of thermodynamics provides the basis of measuring thermodynamic property? Which law of thermodynamics provides the basis of measuring thermodynamic property? Yes, what is the guess? Any guess you want to make? Zeroth law. आप बोलोगे सर जीरोथ लॉ तो टेम्परेचर मेजर करता है बस, जो एक थर्मोडायनेमिक प्रॉपर्टी है, नो डाउट. So actually zeroth law gives you method to measure one property, and in terms of those properties we can also measure other things, right? Like if you measure temperature, then if volume measurement already we know, pressure can be measured, P is equal to mRT. So if you measure one property, from there you can also link with other properties. I think that is the question he framed, but certainly other are not the answers. Third law gives you entropy, does not measure entropy. एंट्रोपी को थर्ड लॉ मेजर नहीं करता है, थर्ड लॉ उसको डिफाइन करता है. इट डिफाइंस, लाइक फर्स्ट लॉ डिफाइंस इंटरनल एनर्जी. यू नो इंटरनल एनर्जी इज mCV T2 minus T1. If I ask you a question, which law defines internal energy or which law gives you concept of internal energy, you will say, sir, first law. Why? Because this is first law. We were already knowing what is heat, we were already knowing what is work, and in terms of that we defined the internal energy of the system. So first law gave the concept of internal energy. Now my question is, which law tells you to measure internal energy? Which law helps you to measure internal energy? Measurement in terms of temperature. वही तो मैं बता रहा हूं. तो internal energy is a thermodynamic property. How do you measure entropy? S2 minus S1, mCp log of T2 by T1. Which law helps you to measure entropy? Sir, if we want to measure entropy, we need to measure temperature. And which law tells you to measure temperature? Zeroth. So indirectly, which law tells you to measure the entropy? Zeroth. Which law defined entropy? Second law. Which law defined internal energy? First. That is how you need to understand. So you should be very clear. Answer is zeroth law. Solve this question now. We are reaching to the end of wonderful session. 10 more minutes left, and I'm really thankful to all of you. So tell me what is the answer to this. Rigid container equipped with stirring device contains 5 kg of motor oil. I think this we have already done, or no? So M is 1.5 kg. dq is equal to delta U plus dW, but everything is in watt. So let's do this. Heat is transferred, that is 1 watt. Work is done, applied to stirring, minus 1.5. Work is done on the system. It is like this. Heat is transferred, dq dot. Work is done, dw dot. This is negative, this is positive. And what is delta U dot? 2.5 joule per second. But question is different. It is not in joule per second. It is in joule per kg second. So we need to divide it by 1.5. Comes out to be 1.667 joule per kg second. That is the answer. Done? It was a simple question. Let's go for next now. We are reaching the end of our wonderful session today. Air goes through polytropic process from 125 kilopascal 325 Kelvin to 300 kilopascal 500 Kelvin. Find the specific work in the process. What will be the specific work done in the process? Looks like it is a compression process. PV raised to power n is equal to constant. This is 300 kilopascal. This one is 125 kilopascal. So P1 V1 raised to power n is equal to P2 V2 raised to power n. What is V1? P V1 is equal to R T1. So V1 is R T1 by P1. If you put all the values, R is 0.287. R for air is 0.287 kilojoule per kg Kelvin. P1 325, T1 to 325, P1 125 kilopascal. V1 we get is 0.7462 meter cube per kg. That is specific volume at 1. Similarly, specific volume at state 2 is R T2 by P2. That comes out to be 0.47833 meter cube per kg. That is V2. So what is asked is specific work in the process. How do we calculate specific work? But for that we need to find out N. N is log of P1 by P2 over log of V2 by V1. ये कैसे आ गया? यहाँ पे log लोगे तो आपके पास log of P1 plus n log of V1 is equal to log of P2 plus n log of V2. Eventually n की value we can calculate like this. All of you know that formula. So how to calculate now value of n? This is the value of, this is how you calculate value of n. I hope you know that, right? Log of P1 plus n log of V1 is equal to log of P2 plus n log of V2. Take all the terms of n one side and on the another side. जब हम वैल्यू रखेंगे तो n इज कमिंग आउट टू बी 1.969, लिख लो कॉपी में, n is coming 1.969. Now what is specific work? How to calculate specific work? P1 V1 minus P2 V2 over n minus 1 kilojoule per kg. Specific because per unit mass. N is known to us, P1 is known to us, V1 is known to us, V2 is known to us, P2 is known to us. वैल्यू पुट करो तो आपके पास आएगा डी चॉइस, माइनस, नेगेटिव, बिकॉज इट इज कंप्रेशन. So because it is compression, it is going to come negative for you. Yes, it is negative. So almost we are hitting the century. 2 more wickets, 2 more runs actually. So be there. We should hit the century now. So let me thank all of you first, those who were there entire day. It is 7 hours marathon session, 100 questions. Believe me, these are really good questions, and I'm thankful to you for encouraging the mentors here. So question number 99, 98, I think 99. Fixed mass of saturated water vapor at 300 kilopascal is isothermally cooled. So what kind of diagram we are going to get? TS diagram. So this is 300 kilopascal. Saturated water vapor at 300 Kelvin. So it was like this, right? Cooled until saturated liquid. So yahan tak pahunch gaya. Simple. This is 1, this is 2. What is heat rejected? This is HFG only. This is nothing but HFG. Right, so this is all you have to calculate is, I think he will give you some data. So HFG at 300 kilopascal, उसके correspondingly जो value है, that is 2163. So this is again sort of data oriented question. Okay, so let's go to our now century. This comes the 100th question for the day. So read this question. Air is contained in a variable load piston cylinder device equipped with paddle wheel. Initially air is at 500 kilopascal, 27 degrees centigrade. Paddle wheel is now turned by an external electric motor until 50 kilojoule per kg of work has been transferred to air. During this process, heat is transferred to maintain a constant air temperature while allowing gas volume to triple. तो कैसे solve करेंगे? Let's try to see this. We are given P1 as 500 kilopascal. T1 is 300 Kelvin, 27 degrees centigrade. Work input is 50 kilojoule per kg. This, it is given external electric motor transfers this much work to the air. Now volume becomes V2, becomes 3 times V1. R is known for air, 0.287 kilojoule per kg. Kelvin. Temperature is constant. This data information is given to us. Now how do you calculate the heat is transferred to maintain constant air temperature while volume to get, and this is piston cylinder mechanism. So how do you calculate PDV work? This is RT log of V2 by V1. Isothermal work, constant temperature PDV work, how do you calculate? RT log of V2 by V1. And you people are now having sufficient basic knowledge. You are only requiring small hint to solve the question. So work, isothermal work, the formula each one of you should be knowing. I cannot tell you the formula for this. 0.287 into temperature log of 3. This one is 3. So what work we get is 94.59 kilojoule per kg. That is the exit work or output work. Now what is W net? W net is W output minus W input. 94, so this becomes 44.59 kilojoule per kg. But he's asked you amount of heat transfer. But you know one thing, for isothermal process, the work done and heat is same. If it is isothermal process, then work done and the heat is same. Why? Because delta U is 0. So answer for this is 44.6. 44.6 will be the answer for this. Done? What about this question? So I'll just take one or two more and we finish it up. Which of the following statement is not correct related to Gibbs phase rule? Guess maro kaun sa hai? We have done it. Just guess. Which of the following statement is not correct related to Gibbs phase rule? मैंने आपको बताया था कि वो only extensive properties, ऐसा नहीं है. It is for intensive properties. Gibbs phase rule is for intensive properties. F is equal to C minus P plus 2. This is the intensive properties. Degree of freedom is used to calculate the intensive properties. C is the number of components, P is the number of phases. Okay, because 3 questions are not done, I am going to give you 2 additional questions, right? So these 3 questions will be done, don't worry. Question number 102. Which of the following is true? Give the answer for the last question of the day. What is the answer for this? Which of the following is true? Isolated system of the universe. You know, let me tell you, second law, equation of second law of thermodynamics is this. This is the equation for a property. For isolated system, if the system is isolated, dq is 0 and ds of the system is ds generation, and this becomes ds of the universe, and it is always positive. For isolated system, this is always greater than equal to 0. Why equal to? Because if it is irreversible, ds generation is 0. For reversible process, ds is equal to 0. For an irreversible process, ds is greater than 0. Actually, for an isolated system, you get ds for the system, depends what he is giving. For reversible process, ds generation is 0, not ds is 0. For reversible process, ds is not 0. For irreversible process, ds generation is positive. So if this is ds generation, it is correct. Otherwise, A is the right answer. Right? First, you understand this. ds generation is 0 for reversible, positive for irreversible. These are the 2 options. For isolated system, dq is 0. Now for system, ds can be positive, can be negative, it can be 0. That is what is to be understood. 99, what is there in 99? No, this is nothing. This is, I think, some data was required. This is at 300 kilopascal. Go to steam table and find HFG. That is the value. Okay, so it is 7 hours, and I'm really thankful all of you gave your time to me today, and we could complete this 100 question task. Never was done earlier, so it was a challenge for us also, whether we will be in position to pull it properly or not. We made good questions there, and we send it to you, and I think this can work. It can work, and now till your gate exam we will make it even more streamlined, so that we don't make any mistake. You don't not waste your time, and our mentors will be motivated today, because when the number is a 75 or 75 students are attending, teacher is always motivated, that is his energy level, and then he gets energy from there. So we will we will keep on providing you more classes, and we will make it more streamlined. Try to get the PDFs from YourPedia. Give your suggestions also. You can give your suggestions. We'll keep on improving it. Good questions. Sending you PDF before the class. You please make yourself available for the class. That's it. Sit in the class 5-6 hours. One particular subject is done, and we never know if some question directly pops up in the exam, because it is competitive, and this may pop up directly in the question. 80, 82, 89 we will cover in the next class. I think it's a too long duration now, 10 years, so we'll do that. Not a problem, right? Chalo, thanks a lot to all of you, and obviously one more expectation from you. You please share this information with your friends also, because more the number of students attending, it is always motivational for us all here. Thank you, and thanks for that hurt. Thank you.